Welcome to this Visual Basic tutorial. Before we dive into today's lesson on Visual Basic programming, make sure you have Visual Studio installed on your computer. You can find the Visual Studio installation link below. This course is led by Bob Tabor from Developer University, who will guide you through each step of the learning process. Now, let's get started.
Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, I want to show you how to build a super simple Visual Basic application, a Hello World application. It'll simply display the message Hello World in a console window on your computer. Now, I'm not going to attempt to even explain why I'm doing what I'm doing. The focus will purely be on what and how I'm doing it. In other words, I want you to focus on the workflow at this first pass. How to create a new project. Where do you type your Visual Basic code? How do you test your application and actually see it running as you're building the application? What do you do if you actually mistype code? How do you fix the problems that pop up? And how do you save your project to disk and things like that? And so for now, just try to follow along and do exactly what I'm doing. Don't worry if something doesn't really make sense just yet. That's really what the rest of this course is for. We'll get to it. I promise we'll explain everything. In the next few lessons, we're going to dissect this tiny little application that we're going to build here, and I'll explain at that point why we did what we did, the purpose behind everything. Again, like I said in the introduction to this course, I'm going to assume that you have some version and edition of Visual Studio already installed. Even if your Visual Studio looks a little bit different than what you see on my screen, that's okay. The basics are the basics no matter what. So let's go ahead and get started. And I'm going to go to the File menu and select File, New Project. That'll pop open the New Project dialog. And this is important. If you get lost on this step, you're going to be lost, significantly lost. So take a moment and really pay attention to what you're doing here. Make sure you're in the installed templates here on the left-hand side. You're going to see a number of languages and tools over here now beneath the word templates. You must make sure that you have selected Visual Basic. If not, you're going to wind up with a weird template and you're not going to know what to do next. I've gotten enough comments through the years to know that this is a frequent mistake that people make. So make sure that you select Visual Basic, and then you'll see a list of template types. And we'll talk about what templates are a little bit later in this course, but for now we just want to make sure to select Console Application. We're going to use the console application template pretty much exclusively throughout this entire course until we get to the very end. And so you'll always want to make sure to choose console application. The next thing we're going to do is give our new application a name. Now, when we change the name, there will be some changes to the solution name here below it. And so I'm going to type in the word hello, capital H, hello, capital W, world. Notice that I didn't put any spaces between the words hello and world, okay? And then you'll see that that same word is typed here. I'll show you what that means a little bit later on. By default, it's going to put your new projects into your documents folder. And so for me, my user on this computer is Bob, and Bob has a documents folder. You're probably familiar with that. And inside of there will be a Visual Studio folder with the year, or rather the version of Visual Studio that you're currently using. In my case, 2015. It could be 2050. I don't know. Whenever you're watching this course. And then finally, there's a subfolder called Projects, and that's where we want to start off by saving all of our projects. You could change this and put this someplace else, but if you keep it here, then you always know where to find your projects. Now, if there's any other selections to be made here, and it might depend based on which edition and version of Visual Studio that you're actually using, just make sure that if there's an option to create a directory for the solution, make sure that that is turned on, but everything else can be turned off. You can ignore every other little message that pops up. We'll click the OK button to create our new project. Visual Studio goes off and does some work for a moment or two. And ideally, you have this little window in the upper right-hand corner called the Solution Explorer visible. This is going to show you all the files and things that are associated with the project. We'll come back and talk about that later. Here in the main area, you'll see a tabbed area called module1.vb, hopefully opened up. And inside here, we're going to make some room for ourselves. We're going to put the little caret there on line 4. I'll hit the enter key on the keyboard a couple of times just to make some space For what comes next, we're going to type in some code. And I'm going to type in the word console because I want to work with a console window. And I'm going to hit the period key on the keyboard. And I want to write a line of information to the screen. So I'm going to use this write line method. We'll talk about methods in just a little while. Write line, and I'm going to give it the message that I want to be typed in. So I'm going to use double quotation marks, and I'm going to type the word hello space world. Whatever I type inside of these two double quotes, this will actually be displayed to screen. We'll come back to that in just a moment. And then I want to make sure to write one more line of code, console dot, and you'll see little windows pop up with information and messages. It can be distracting at first, but actually this all comes together and it becomes one of the most useful features of Visual Studio. So ignore it for now. We'll pay attention to what it is a little bit later. Just type all the way through what I'm telling you to type right now. Read line. And then we're going to use an opening and closing parentheses, but nothing inside of it this time. Okay, so the next thing we want to do is save our work. And I'm going to hit the little icon on the toolbar, save all. It has two little disks next to each other. And you'll see the little yellow line here turns into a green line, letting us know that everything's been saved. And then you should be able to find a little green arrow with the word start next to it here on your toolbar. Now, sometimes you may not see these based on some of the default settings, or you may have accidentally moved some things around. Just about everything you see on the toolbar can also be found in the menus. So for example, in the File menu, there's a Save All option, and then in the Debug menu, there's a Start Debugging. So if there's something that you don't see on your toolbar that you see on mine, just look through the menus and you might find it there. But ideally, it would be here on your toolbar. I'm going to click the Start button. And you'll notice that the appearance of Visual Studio changes a little bit, and then off to the side, a console window pops up with the word Hello World with a blinking cursor. Awesome. All right, so we built our first application. How do we stop the application? There's two ways. I could click the little X button here in the upper right-hand corner, or I can hit the Enter key on the keyboard. The application will stop executing, and now we're back into edit mode in Visual Studio, back here in the code where we could modify it and make changes. So you can see that Visual Studio is now returned to its original state, and you might see some other windows pop open from time to time. You can safely ignore those for now. Now, what if your experience was vastly different from my experience? So for example, what if you type the code out, but you see an error message pop up when you actually attempted to run the application or start the application? You get this little error message that says there were build errors. Would you like to continue and run the last successful build? Select no, and then what you should see is a list of errors pop up. A list of errors here in a little window called the error list. And in this particular case, you can see that I get a little notification of the issues, and if I were to click on one of them, it would take me to the line of code where that error was actually manifested. Now, the error list popped away, but if I hover or click on the error list here in the bottom, it will pop back up for me, so it goes away, it pops up. All right, so you can feel comfortable with moving around Visual Studio to that extent. Also, if I hover my mouse cursor over this little red squiggly line, it will say that there is a declaration expected. Now, the reason for this particular error is because you wrote the code in the wrong place. You may have placed it between the module and end module keywords, but not between the sub and sub. Again, ideally, this code belongs right here between the sub main and the end sub. You need to put it right there in the middle. And so that's probably one of the first and most important messages, is that it matters where you type your code. And I'll explain what a sub is versus a module. There are other kinds of code blocks, as we'll come to understand as we continue through this series. But that's one potential error that you could have run into. You saw how Visual Studio tries to tell us that there's a problem with the red squiggly line. It also gave us a list of errors. Now, once we fix those errors, notice that the error list is clean. So you can see also that it tells us that there's 0 errors with our code. Awesome. All right, so maybe you had a different problem. Maybe you see an error that looks something like this. And you get a red line completely underneath it. You try to run the application. You get that same little "there were build errors" message in a message box. You click the no button and you see something like readline. Notice there's no L in readline, is not a member of console. Now, admittedly, since we don't know Visual Basic very well at this point, the messages are not as helpful. But the fact that the error is happening on this line means that we can take a moment and really try to investigate what the problem is. And in this case, if you really look at it carefully, you'll notice that I'm missing the L in readline. So precision is extremely important as you're typing code. You have to type exactly what I type in order to get the results that I get. So even if you deviate by one little character, it can unfortunately stop the execution and the compilation of your code. So in this case, we just have to add the L in readline and we're good to go again. You could experience something similar, if we misspell the word console. In this case, you'll see that console is not declared. It might be inaccessible due to protection level. Now here again, the problem is we misspelled the word console, but once we fix it, then the error will go away and we can run our application again. All right. Or perhaps you didn't use you didn't use double quotation marks and you see that hello world has no double quotation marks around it and you get two different error messages whenever you attempt to run the application. One says something about a comma, the other one says hello is not declared, it might be inaccessible. Again, since we're not as familiar with Visual Basic at this point, the messages might throw us for a little bit of a confusing loop, but the remedy is easy. Again, precision is important. We have to surround that message, in this case, with double quotation marks. And I'll explain why in an upcoming lesson, what that really is telling Visual Basic, the Visual Basic compiler. All right, but that's how we would fix that issue. So again, I think that making sure that you follow my instructions carefully, making sure you type the code where I type it, not outside of one of the code areas like I've designated, like I've tried to call your attention to, but rather in the right spot, and then making sure you spell everything correctly. That is the key to moving forward. Whenever you run into issues, it's probably not Visual Basic or you have a problem with Visual Studio. Some people will say, is my version of Visual Studio different than yours because I typed this out and it won't run for me? And invariably what happens is they've done something incorrectly when they typed in the code. So typing in code is an exercise in precision. You've got to make sure that it's exactly what you see on your screen and what you see on my screen is identical. Okay? All right, so assuming you got this to work, then you're well on your way to building applications. You've already learned some of the most important lessons so far, whether you realize it or not. As you undoubtedly learned in this lesson, writing Visual Basic code is an exercise in preciseness. However, frankly, Visual Basic is probably the most forgiving of programming languages because it will always nudge you in the right direction, at least as often as it can. Or at the very least, it's going to show you where the problem was by putting a little red squiggly line or something along those lines, giving you errors in the error list that you can work from. So in the following lessons, we're going to begin focusing on two things primarily. First of all, why we did what we did here. What happens whenever we create a new project? What happens when we click the Save All button? What happens whenever we click that Start button to actually run our application? So that's number one. Number two, we're going to focus on the syntax of the Visual Basic code that we wrote. So if preciseness is required, then you're going to need to have some explanation as to what all the words and the symbols that we've been using here, the use of the period, the use of the opening and closing parentheses, the use of the double quotation marks. What do all these mean? And honestly, it's really easy once you get started. Once you get a few basics under your belt, I think you're going to see that writing Visual Basic is almost as easy as writing English into Microsoft Word. Okay, so at any rate, we'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devview.com. In this lesson, we want to start with the process of dissecting this tiny little application that we created. Previously, I wanted you to focus on the workflow, what we did, and how we did it. Now, I want to focus on why we did what we did. It's crucial that we cement these ideas in your mind because they really provide the basis, the foundation for everything else that comes next after this. So what I want to do is start on the inside and work our way out. And whenever you learn how to write applications with Visual Basic, learning the syntax of Visual Basic, or in other words, learning the nouns and the verbs and the punctuation of the programming language is really just half of the battle. The other half of the battle is learning about related pre-built functionality that's available to the programming language. So in our case, Microsoft has created something called the .NET framework. And while that sounds a little mysterious, it's actually not all that bad. For now, there's really just two parts of the .NET framework that really concern us. First, there's a class library, which is simply a library of code that Microsoft wrote to take care of difficult tasks so that we as developers who will utilize or borrow from that library, we don't have to build that code ourselves. We can just rely or borrow that code from Microsoft. So there's this library of code to help with things like math operations or working with text or displaying things to the computer screen or transmitting information over the internet and a ton of other stuff. So that's the first part, the class library, which is part of the .NET framework. The second part is called the .NET framework runtime. It's also known as the Common Language Runtime, or the CLR. So the CLR, the runtime, is just this protective bubble that your application, when it's running, lives inside of. And I use the term protective bubble because the CLR, the runtime, it takes care of all the low-level details so that you, the developer, can focus on what the application does and less about interacting with the computer's operating system, with its memory, with its hardware, and so on. And furthermore, the CLR, it provides this layer of protection to the end user so that you, the malicious, evil software developer, you can't really hurt the end user's computer, at least not without them asking permission if you can delete their whole hard drive, okay? So they'll have some knowledge or some ability to say, no, I don't want to delete the entire hard drive. So for right now, it's really the .NET framework class library, the first thing we talked about, that I want to focus on because we're writing code. So whenever we typed in this phrase, console.writeLine, we were using some code in the class library that knows how to display text in a Windows command line window. And then all we have to do as the programmers is actually say what it is that we want displayed to the end user. And so we're just focusing on the important part. These are the words we want written out to the screen. Everything else, how is actually written out to screen? Well, that's the part that Microsoft takes care of for us because they wrote a library of code that we're able to borrow or use. So this next line of code is also important. Here we're telling our application to wait for input before continuing to execute. So here again, we're calling a method inside of the .NET Framework class library that expects input from the end user. Now, we don't have to actually go through the hard work of listening for keyboard strokes and worrying about the signal as it's passed through the operating system and worrying about the hardware of the keyboard. All of that is abstracted away from us. All we got to do is say, we want to wait for the user to actually do something on the keyboard before we continue on, okay? So, what happens if I were to actually say, let's ignore this line of code? And to do that, what I'm going to do is add a code comment. And I can use a single quote mark in Visual Basic as a way to comment out a line of code. This means that I want you, the compiler, as you're running my application, to ignore this line of code. We're essentially deleting it, but we're leaving it in the source code. I could have just deleted this out completely. So I'm going to select it all with my keyboard by hitting the arrow keys. I use the arrow keys a lot. You'll want to use those as well as the home and the end key, so I can jump to the beginning of the line and the end of the line for any line of code. And I can also use the arrow key to move back and forth inside of the code. So here I'm going to hit the home key and then hold down the shift key and then hit the end key to make a complete selection, and then I can hit Control X on my keyboard just like I do in any Windows application to actually delete that line of code. And yeah, I could have done that. However, now it's gone and I can't ever add it back in. I'd have to retype it. So commenting out the line of code is the preferred way to actually do an experiment without deleting your code completely, but you're saying ignore this line of code whenever you're actually running my application. Okay. So now what happens if we were to run the application, but we left out that console.read line? Let's go ahead and run the application by clicking the start button. And it executed in a fraction of a second and then it ended. All right. So without pausing the application, saying we need to wait for an end user to hit the enter key on the keyboard, the application executes and it's finished in a fraction of a second. All right, it flashed on screen and then went away. And so that's why we need both of these lines of code in order for our application to work the way that we had expected. Okay, so let's talk about the position of the code. You'll recall that I made sure in that previous video to emphasize that you have to put the code in the right place in order to get the same results that I got on my screen. So the right place was between this sub main statement and this end sub statement. All right, so together these define a block of code. And you can see when I even put my mouse cursor on this line that it will highlight the corresponding end sub. So here's the beginning sub and the end sub. Furthermore, I can hover my mouse cursor off to the left-hand side with this little minus, and notice that it will highlight in a very, very light gray color the entire section, saying that this all belongs together as one block of code. Furthermore, I can go ahead and click that little minus sign and it will roll the code up. And you'll notice that now we're going from line 1, 2, 3, and then we jump down to 10. Where did 4 through 9 go? They're actually rolled up together in this little section, and I can hover my mouse cursor over it and we can see the full definition for that sub main in a little window that pops up underneath our mouse cursor. But essentially what we're saying here is that this code all belongs together in a single code block, and this code block has a name. We've given it a name called main. And once it has a name, we can call it by its name. So before we get to that, let's talk about this other level of indentation that we have here, an outermost module. And as I hover my mouse cursor or put my mouse cursor on the module, notice that it corresponds here down at the bottom with this end module word. Okay, so you can think of when you write code as a series of containers. Here we have a container for our code, and then it sits inside of another container for our code. All right. So I'm going to oversimplify it for just a moment and build on this definition, but basically this innermost code block here is known as a subroutine, or basically just a sub. It's actually known by many names, and the context of how we're using it will determine what we call it. So in this case, just a sub or a subroutine. In other words, it's just a block of code that has a name and we can call it by its name. We'll come back to that in a moment. In other situations, we might see it called a function. All right, and notice when I change the word function here, it changed the word function down there. Now we do get a little squiggly line here because it's not really being used the way that it was intended to be used. We'll come back to that later. Let me go ahead and type the word sub here again, and notice that it automatically changes it to end sub for me again. All right. And then in other situations, it's not known as a sub or a function, but rather just in general terms as a method. And so I'm actually going to use that term method many times whenever I'm referring to either a sub or a function. And so we'll talk about what methods are. They have a very specific meaning, but for right now, I'm just going to use it in a very general sense, that this is a method and the method has a name. The name of that code block is called main. Now this specific subroutine, the specific method, it actually has a special purpose in our system. Since its name is main, it just so happens that this code will execute first whenever our application runs. So whenever the application comes to life, the application will look for an entry point. What do I do first? And whatever is defined inside of this method called main will be the first code that actually gets executed. From here, then we would actually call other subroutines or functions, methods, in order to accomplish things in our application. We'll see examples of that as we continue on in this course. So later on, you're going to come to realize that a method, in this case just a sub, a method means so much more, but I just want to use that simple working definition of it being a code block that has a name, and since it has a name, we can call it by its name in order to execute that block of code. So whenever you have a name, you can call something by its name, whether it be a method or a module or a class and so on. We'll talk about all these ideas a little bit later in more detail. So the main method lives inside of this module, a module simply known as module 1, the default name. All right. And so a module is simply a way to, simply an organizational tool. It's a way for us to keep all of the methods, the subroutines, the functions, that kind of are related together in some way, that are similar in nature. So you put all of the methods that are somehow related into a single module. There will be another container for your methods that we'll talk about later that's called a class. So a module is kind of like a class, but a class has a slightly more advanced and very important usage in Visual Basic. But in both cases, whether we're talking about modules or classes, you're going to put all the methods that are somehow related together inside of that same kind of organizational unit, that Tupperware container, as I sometimes call it, okay? So what do I mean by related together? Well, that's really up for you as the programmer to decide based on the type of application that you're building. You're going to come to understand as we go further through this and as you continue on past this course, the philosophies of writing code that will dictate where the code should reside inside of your application. So the module is pretty simple and it's pretty straightforward, and that's why we're starting with it here. And the class is a little bit more advanced, but ultimately they're kind of the same. In fact, a class actually is more than just an organizational tool. I really oversimplified it, like I oversimplified the notion of methods, but I want to keep it simple for now. Let's just use that as a working definition until we get a couple of lessons from now when we'll start creating classes of our own, and we'll talk about why classes are so important. But the main takeaway now is that code is organized inside of code blocks, and you define a code block by using a keyword like sub or function, and then end sub or end function, or another type called a module and end module. Eventually we'll create class, end class. Those define code blocks, and code blocks can live inside of other code blocks as an organizational unit. All right, so let's take a look at this line of code again here, line number 5, as you see on my screen. Here we're actually executing a method. We said before that this is from a library that Microsoft created, and that's true, but we're actually executing a specific method by using its name, WriteLine. And so now anything that was defined inside of the WriteLine method by somebody at Microsoft will get executed when we call the name of that method, okay? So it actually lives inside of a class, a container called console. And so the second line of code that we wrote also is from the console class, but it calls a different method called readLine. So readLine is calling a different block of code that somebody at Microsoft actually wrote. And we've already talked about the purpose of WriteLine versus readLine. Why are they both associated with this console class? Well, they're organized into the same class, the console class, because they both have something to do with building applications that display as console windows on our computer. So they're related in a sense in that way. If I wanted to do something with the Windows console, what would I do? I'd go to the console class and then call one of its related methods. Okay? And the way that I do that is by accessing the methods of class using this little dot operator, all right, the period on our keyboard. So here we're able to say essentially module1.main, except in our case we're saying console.writeLine or console.readLine. So this little period is actually known as a member accessor. In other words, we can access a member of the console class by using a period, and then after the period, the name of the class, the period, then we can look at all the members of that class, the members being the various methods and other things that were defined inside of the console class, all right? And then we can actually type the name of the member, in this case, the WriteLine member method versus the ReadLine member or method in order to execute it, all right? Now notice that immediately following both the WriteLine and the ReadLine, that in both cases we have a pair of parentheses. Now, admittedly, in this first case, we're actually putting something inside of the parentheses. In this second case, we're not putting anything inside of the parentheses. In the case of the ReadLine here in line number 6, really all we want to do is just say, go ahead and wait for input from the user. So we're using an opening and closing parentheses because we don't have any extra information to tell that library of code that Microsoft wrote. We're just saying wait. Here, however, we need to give some additional instructions. We need to say what we want WriteLine to print to the console window. So to do that, we're going to give it the words we want it to print to screen. And whenever we're going to give it words, we need to treat them as a literal string of individual characters. So I want you to write the letter H, the letter E, the letter L, the letter O, and so on, and use a space. So I want this exact string of individual characters. So we're going to call this a string, literally this string of characters, so a literal string of characters to the console window. And so we're going to talk about strings versus other types of information, maybe numbers, maybe true, false, maybe dates and times, all right? So we'll talk about data types in Visual Basic in another lesson, but it's pretty crucial to understanding Visual Basic. But here we're going to give it a literal string of characters we want printed out to screen. All right, but the key idea here is that some of these methods can accept input as parameters, so we'll call them input parameters, and some of them don't require any input parameters in order to do their jobs, all right? So we're going to come back to the notion of methods in the future and how to pass data into methods, just like we did here with Hello World in line number 5, and the significance of the double quotes. But just know that whenever you see a set of parentheses after a word, the method is being invoked. So the parentheses are actually a special tool inside of Visual Basic called a method invocation operator. We want to invoke the method. We want to say, do it, run, go, do your job. And here we'll provide you some extra information in the form of an input parameter, okay? So that's the purpose of the open and close parentheses. So Visual Basic is really lax about some things and is pretty strict about some other things. In some programming languages, you could stretch a single line of code onto multiple lines because the line of code is so long that it might run off the visible area here inside of your code window. And now, in some cases, like in C#, you can do that automatically. You don't have to do anything special. However, in Visual Basic, it's not the default behavior. If I were to try and separate this single line to two lines of code, the single instruction onto 2 lines, I'm going to get a bunch of errors, all right? In Visual Basic, by default, a single line represents a single idea, a single thought. It's like a sentence in the English language. And to separate these onto 2 separate lines, you're essentially creating 2 sentences without using the correct punctuation, all right, if that's the right analogy, okay? But you can actually do this if I had a really long line of code and I needed to separate it so I don't have to scroll off to the right-hand side of the screen every time that I wanted to read my code. I can use what's called a line continuation character in Visual Basic. So it's simply an underscore. So in this case, I'm able to say console, and then hang on a second, let me use an underscore, right line. Okay, and I might use some indentation here just to make it obvious that these two kind of belong together. All right, but that's not necessary. So in this case, this would be kind of silly to actually do this. So I'm going to remove it, but you can use an underscore character, and we will throughout this course to split up lines onto multiple lines to make it more readable so that it doesn't go off to the right-hand side of the screen. Additionally, I can kind of do the opposite where I can put multiple lines of multiple instructions on a single line. And so here again in Visual Basic, one line by default represents one instruction. And so we have two instructions in our program right now. But what if I wanted to combine them onto the same line of code? If I try to do that without anything, I would get some errors, right? Because there's really nothing separated, and you would see the end of the statement was expected. And so if I really wanted to do this, and there's really not much of a reason to, but you might see it in somebody else's code, you can use a colon. In that case, now we've ended one line of code here, and we've said, okay, just let's pretend for a moment that this is actually a different physical line, and then this other line of code, and now the application will execute and run exactly the same as it did before. All right, there we go. Now let me go ahead and get rid of that too. Now I want you to also notice that by default that we get some indentation levels. Like here at this leftmost indentation, we have the module. And then kind of to denote containment, there's another level of indentation for the submain. And then inside of the submain, again, to indicate containment, there is the code that we actually wrote. And then I showed you just a moment ago how I might use indentation another time to indicate some relationship. So if I wanted to do that, that might help me to see that these two lines in 5 and 6 are actually related together, even though they're on two physically separate lines. All right. So there is some indentation by default, and the Visual Studio IDE, the code window that we're typing in, will nudge you in that direction. Even if I tried to, for example, start typing a line of code here and do console.write line, that's all, folks, and I hit enter on the keyboard, all right, it's not going to, because I forced the issue, I made it line up there on the leftmost column, it won't force it, but if I were to just hit the enter key on the keyboard, it's going to put it right there in line with all the other code. All right, so just be aware of that I might need to re-indent some code if I took extraordinary measures in order to move it off to the left-hand side. But indentation is completely optional in Visual Basic. It has no real bearing. Furthermore, white space has no real bearing in my program as well. So you can see I have all this extra white space. It doesn't mean anything. I could actually remove all of it just by kind of making some selections here on my keyboard and deleting. And this will work just as well as this works. So why do you suppose that we have the notion of indentation? Why do you suppose that I add and that the template added white space in between certain containers of code? Well, it makes it a little bit more readable, right? I mean, if you have it all scrunched up together, or you have it way too far apart, or if all of the lines of code are butted up against the left-hand side, it's not visually as easy to tell where you're at in the hierarchy, so to speak, of the code structure. And so that's why Visual Studio automatically will try to nudge you in the right direction to format your code in this way. Now, along the same lines, Visual Studio also color codes certain types of instructions that we type in. So for example, you can see here that this hello world is in this really by default. Your colors might be a little bit different than mine. That it really doesn't matter. The fact is that Visual Studio will try to color some things differently. So by default, you can see here that there's this this dark, deep red color, which indicates that this is a literal string. Then there's this aqua color, which says that this is a class or a module. All right, there are things that have a more a royal blue color. These are keywords inside of Visual Studio, and you'll see some other colors pop up as well. Whenever we use the code comment, notice that the whole line turned green. That says it's a code comment. So different colors, just like indentation levels, just like white space, help the readability of our code. All right, so we've talked about the code that we wrote. Next up, let's talk about the file that we actually wrote our code into, this module1.vb. I don't know if you saw that little tab name up in the upper left-hand corner. And we're going to talk about how code files relate to projects and how projects relate to solutions and what happened whenever we click this Save All button here on our toolbar. And then we'll talk about what actually happened when we ran our program then in the video after that. So there's some important concepts that you're going to learn about project management and about compilation in the next two videos. Make sure you watch them. We'll see you there. Thank you. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. Next, we'll talk about how code files are organized into projects and solutions and where they're stored on your hard drive, how to open up a project that you previously closed, how to open up one of the code files that I'll supply or that some friend might give you that you can download in a zip file, how to unzip it, put it into a directory, open it up, and so on. All right. So whenever we created a new console project in one of the previous lessons, the module1.vb file automatically opened up into this main area inside of Visual Studio. And that's one of the things that project templates do for us. They provide a great starting point for the type of application that we want to build, including files, boilerplate code. So it gave us this module 1, sub, main, and sub, and module. Gives a little boilerplate code. And then also it added some settings. We don't see them right here, but there are some settings that are stored here in this app config and in this hello world file that you see listed here in the Solution Explorer, and some other resources depending on the type of template that we choose. All right. So this little tab here at the top, in my version of Visual Studio, it's a dark blue tab. It really depends on the colors you have selected. And again, your version of Visual Studio might show it a little bit different than mine. But at any rate, it indicates which file we're currently working on here inside of the main area. If we were to add an additional file to our project, there are a couple of different ways to do that. We could open up multiple files here and have them all open at the same time, but only view one at a time. We'll look at some maybe window management accidentally as we go through this course, and you'll see. But before, again, a more thorough explanation of how to utilize Visual Studio and get the most out of it, you'll want to watch an entire course just on the Visual Studio IDE itself, okay? But at any rate, that tab has a label inside of it, and it indicates which file we're currently working on. So our Hello World program right now only has one code file, like I said a moment ago, but as our applications become more complex, we're going to organize our code into potentially many files inside of the same project. Now, if you take a look over here, and I've already referenced it once, there's this window called the Solution Explorer that by default is kind of docked up in the upper right-hand corner of Visual Studio. And it basically has a tree-like representation, a tree-like view of the items in our project and how it's related to our solution. Now, as I said at the outset of this course, this is not intended to be a tour of Visual Studio. There are going to be other resources on Microsoft Virtual Academy that can help orient you to Visual Studio, but the Solution Explorer is the most important part of Visual Studio, in my humble opinion, next to the main area where we're actually going to type our code. Simply put, this Solution Explorer is our main navigational device to the other files and the settings that comprise our program. So as you can see here, we have a module1.vb namespace.vb. If I were to close this tab in the main area by clicking the little X button off to the right-hand side, and there's nothing now in the main area, I could open that file back up by just finding it here in the Solution Explorer and then double-clicking it, and there you go. We're back into our module1.vb. So files and important settings are organized into projects, which are then compiled into a single .NET assembly. We'll talk more about compilation in .NET assemblies a little bit later in another video. Okay. Furthermore, one or more projects are organized into solutions. So in many cases, as you're getting started, you're only going to have one project inside of one solution, okay? But as you build more complex applications over time, it's highly likely that you're going to manage multiple projects that are somehow related inside of the same umbrella called a solution. Again, the reason for that might not be obvious today at this moment, but as you continue learning about Visual Basic beyond this course, I think you're going to find that as you build more complex, business-oriented applications, this becomes a crucial code management strategy to put things in different projects, depending on the functionality and the role of that code inside of the larger software system that you're building. All right. Again, that's a topic for another day. Just for now, accept that there's this extra layer called a solution that owns projects, one or more projects, and trust me, it becomes more important as we move past the basics. But for the most part in this course, we're going to only concern ourselves with talking about projects. The big question at this point should be, where are all of these files actually stored on my local hard drive? I can see them here in the Solution Explorer, but where are they on my local computer? So whenever we created the Hello World project, and recall that we went to File, New Project, that opened up the new project dialog, and we typed in the name of the project that we wanted to create. And then I also called your attention to the fact that that there's this location here, and that this would be by default where our code is actually saved. All right, so by default it's going to put it in the current user's documents folder. So if you have multiple users on your system, then it's going to be whatever user you currently are logged in as. In my case, I only have one user on my computer, the Bob user, me, and Bob has a documents directory. And inside of that documents directory, there is a Visual Studio, and then in my case, 2015, it could be 2016, it could be 2050 if you're watching this, 35 years from now, okay. And then there's a subdirectory inside of that called projects. So this is where by default things will actually be stored. If we take a look at Windows Explorer, the File Explorer here in Windows, and let me resize this a little bit. Mine's going to look dramatically different from yours because I use this quick access feature quite a bit. But suppose, for example, that we're looking at the desktop here by default, and I've got a lot of junk on my desktop. Here I'm going to be able to look at the documents directory. All right, now sometimes this documents directory will show all of the documents, and sometimes it shows just a subset of documents. In this case, it's only showing a subset. I actually have quite a few more folders. But for our purposes right now, this will do. We see that there's this Visual Studio 2015 folder for my situation, for my case. Inside of that, then there are a couple of subdirectories. There's the project subdirectory. Now, again, let's just ignore this version of this and go back to the quick access where we're going to get to my documents directory. You'll see everything in documents. We'll go into Visual Studio 2015. Then we're going to go in, we see quite a few more folders. We'll go into projects, and there we are. There's the Hello World folder, all right? And as I add more projects, they're going to fill up this projects folder here. And it's important to note, whenever you create a new project, you can put it anywhere on your hard drive that you want. I just usually accept the default, at least to begin with, unless I'm very purposeful in what I'm trying to accomplish. Maybe I want to put it someplace else because I want to work in a team environment and we're all agreeing to put our code in a specific place or use a tool that really kind of pushes us, nudges us towards a different file structure. Be that as it may, we'll come back to that idea some other day. All right, so furthermore, you can open up a project that's saved anywhere on your computer. And to illustrate this, I wanted to give you, and I'm just going to shut down Visual Studio for now completely. I gave you this file. You should be able to find it wherever you're currently watching this video or wherever you originally downloaded the video from. There's also a file that should be available called example.zip, and it has a project inside of it. And so what I want to do is extract this to my hard drive. I'm just going to right click here and select Extract All. Pops open the Extract Compress Zip Folders dialog. And I'm actually not going to extract it to my desktop. I'm going to extract it to the root of my C drive. And then I'm going to click the Extract button. And it says, hey, there are actually some files with the same names. Unfortunately, this is due to the fact that I've gone through this example before. So let me do this. Let me cancel this out. Cancel this, cancel, cancel, cancel. Let's open this up. Let's delete. Let's find my local computer here. There we go. And I'm going to delete this folder. Okay, so now you can see this is all the junk on my folder, and I have a very, very messy hard drive. I'm going to right-click the example again and click Extract All. And here we're going to go and just say, I want to extract this project called example to my C:/drive. Extract it. And there we go. So now if we were to open this up and double click the example folder, you can view the contents inside of it. And you see inside of this another example folder and an example.sln file. So this second example folder actually contains the project. And this example.sln file is the solution file. This solution file is the same as the solution that we saw in the Solution Explorer. So a solution can contain one or more projects, and here the projects are going to be contained inside of subfolders. If we were to actually open up this .sln file, here I'm just going to open it with, and you can see I have the Notepad app already selected because I've made some changes in Windows. If you want to open it up with Notepad, you should choose another app. It'll give you this little dialog here, at least in Windows 8 and Windows 10. All right, so we're going to open with, and here you might see some options. Visual Studio is the preferred way to actually open up an SLN file. We don't want to change that. Therefore, if you do search through your list of apps and you're trying to look for Notepad, make sure you do not click this checkbox. Always use this app to open SLN files. You do not want to do that. You will hate me if you do that. All right. So select Notepad, but don't check that checkbox and click OK. And you can see that this is simply this solution file just simply has some settings related to versions and what's inside of a project, some global settings, some other information about configurations and so on. We don't want to make any changes in this file whatsoever. So just carefully close this. If it asks you to save any changes that you made, make sure you do not save those changes. All right. Otherwise, you're just going to need to delete it and start over again with a new zip file, extracting it. Okay. All right. So we've satisfied our curiosity, but what's inside of this project folder? Well, you can see that we have another file called example.vbproj. So this is the project file. And here I'm going to do the same sort of thing where I'm going to open this with, and I'm going to choose Notepad again, making sure not to select this, just to satisfy our curiosity. And here we see that this is an XML file that just has other settings related to this specific project. A lot of settings. We do not want to make any changes to this whatsoever. It just has information that's going to be used by the Visual Basic compiler to create an executable for our application, and also maybe some other things related to how we want our project organized and what we want visible in our application. I'm just going to close that. I do not want to make any changes to it. There are also then some subfolders inside of it. The same project folder. I think the most important thing we see here is this module1.vb file. So this is the code that I wrote for the example project. And if I wanted to open up and work on this project now, I have a couple of choices. I could either double click this example.vbproj from our file explorer, or I could double click the example.sln file to load it into Visual Studio. So just to show you that, that's usually how I open up the projects. Or the other thing that you can do is actually go to the File menu and select Open Project or Solution. Or if you've opened it recently, it might be in your list of recently opened projects and solutions, and you can navigate and find, for example, the Hello World project and open that back up into the Solution Explorer. Okay. Now, what I want to do is actually shut down Visual Studio one more time. Here I want to go into our Documents, Visual Studio 2015, Projects, Hello World. Then I want to go to the Hello World project inside of the solution folder, and I want to look at this bin directory. So bin is short for binary. It denotes that there's a binary executable output that will be added to this folder whenever we go through the compilation process. Whenever we hit the start button, it would actually create a debug version, compiled version of our application that can be run on our local desktop. All right, so compiling your code into a working application is really the end goal of writing source code. But I want to stop short of talking about that in detail and pick up this idea much later in the course. I think you're going to get a better appreciation for it once we get past some of the basics. So I'm going to stop right now, and I'm not going to show you what's inside of this debug folder. All I am going to do, though, is just talk about at a high level what we learned in this lesson related to the Solution Explorer, how it allows us to navigate through the code files associated with our project, how we're able to close down Visual Studio, but then open up our project again, either by navigating through the file system in the File Explorer, or by using one of the open menus in the File menu. So I can open a solution or project, or open something that I've opened recently in the past in order to open it back up and continue working on code that I have in the past. We talked about the file structure and that you can save your projects and solutions anywhere on your hard drive, but by default, it's going to put them in your current user's document/Visual Studio/project subdirectory so that it keeps them all nice and organized. I showed you how to extract out an example and put that somewhere on your hard drive so that you can then open it up into Visual Studio. So the source code that I give you and that I make available with this course, you can download it, extract it, and open it up and look at it in Visual Studio if you want to. All right, so hopefully that all made sense and you understand those relationships. Now let's continue on. And again, we're going to focus on just that little Hello World application, but you can see how that's branched off into so many conversations now that are vital to our fundamental understanding of what's going on as we build applications in Visual Basic. All right, we'll see you in the next video. Thank you. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, I want to get back into the Visual Basic syntax itself, and I want to talk about declaring variables, choosing a data type for your variable, and then initializing variables. So to begin with, as you can see in Notepad on screen, I have a little algebra problem that I want to throw at you. And even if you've taken an introduction to algebra, you should be able to solve this one pretty easily, right? So here I just want to solve for the value of x. So without a whole lot of thought, hopefully you can take a look and see that, well, the value of x must be 7, right? So using that same thought process now, take a look at this Visual Basic code. All right, so x equals 7, y equals x plus 3. Console.writeLine y. What do you think will be displayed in the console window when we execute this Visual Basic code? Well, probably the value 10, right? So you just read Visual Basic without any help from me. It's pretty common sense, right? I mean, it for the most part makes sense what you're trying to accomplish once you understand, for example, console.writeLine. So first, as far as Visual Basic is concerned, the x and the y in this situation are referred to as variables. And so a variable is simply a bucket in your computer's memory that's capable of holding a value. So you can put you can put values into buckets, or rather into variables. You can take values out of variables, or the buckets, all right? And then suppose I put something in the bucket, I can put something else in the bucket and cover up or eliminate the original value, and now it has something new in that bucket in the computer's memory, that variable. All right, so this particular case has these buckets just holding numeric values, but we could create buckets that are just the right size to hold any kind of data. So for example, we can create a bucket that's just the right size, a variable in the computer's memory that's just the right size for strings of individual characters, so strings, very big numbers, very small numbers, true, false, dates and times, and numbers that have values after the decimal place, and a lot more. So there's a lot of different kinds of data types that are available in Visual Basic. And so in the case of this little code snippet that you see on screen right now, we would expect that both X and Y to hold numeric values. Now, these particular numeric values probably don't have any values after the decimal point. So that narrows down the kind of data or the data type that we would choose to store values for this particular application. Now, we know that X and Y should store numeric values, but we have to express that intent using the Visual Basic programming language so that when our code is compiled, it can be executed and carry out the instructions that we have in our mind. So the instructions that we give in Visual Basic will ultimately be executed by, remember that .NET runtime, what I call the Common Language Runtime, or just the CLR. And part of its responsibilities is to allocate space, buckets, in the computer's memory sufficiently large enough to hold the variables that we declare, to hold data, and we tell it what kind of data, the size of the bucket, in other words, that we want to create in the computer's memory. So in this case, we're going to have two data items, X and Y, and we have to tell the runtime using Visual Basic Code to allocate some space, enough space in memory, sufficiently large enough to hold numeric data sufficient for our application. So how do we do that? Well, we do that by declaring variables. So let me go ahead and get rid of this, and I'm going to create a new project. There's a number of different ways to create projects. We already did file new project, right? But here on the start page, there's also this little link that we can use, new project. Either way, it's going to pop open this new project dialog. So what I'm going to do is call this project variables. All right. And kind of the same rules apply that we talked about before, making sure that we don't make any other changes and just click the OK button. Now, the big takeaway from this lesson is that a variable is simply a bucket in the computer's memory that you can store data inside of, and then you can retrieve data out of it, and that you have to create the right kind of variable using a data type. We have to say what kind of data, what data type we intend to store inside of that variable that we declare. So all the same rules apply here that we talked about in the very first lesson. First of all, you have to type the code in exactly the way that I type it in. If you don't, you're going to get some kind of error. Work through the errors, make sure you pay attention to detail. If you have to, pause the video, rewind it, look at the source code that I wrote, because I'm going to supply that to you in zip files. You can unzip it, look at it, compare what I wrote versus what you wrote. But by all means, write this code yourself and start building that muscle memory as you're typing code yourself. If you do run into problems, remember, Visual Studio doesn't leave you hanging. You'll see the little red squiggly lines. You'll see the list of errors as you attempt to start or run the application. Those will all give you hints and clues as to where to look for the problem, and then just start developing that sense of being able to identify visually where the problems are in your code. You got to pay attention to the minutia, spelling, punctuation, everything that fortunately, people like you and I can understand, even if it's not spelled correctly or punctuated correctly. Unfortunately, computers need things exact. Okay, so, and while Visual Basic is forgiving, as we said, you still have to give it the correct instructions. All right, so what we want to do is write 2 lines of code where we're going to declare 2 variables. We're going to say create 2 buckets in the computer's memory that are sufficiently large enough to hold numeric values. And the way we do that here inside of our submain is to use a dim, and that is shortened for dimension, or we often call it declaring variables. Okay, so we're going to give it a name. That is the name of our variable x. We can give it any name with some exceptions. We'll talk about that in a minute. Now we got to say what kind of variable we want to create, and we're going to create a data type called integer. We'll talk about that in a minute too. So I'm going to do the same thing with y as integer. All right. Now, to borrow from the explanation earlier in the lesson, we're officially asking the .NET runtime to allocate space in the computer's memory sufficiently large enough to hold 2 numeric values. One that we're going to label x so we can get back to it, to save new values in it, or to retrieve the values that are already inside of it, and y, another label for a different bucket, a different space in the computer's memory, so they will hold 2 different values potentially. All right, so we're asking it to create these 2 buckets that will each hold values that eventually we're going to drop into those variables or drop into those buckets. And then after we've created those buckets or those variables, then we can begin to assign values into the variables and then retrieve values out of the variables. All right, so most importantly, we're going to assign integer values into those variables. How do I know that they're integer values? Well, again, here we use the key word integer in lines number 5 and 6. So integer is the Visual Basic term for a mathematical term, really. It refers to a number that has no fractions or values after a decimal place. It can contain very large numbers from 2,147,000,000 and something odd numbers to a negative 2,147,000,000 and something odd. Okay, so if you need to store a number that's larger than 2,147,000,000, then you want to create a different bucket in the computer's memory because you're going to need a larger bucket to hold larger numbers. Conversely, you probably want to use a smaller bucket if you really don't plan on using very many values inside of it. So for example, a true false value, you need a real tiny bucket because it only needs to store a 0 or a 1, which is true or false. Okay, so at any rate, like I indicated earlier, there are many different types of data types. There are simple data types, and then you'll also learn about complex data types. And then later on in this series of lessons, you're going to learn how to create your own custom data types using classes. All right, so because I don't want you to be overwhelmed just yet, I'm going to keep it simple for the moment. We're just going to talk about the integer data type here at the outset. We'll also talk about the string data type in this lesson a little bit later. All right, so first of all, I'm going to assign a value to x. I'm going to give it the value 7. Then I'm going to assign a value to y. And we'll take whatever the value of x is and add 3 to it. Now what I want to do is write out the value, console.writeLine, the value of y, and then of course we're going to use console.readLine so that we can actually see what it is that we typed in. Okay, let's run the application briefly, and we already know what the answer should be. The answer should be 10, right? Based on the little notepad equation that we saw earlier. We essentially just recreated this, but using actual Visual Basic code in order to come up with the value 10. So what really was going on here? Well, after we've created 2 buckets, 2 variables in the computer's memory, sufficiently large enough to hold integer values, then we started assigning values or putting values in those buckets and retrieving values out of the buckets. So in this first case, in line number 8, you can see that I am putting the value of 7 inside of the in the bucket labeled x. Then I'm going to retrieve that value out of the bucket labeled x and say, what did I stick in there? Oh yeah, the value 7. We're going to add those 2 values together and then assign that value to y. So at this point now, y should equal 10. Then we're just going to merely do what we've seen before. And instead of hard coding, the value of 10 as a literal string of 2 characters, 1 and 0, we're just going to give the console.writeLine our integer value of y, storing the value of 10, and it will figure out how to print that to screen. And that's how we saw the number 10 show up in our console window, okay? So I think one of the most important things that I didn't cover just yet is the role of this equal sign. It's actually an assignment operator. So in English, that line of code is basically saying set the integer named x equal to the value of 7. All right, and so we do the same thing in the next line of code. We're assigning this value into this variable. All right, so hopefully that makes sense. What I want to do now is comment out all these lines of code, and I can just go through here and one by one use the little single the single quote mark in order to comment all of these lines out. Or tell you what, I'm going to show you a shortcut. There's a tool here on the toolbar that allow me to do the same thing. So I'm just going to select all the lines of code with my mouse, and then I'm going to choose this little comment out the selected lines. Now notice that I can also use this keyboard combination. If I hit Control K, Control C, that's called a chord in Visual Studio. When you do dit, it's like creating a chord on the piano. And it will also comment all the lines out. But I'm just going to click the button here. You can see that it added a single tick mark to every line of code, thus commenting out the work that we've just done. I'll leave it here for your reference. All right. Now I'm going to create a few empty lines here by just hitting Enter on the keyboard a couple of times. And now let's create another example. Here what I'll do is we're going to go console.writeLine. Open and closing double quotes, what is your name? Question mark. On the next line, we'll go console.write. Notice I'm not going to use writeLine. We'll talk about the difference between the two here in a moment. Console.write, and then I'm going to use double quotes inside of that and say, type your first name, colon, space inside of the double quote. The next line of code, I'm going to create a bucket, or rather a variable called lowercase my, capital F in first, capital N in name as string. Okay, so let's talk about what I did here. Instead of using just a single letter as my variable name, I'm able to use a very long variable name. Furthermore, I'm able to use lowercase letters and capitalized letters in order to kind of give me a visual cue of where one word ends and another word starts. All right, and this is called camel casing. We'll talk about it in just a moment. And instead of creating an integer value, this time I want to capture from the user their name. Their name's not going to be stored in a bucket that can hold integer values, right? We're going to need to store strings of characters so that it can store Bob, B-O-B, okay? So that's what my goal here is, to retrieve the name of the user into this variable called my first name. And the way that I'm going to do that is through the use of the read line. And so we're going to use the read line in a slightly different way than we had before. So my first name equals console.readLine, okay? I'll explain what that does in just a moment. We'll make some more room. And then we're going to go console.writeLine, open and close, double quotes, type your last name. And here, actually, I don't want to do write line. I'm just going to do write. We'll go dim my capital L last, capital N name as string. My last name equals console.readLine. And then finally console.writeLine. And here, this is going to look crazy. I'm going to do hello, comma. I'm going to use an ampersand character, my first name, another ampersand, that's under the 7 key or over the 7 key on your keyboard, And now I'm going to use an opening and closing double quote. I'm going to put a space in between the two of them, all right? And this is just going to provide some spacing between the first name and the last name, like so. Okay, so let's go ahead and get started here at the very top of this and explain what this is going to do. First of all, what we're going to do is ask the person for the first name. When they type in their first name and hit the enter key on the keyboard, then we're going to retrieve that value and stick it into a variable called my first name. We'll do the same thing with last name by creating a different variable, reading off the value and putting it into the value of the variable. And then we're going to do console.writeLine, and we're going to concatenate or append together my first name, my last name, and this literal string, hello, comma, space, using this ampersand character, which is the string concatenation operator in Visual Basic. It just means that you'll just tie together all of these individual strings, and we're using spaces here, like in this case, and in this case right here, in order to give the correct spacing between the various words. All right, let's run the application, and we'll go and walk through it and talk about what it does. All right, so here we go. What is your first name? Type your first name. Here, Bob. Enter. What's your last name? Tabor. Enter. All right, now I unfortunately forgot something very important in my program. What did I forget? Whoops. I forgot the console.readline. All right. So we can run it real quick again, and I also want to put one space here between the colon and that closing double quote so that it keeps it consistent between the first name and the last name. Let's run it again. All right, and here we go. What's your first name? Bob. Type your last name. Tabor. Hello, Bob Tabor. Very cool. All right, so great. First of all, let's talk about naming conventions. And convention is basically something that most programmers do. And they do it because it's not only a best practice, but because all the other programmers are doing it too. Okay, and so it makes your code look consistent if you were to share your code with other people. So in this case, I named my variable my first name with starting off with the lowercase m in my, then the capital F in first and capital N in name. And so this convention is called camel case. And you should get into practice of using camel case whenever you name your variables, because again, most programmers do this, especially for variables that are declared inside of a given subroutine, function, or method. And we'll talk about the scope of variables in another lesson, but basically any variable that is of a local scope inside of a method, you should create them using this style of convention. You can name them anything you want. You should use long names and resist the urge to do what some books and some authors and articles that you might read online do, which is to use a convention like str first name. All right. The reason people do this is to remind themselves that this is a string. If your methods or functions are so long that you can't remember or you can't see their declaration in one page of code, then your methods are trying to do too much. But that's a whole other topic. Typically, you don't need to use that. It just muddies up the readability of your code. All right. So, and furthermore, if you were to hover your mouse cursor over a given variable, you can see pretty easily what the data type of that given variable is. In this case, my last name is declared as a string, as you can see there off to the right-hand side of the little bubble window that popped up underneath my mouse cursor. Okay, so the next thing that might have caught your attention is that we used writeLine versus write here in lines 14 and 15. The only difference is that writeLine will create a brand new line for the entire statement, whereas write will echo the characters that you have as input parameters, but it won't move automatically to the very next line. It'll just stay on that line. So that's what allowed us to say type your first name, and then as we began typing, it came off to the right side of the colon that we had added right here. Okay, so here we have requested now the the actual name of the user. And this is where we're using the console.readline in a slightly different way. We're retrieving whatever the user typed on the keyboard, and when they hit the enter key on the keyboard, at that point, the readline method will have executed and take whatever values were typed in by the end user and then assign them to this variable. So we've seen console.readline used without retrieving values like so, but it has this second function where it will actually retrieve back the values if we're interested in those values that the end user types in, and we are in this case. So we do basically the same thing here, nothing all that different until we get to line number 24, where we start appending values together into our write line in order to display them nicely to the end user, to format that string nicely. Now there's two things that I want to point out about variables and about Visual Basic in general. First of all, Visual Basic is case insensitive. Now, other programming languages like C# will allow you to create two different variables that have the same name but with different casing. So you could create, for example, my first name all lowercase, and then create a second variable called my first name all uppercase, and then create my first name with uppercase, lowercase, uppercase, lowercase, and those would be three different variables. Okay, you can't do that in Visual Basic, fortunately. It makes it easy to step on yourself and to make mistakes if you're not careful when doing that in C#. So you can't do that in Visual Basic. That means if I were to do this, my dim first name as string, you'll see that I get a red squiggly line, and it says the local variable my first name is already declared in the current code block. All right, why? Well, even though the casing on the F and the N is different, it is essentially the same as this declaration here in line number 16. So that's the first thing about Visual Basic, is that it's case insensitive. Now, when you type, sometimes Visual Basic will try to capitalize words for you automatically. So I'm not going to use the shift key at all as I type this. So dim, and notice when I hit the space bar, it made it from a lowercase d to a capital D. My other value as, and I'm going to hit the space bar and it capitalized the word as, and I'll hit integer and I'll hit the space bar and it capitalized the I in integer. So Visual Studio will capitalize words for you, but essentially that's a function of Visual Studio, not a Visual Basic. Now you'll also notice inherently that while it is case insensitive, you cannot declare the same variable twice. So that's the second thing that we noticed here a moment ago. And that's why this would not work. My first name as string will give us an error because we've already declared my first name here and case does not matter. So you cannot declare the same variable twice like you can in other programming languages. Okay. So now that we understand how to declare a variable, let's declare it and initialize its value in a single line of code. So here, I'm going to comment out this line of code right there. And I'm going to go to the next line. Dim my first name as string equals, double quotes, Bob. So when I use the term initialize, that means I'm going to set the value of a variable immediately at the point when I declare it. That's like creating the bucket and the value in the bucket all in one line of code. All right. So typically what you want to do is give your variables values as soon as possible. This puts your variable into what's known as a valid state, which will be an important idea as we learn about writing real applications as we get deeper into this series of lessons. But also experienced developers like to write less code, and they're always looking for a convenient way to reduce the number of keystrokes and just the sheer amount of code that they have to read through. And so something as simple as at some point it's going to become simple to create new variables and to initialize their value. Instead of doing that in 2 lines of code, it just makes sense to put them all in 1 line of code. So what I want to do is actually now, let's comment out this, because that doesn't really make a lot of sense in this application to go ahead and initialize the value the way that we did here. But what I will do here in this little block of code is to kind of do it all in one shot on these 2 lines. Lines 22 and 23, let's redo this like so. Dim my last name as string equals console.readline. All right. So now we're able to do both of these things, not only create a new variable, but also initialize its value to whatever the user types in on the read line. Okay. All right, so we talked about quite a bit in this lesson. We talked about what a variable is. We talked about declaring the variable, choosing the right data type based on the kind of data that we hope to store in memory. We talked about the difference between an integer and a string. So now we've got 2 data types to work with, right? Numeric values, especially ones that are between -2 billion and +2 billion that have no values after the decimal point, or a string of individual characters. We looked at using the equals sign as an assignment operator for assigning and retrieving values. We looked at the arithmetic operator. I didn't really talk about it, but basically we were just going to use the plus sign in order to add values together, just like we would do in any math problem. And we also looked at the ampersand, which is the code, the string concatenation character in order to append 2 strings together. We looked at the difference between console.write and console.writeLine, and we talked about naming conventions in camel case, and we looked at some of the rules of Visual Basic regarding naming, how Visual Basic is case insensitive, but it also will not allow us to create 2 variables with essentially the same name, but just with different casing. Okay, so we've added quite a bit more information under our belt about Visual Basic syntax. Let's continue the ball. We've got it rolling now. We'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, things are going to get a little bit more interesting. Based on the user's input, we're going to write logic to execute either one block of code or a different block of code. All right, so when I use the term logic, I mean that we're going to make a decision to execute one block of code or another block of code based on some condition, like, for example, the user's input, or maybe the state of the computer, the system itself that we're working in, or some other data that we have available to us. We're going to decide what to do with that input, with that data, and then react accordingly. All right, so what we're going to do is create a new project. I'm going to call it Decisions. So again, Visual Basic console application. We're going to call this Decisions. And click OK. And I'm just going to start writing some code. So again, what you want to do is pause while I'm typing this and type it along with me, and then I'll explain what it does. Now, I'm willing to bet that you can figure out what this does even without my explanation, because at this point things are so easy. But let's go ahead and just write it together, and then we'll go on and talk about it. All right, so here we go. Alrighty, there we go. So I think probably most of this would make sense as you look at it on my screen. The one thing that might look new to you is the if statement that we have here in lines 10 and the end if in line 12. And notice that there's this level of indentation then creating essentially a code block in between the if and end if statements. All right. So we've set up this condition if the user value is equal to 1. So if the value that the user typed in when prompted is 1, then what we want to do is set this variable message equal to the string value you want a new car and then print that out to screen. So let's go ahead and run the application and just make sure it runs in this very simple case, which I'm pretty sure it will. When I hit 1 on my keyboard and hit enter, hey, we want a new car. But what we have not accounted for are the other cases. So for example, 2, nothing happens. And the same would be true even if we typed in something like Bob and hit enter. Nothing happens. All right. So first of all, we want to talk about the evaluation operator. It is the equal sign, so it's playing double duty. We can use it as an assignment to set the value of message equal to the value of some string like you want a new car. But when it's used in the context of an if statement, here we're going to do an evaluation. Is this true? Does user value equal the number 1 or the string value 1? All right. If it does, then execute the block of code that's defined between the if and the end if. If this is false, so when I typed the number 2 or when I typed in the word Bob, then that's false, and we do not execute the values inside of that code block. Okay, so that is what I meant by making decisions. We're building logic and executing that logic, and then based on the input of the user, we'll decide what to display or what code to execute in a more general sense, whether we execute this block of code inside of the if statement or not. All right, so again, in this case, this is using the equal sign as an assignment operator. This is the evaluation or the equality operator. Okay. So what happens then if we want to try different combinations? Well, I guess what we could do is then start a whole new if statement. So if user value equals 2, then we can set the message equal to you won a new boat, and I'm willing to bet that that would work, but there's a more simplified version of this. Let's go ahead and just delete that, because what we can do is inside that same if block we can create additional checks called else if statements. All right, so if the user value equals 1 is not true, then we're not going to execute this block of code. But what we will do is then move down to the next check, and in this case, else if user value equals 2. All right, and if that's the case, then we'll set the message equal to you won a new boat. I could also do else if user value equals 3, message equals you won a new cat. All right, and then finally, what if none of these are true? What if none of them are true, and at this point then, if we run the application and I type in the word Bob, I get nothing. All right, well, there's one of two ways I can handle that. In this simple scenario, I could assign the value of string to initially to bad input, like so. So it would, none of these conditions would register, and therefore it would just stay at its default value, bad input, and that would be printed to screen. So here, Bob, bad input. But what I'd really like to illustrate for our purposes here, just so you can see, the last part of an if, else if, end if statement is just the simple else statement. And in this case, we're saying if this is not true, and this is not true, and this is not true, then, all right, well, this is the catch-all. Otherwise, just do this. In this case, we'll just set the message equal to bad input, please try again. All right, or something like you lose, or whatever the case might be. And so this time, whenever we run the application, we type in Bob and hit enter, bad input. All right, great. I want you to notice something, how I designed this code. I could have, in each of these cases, just done console.writeLine and then said you won a new car, like so. All right. I would have had to add the console.writeLine in each of these else if statements and in the else statement as well. However, what I chose to do instead was just to define a variable and have it store the message that I want displayed, and then just call the console.writeLine a single time here at the very bottom. All right, so that's just a way to simplify the code, to structure the code in a very logical, easy to maintain sort of way. If I wanted to change how this message is displayed, I might have to change it in several different places. So for example, I might want to change, whoops, let's do this, and say result, colon, space, and then display the message. I would have to make a change to every one of these code blocks if I had written the value out. But now I can just make a change in one place and just display then the message after it. So just be cognizant of the fact that you can simplify your code and you can expand its functionality while reducing the amount of maintenance that has to happen in order to add new functionality. So I feel like I've accomplished that in this case by just kind of using this message variable to store the actual message and then only using console.writeLine one time in my application. All right, so finally what I want to demonstrate to you is I'm going to comment all of this out. And in some cases, you don't need the if, else, and if. You can use something just called the conditional method. So there's a method called if with an I, two I's, IIF, and then an opening and closing curly braces. Now, in this first part, what we want to do is set the expression. So let me actually grab some code from earlier here, and we'll grab these first 3 lines of code. And I'm going to select them all and then use the button that's right next to the comment out the selected lines. And this is the uncomment the selected lines, and that will remove the little comments from each line of code. All right, so now we have the user value again. And here what I want to do is if IIF, open and close parentheses, user value equals the value of 1, then after that 1, I'm going to use a comma. And you can see I can add a true part and a false part. So here what I'll do is say the true part is car, but for everything else, if that's user value is not equal to 1, then I'll say you just want a free cat. All right. So let me do this. I'm going to go dim message as string equals empty string, and then message equals if the user value is 1, then I'll give them a car, but anything else they'll win a cat. And then we'll do console.writeLine the message, and then finally console.readLine to stop the execution. And now let's run the application. And I'm going to type in the number 1. Great. And then I'm going to type in the value Bob, and I won a cat. I guess I need to improve this just a little bit and do this. You won a, and there's the message. And I might even just add an ampersand, and then I'm going to put a period to make the end of the sentence like that. Okay? Oh, I have a better idea. Let's fix this. I don't like that. That's a lot of concatenation. There's an easier way to do this. And I'll explain this this syntax a little bit later, but inside of that string, what I'm going to do is add replacement syntax. And there's some special features of replacement syntax that we're going to see in an upcoming lesson that will allow us to format what we put in here. Like if we have a date or a currency value, we can do some really neat things. But for right now, I'll just use U1A curly brace 0 curly brace double quote, and then I'm going to use a comma after that and then put in the message like so. Okay. Now I need to explain these commas inside of the opening and closing parentheses. You see that we have this if conditional method here, and we used a bunch of commas. What those are, it allows us to separate the input parameters to each of those methods. So sometimes a method only will accept a single input parameter like console.writeLine. Now, console.writeLine can also accept 2 parameters or more. In this case, we're going to give it a string and then a value that could be used in replacement whenever it comes across a replacement code. Again, we'll talk about replacement codes at length a little bit later, but you can see here I'm passing in 2 parameters to the WriteLine method by using a comma in between them. Here we're using 3 input parameters by using 2 commas. Here we do the evaluation. Is this going to be true or false? If it is true, then we give it the true part, and then if it's false, we give it the false part. And whatever's returned back from this method, whether it's car or cat, it'll be assigned into our message variable, which will then be added to our U1A, and then we'll replace whatever that replacement code is, whatever it's either car or cat, and then we'll add an exclamation mark at the end. All right, so now let's run the application again. And here I'll type in the number 1, U1 car. See how that formatted it nicely? And we'll run it again. And this time we'll type in the number 4, you want a cat. Okay. All right. So we learned quite a bit in this lesson, just tacking on some additional features of Visual Basic. We looked at, most importantly, the if, and else if, and else, and end if statements in order to add some conditional logic to our applications. So we made some decisions, and based on values and evaluating the truthiness or falsiness of a particular expression, we're going to execute one of the code blocks inside of our if, else, end if code block. All right. We also looked at this magical if, IIF method, which allows us to, again, evaluate true or false, and then return either a true or a false value that we can then like assign to a variable in this case. Then we also talked about how to add multiple items into input parameters using commas to separate each of the values in the input parameter. And then finally we talked about this replacement syntax with curly braces and with the number 0 inside of it, and how we're able to replace a part of the string that we're giving to WriteLine by using the replacement code and then passing it the value we want to be stuck into that template, okay, for display. All right, so you're doing great. We're learning a lot, and let's continue on. We're going to keep adding on the complexity and make our applications more and more interesting. See you in the next video. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, I want to spend a bit of time talking about some of the smaller syntax elements in Visual Basic that you'll need to master in order to understand how a properly formed line of code is constructed. So in one of the first lessons, I may have briefly referred to the Visual Basic syntax having nouns and verbs and punctuation. And I want to elaborate on that just a little bit more and explain what I meant by that in this lesson. So just like the English language has parts of speech and it has punctuation, the same thing is true in software development, and the Visual Basic programming language is no exception. So we're going to talk about those building blocks to create those sentences, those basic building blocks to create instructions in Visual Basic. And so statements are like sentences. Statements are complete thoughts in Visual Basic. They're like complete sentences. And a statement is made up of one or more expressions. And in turn, an expression is made up of operators and operands. All right, so it goes statements. Statements are made up of expressions, and expressions consist of operators and operands. So we've seen statements, obviously, just simply lines of code, executable instructions that we've given the compiler whenever we type them into our module 1.vb. Expressions are, some examples of expressions are things like a method call. So console.writeLine passing in an empty string or hello world, whatever the case might be. Whenever we use the if statement, we evaluated an expression to see whether it evaluated a true or false. So the expression portion of that was user value equals 1. So if user value equals 1, then execute this code block below it, okay? And then also there are expressions of assignment where we're assigning the value of a variable equal to some other value, okay? So each of those are examples of expressions, and they have two things in common. They are made up of operators and operands. So an operand is similar to a noun in a sentence. They're things that are nameable, okay? So variables, that would be a good example of an operand. But things like literal strings, that's an operand, or a literal number like the number 7, that would be an operand as well. And so these are easy to remember because you're creating these yourself. You're giving names to variables or even classes or objects as we get further along. And you're giving value to literal numbers and literal strings, right? So operators are similar to verbs. So you have operands are like nouns, operators are like verbs, and they will act on the nouns. So they're things like, for example, the addition operator or the equality or assignment operator or the string concatenation operator. Typically, you're going to use built-in operators, whereas operands, you name them yourselves. Typically, operators are provided by the programming language. Now, there's exceptions in both cases. You could create your own operators or overload operators. That's kind of an advanced topic, so you know, this is a little bit loosey-goosey, I guess you could say. And there's quite a few built-in operators, and you're going to need to memorize many of them because it's how you're going to perform actions on your operands, the things that you come up with, the intent of your code. So fortunately, as you're getting started, you can use kind of a subset of all of the operators that are out there, and then learn them, commit them to memory over time, and not have to refer to a cheat sheet whenever you need to remember them. So to kind of help facilitate this, what I did was create a project offline called Operators, Expressions, Statements, and I merely created the code that you see here. And you don't have to type this in yourself. You can just open up this project if you want to follow along on your local computer, because I don't know that there's any real value to typing this in. This application doesn't really do anything. It's just illustrating code ideas, okay? So if you run it, it's not, I don't even know if it'll do anything, honestly. I don't think it has any, yeah, it has a console write line at the end, but that's about it. Okay, so just want to walk through quickly. This is not an exhaustive list, but this will give you a few to chew on and to work with initially. We've covered some of these already. We'll add on a few during this lesson. And you can expand your vocabulary of operators and keywords and so forth over time. But in each of these cases, an expression is made up of an operand, like a literal string or a variable or an object, and an operator. So an operator is something like the assignment operator. So here we have an operand, which is x, and an operand, which is the literal value of 3, and the operator is acting on the value of x. So the way we would read this, the value of 3 is being assigned to x. All right, so you see the associativity of the code and the direction. It will go from right towards the left. So anything on the right will be evaluated first, and then it gets assigned to the value that's on the left. All right, so that's the assignment operator. We have the addition operator, the subtraction operator, the multiplication operator, the division operator. So these are things that you would probably come to expect. Then you can see we looked at the equality operator to see if two values are in fact equal or not, true or false, x equals y. Now there's some other variations on this. We can check, for example, if x is greater than y. Now, in numeric terms, the greater than, the less than operator, the greater or equal to, and the less than or equal to operators, they're all pretty easy to understand, but you might be working with dates or strings, in which case the greater than, less than, greater than or equal to, less than or equal to might be a little harder to understand what is being compared. Is it the length of the string? Is it the whether they're alphabetical order or not, and so on. All right. Then there are conditional operators, the conditional or and the conditional and operator, so that you can tie two expressions together and evaluate them. So x is greater than y, a is greater than b, if either of these are true. So if this is true or this is true, then perform the code that you see in that code block. The AND operator is inclusive, so both have to be true in order for this to happen. So x must be greater than y and a must be greater than b in order for the code inside of the if statement to be executed. All right. We've also talked about the member access operator, the period, and how that allows us to call a particular method of an object or a class. In this case, we've been calling the writeLine method of the console class by using the period in order to access it. Now, in this way, the associativity goes from left to right. So we start with the console object, and then we call into its writeLine method, and then we pass in a input parameter of a literal string. And so in this case, also, I just want to point out that the double quotation marks, that is the literal string operator. And then there are other operators, like, for example, the as operator. Now you could say as is a keyword, dim is a keyword, that's all true, sub is a keyword, module is a keyword. But if it acts on operands, then it's also a operator. In this case, it acts on the operand of b, assigning it a data type of integer. All right, so why am I telling you all of this? Well, because the syntax rules of a programming language really do matter. So for example, I can't just do that and expect anything to happen. I mean, Visual Basic Compiler will look at that and say, what are you trying to do? You've only given me expression, and an expression, it's not a complete statement. I need more than just an expression in order to do something, okay? So in this case, we're only just doing x plus y, but x plus y what? All right, what do you want me to do with this? So in situations like these, you can see Visual Studio will actually catch these syntactical errors as compilation errors. We can't even run the application. We can't even compile this code into an executable that will run inside of the .NET Framework CLR, the .NET Framework runtime. Why not? Because the code cannot be compiled and turned into a language that is acceptable by the .NET Framework runtime. So in that case, you can see the code editor gives us this red squiggly line letting us know that we have a problem in our code, and so it anticipates the issues with the code by pre-compiling as we're typing. All right. If we were to hover our mouse cursor over it, we're going to get some very vague explanation as to the problem. Method arguments must be enclosed in parentheses. So it thinks that what we're trying to do is call some sort of method like this. Right? And even so, it's still going to have some issues. All right. So basically, we don't even have enough code here for Visual Basic to give us a good error message, unfortunately. And so essentially, we just have to be aware of the fact that when we type in a line of code, we have to kind of be purposeful and understand what it is we're trying to accomplish. If we don't have the right set of expressions filled with operator and operands, as we had here just a moment ago, then we're not creating a properly formed statement. Since we don't have a statement, it can't really do anything with that code that we write. So for beginners, all you really need to understand is that there's a proper syntax in Visual Basic, just like there are rules for the English language, just like there is proper grammar in the English language. So understanding that is a big step to solving your own problems whenever you're phrasing Visual Basic instructions that the Visual Basic compiler will accept and compile down into a language that the .NET Framework runtime can understand. So I tell you what, let's go ahead and stop right here. Let's recap the things that we talked about in this lesson. First of all, we said that statements are complete instructions in Visual Basic. They consist of expressions, and a statement is like a sentence in the English language. And expressions are things that contain nouns and verbs, the combination of the two. Okay, so actual expressions are made up of operands and operators, and an operand is a thing. It's like a variable or a literal string, something that we give value and importance to by naming it or giving it value. And so for now, you can think of, for example, the console class. That's an operand. And the variables that we've created, those are operands. Whereas operators, and we spent a lot of time looking at operators here, and there are even more than that that we didn't talk about. Like, I don't know if I said anything about the method invocation operators, but this is definitely an operator that will kick off the execution of a method, right? So there are lots of different types of operators, and you'll need to learn the operators in order to perform actions on the operands that you create, and that gives the instructions, the proper instructions to that formulate your program. Now, we've already been using these operators for all sorts of purposes until now. Even if we didn't identify them specifically as operators, we're still using them, and just understand that they are what actually do things in the application. And just by giving, for example, X, or giving console, by itself on its own line, it's not going to accomplish anything. We have to use operators. And we have to use operands. This is an operand, okay, in order to accomplish things in our applications. And that's all I wanted to say. All right, so hopefully that was helpful in diagnosing and understanding the code as you write it. All right, let's continue on the next lesson. We're doing great. See you there. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, we're going to focus on iteration statements, and a specific iteration statement, the for next iteration statement. Now, sometimes you're just going to need to loop or iterate through a block of code. You're going to need to iterate through a sequence of items, and maybe to perform a series of checks until you find a successful match, maybe to execute the same code a number of times, just because that's part of your business rules, whatever the case might be. Actually, you'll find yourself doing this more than you might anticipate. And while it may not seem all that practically useful at first, trust me, you're going to need this in your toolbox as you start to write more interesting applications. So let's create a new project, and we're going to call this for next iterations, and click OK. And the syntax is really simple. And I'm willing to bet that you're able to figure out what this will do without me telling you what it does. So here we go. All right, there we go. That's all we need. So can you guess what you're going to see in the console window whenever we run the application? Let's see if you're right. Okay, so if you guessed that you would see the numbers 1 through 10 printed out into a console window, you're right. All right, so basically all we're doing is executing the block of code defined by the for and the next statements, in this case in lines 5 and 7. Anything between the for and the next will get executed a number of times until we've reached a certain condition. In this case, we're going to start off with the value 1 and assign 1 to index. But once we get to assigning the number 10 to index, that'll be the last time we iterate through the code defined inside of the code block between the for and the next. And then we break out. And here we, in line number 9, we wait for the end user to respond that they have actually seen the content that we printed to screen, and that's pretty much all there is to it. So we're instructing Visual Basic to execute a block of code a number of times, and once we've completed that sequence of times as defined by this higher end boundary, then we'll break out of the for next loop iteration statement and move on to the rest of our code. All right. So inside of here, we can do some interesting things. So like, for example, what if I were to go if index equals 7, I could do something like then console.writeLine, found 7, like so, and we could run this. And then once we get to the number 7, we can print that out. I have an idea. Why don't we shorten this just a little bit? Like before, I don't think I showed you the then portion of the if, else statement, but you can use the then in order to combine everything on a single line like so. All right. So the then will allow you to combine a simple check with a result. If index equals 7 is true, then go ahead and perform this line of code. So we're able to condense 3 lines of code into 1 line of code. And now when we run it, we get the exact same results. Okay, I just wanted to show you that little use of the then keyword. Great. And what if, though, let's comment that out. What if, and let's bust back over here to if index equals 7, console.writeLine found 7. And now, at this point, we found what we were looking for. What if we wanted to break out of this loop? We're no longer searching for the value. We found what we were looking for. We could do something like exit 4. Okay. And so now when we run the application, the result looks a little bit different. We get to 7. We found 7, and now we exit out of the for statement, and we continue on executing our lines of code. Great. This might be a good time to talk about one of the features of Visual Studio. And again, I'm trying not to talk about Visual Studio, but you still need some tools in your toolbox if we're going to build applications. And one of those tools are the debugging tools of Visual Studio, which is probably one of the best reasons to use Visual Studio. You can actually pause and watch the execution of each line of code by simply setting a stop sign or a breakpoint in your code. And then when we execute the code and we get to that breakpoint, then we can continue to step through the code line by line or continue on and allow it to continue to execute the lines of code. So to set a breakpoint, it's really easy in Visual Studio. There's actually a number of different ways to do it, but I find that the easiest way is to find this little gray column off to the left-hand side underneath the tab heading and just click in that column for the line of code that you want to set a breakpoint on. So in this case, I want to set a breakpoint on line number 6, so I just click in the little gray area next to 6, and it creates this little stop sign over here on the left. I guess it's a circle. It looks more like an octagon to me. And then it highlights the rest of that row in red. And so now whenever we go to run the application and we're in debug time, we're actually, the execution of the application has stopped. Now, unfortunately, I got this little window that popped up and I gotta get rid of that. Move it down, but you can see that in this case the line of execution has stopped here on line number 6, and what we can do is hover our mouse cursor over the variables. In this case there's only one variable, but if I hovered over in this case the variable index, we can see its current value, and I can click what was formerly the start button. It's now the continue button, and when I run it and hover my mouse cursor over, you can see that index has increased to 2. So when I clicked continue, it executed the next several lines of code, came back up to the top, and we were able to break again on that same line of code since we're just iterating through the same block. Now I can use keyboard shortcuts, or I can use these little items here in the toolbar while we're in debug mode to step through our code. Now I'm going to ignore the step into and the step out of. They're kind of special cases and not really essential to us until we start building more complex applications. But the step over is probably what we want to use. So I'm just going to hit this step over or F10 button on my keyboard. And here I can just begin to step through each single line of code. And I can continue to evaluate what the values are. I can look at this autos window or the locals window, or even the watch window, and see the value of variables. So in this case, index is one of the local variables, and I can see it here, its name and its value. And as it changes value, notice that as we executed that for loop in line number 5, the value turned from a black font to a red font, indicating that the previous line of code changed the value of that variable. All right, so that's just a little visual cue to let us know that something just changed in our application. Let's see what else we can do here. If I have a specific variable that I want to keep an eye on, I can kind of highlight it and then drag and drop it into a watch window, so that even if I am moved off to another part of the program, I can always keep an eye on the current value of the index in one of the watch windows. All right. So the other thing that you can do, which is kind of neat, is hover your mouse cursor over and see the current value of any given variable. And I can even pin this down. So notice that when I did that, it created this little pinned area, and I can actually drag it and move it around so that as I start stepping through the code, that little window pops up here. And you might have seen it briefly change color to red whenever we hit the index 6. And I'm going to continue moving on through our code here. And at this point, we'll see that index will in fact equal 7. So we'll step into our if code block, execute the console.write line, and then we'll see what happens when we hit the exit 4. It jumped from line number 10 all the way to line number 14. And if we hit continue now, we'll just see this console window, and we're back in runtime, and I can hit the enter key on the keyboard to continue. All right, so those are just a really, really quick overview of the features. There is one cool feature that I want to show you that's applicable here since we're working with iteration statements, and that is we can configure our breakpoint by clicking the little gear wheel that appears as we hover our mouse cursor over our breakpoint. And I can say that I only want to break on this line under certain conditions. And the condition that I want to break on is whenever index equals 7. So whenever we hit that point, I'm going to say, let the breakpoint stop the execution of the code. Otherwise, let's just go ahead and blow our way through 1 through 6. And so now I hit the continue button. Let's hover our mouse cursor over our index, or we can just see it off here to the right hand side. It is in fact 7. I'm done with that now. I could say I want to keep an eye on this and just keep that around, or I can actually just get rid of the whole thing by just clicking the little X button there. All right, but you see how I was able to configure this breakpoint and make it conditional so that it only stops whenever the index value is equal to 7. And there's some other options here that I could choose. For example, I could log a message when we hit a certain situation and then continue the execution. We're not going to do any of that right now, but notice this little tab, breakpoint settings, pops up inline. Very, very neat. And we can continue on. The last thing that I want to show you, and you can see that the icon has changed from just a red, I guess it's a circle, but it looks kind of to me like an octagon. But notice that whenever I change some of the settings, it has a white plus symbol in the middle of it. Let's go ahead and turn off that. But what I do want to do, say I want to disable the breakpoint temporarily because it's not useful to me at the moment. So let me just run the application. the breakpoint is still there, but we're ignoring it for this run of our application, and then I can enable it one more time or get rid of it altogether by clicking on it a second time. And any of the things that I did here, I'd be able to also do from the debug window, where I'm able to toggle breakpoints, create new breakpoints, even make them functional breakpoints, changing their settings about when they should actually be enacted, delete or disable the breakpoints, and so on. Okay, so let's go ahead and get rid of that, save that. All right, so I also wanted to show you something cool, another feature of Visual Studio since we're on this topic and we've got some time. I'm going to go ahead and, well, we'll just leave everything where it's at. Here what I want to do is show you how to use code snippets. And if you can't remember how to use an if statement or how to use a for statement or any of the other things that we're going to learn about, typically what you can do is just type the first word. Even if you don't remember the exact syntax, you can type in for tab, and bam, it expands it out and creates a code snippet. I can continue to tab my way through and notice that there are 3 fields that I'm tabbing between, and they're all kind of in this goldenrod or yellow color. And this will allow me to change, for example, the variable name that's used as the iterator variable. So I can change it from index just to the letter I. I can change it from 1 to, let's say, we'll start at the number 3 and we'll go to the number 13 instead. And when I've finished replacing the various parts of this for statement, I can hit the enter key on the keyboard, and now I can continue on in writing the rest of my statement here. So in this case, it would just be I. Let me comment this all out, change my mind on that, and there you go. Now we're going from 3 to 13 instead of 1 to 10. All right. And another interesting thing I can do is to actually go and here, let me show you one more thing. We'll just go if tab, and here you can see that I'm checking, in this case, the only thing to replace is that conditional check. What are we going to evaluate, whether it's true or false? We just make that change there. So I equals, 3 or whatever the case might be. Let's put that in the context of this. So if tab, I equals 4, enter, and now we can continue on in here and write whatever we want to write logic-wise. So those are code snippets, another feature of Visual Studio. The final thing I want to show you about the for next statement is that you can step backwards. So if I wanted to go from 13 to 3, I could do that, but unfortunately, if you just leave it like I wrote it, it's not going to give you any satisfaction. What you need to do is actually add a keyword called step. And so I can step backwards through a for statement by saying step -1. And we can do the step to do some interesting things. Here I'm going from 13 to 3. Okay, that's cool. Let's go for tab, and here we'll go from 1 to 10, but we're going to step 2. And we'll do console.writeLine. So here we're just going to, index. We're going to start with 1, and then we're going to step 2 until we get to 10. So let's run this, and basically this gives us the ability to count odd numbers. So we print out 1, 3, 5, 7, 9. We hit 10. We break out of the for loop. So that's our ability to step 2 numbers at a time, and essentially avoiding all the evens. Okay, so there's a lot of options here. Again, in this lesson, we talked about quite a few things. We talked about the for next iteration statement and how it will automatically allow us to iterate through a block of code a number of times as defined by the conditions here. And we are assigning the current value of the iterator of the variable that will hold the current index from one number to another number. All right, so and that will define the number of times. We can obviously step backwards by using a negative step, or step over numbers by using 2, 3, 10, whatever it is that we want to use. we're able to use the if and then keyword in order to do a really quick conditional statement all in one line of code. We use the debugging tools and even conditional debugging, disabling debugging, stepping through lines of code, all of that. We looked at code snippets that allow us to generate lots of code, a little template of code that we can then go through, use the tab key to change various values. So we looked at a lot of cool little features here in a relatively short amount of time. Let's continue on. We're doing great. And hopefully you're gaining confidence in your ability to write code using Visual Basic because I know at this point now we can do some pretty interesting things. So let's continue on in the next video. We'll see you there. Thank you. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, we're going to talk about arrays. Often you're going to need to work with several related variable values. So how do you work with multiple variables that are all somehow related? They're all intended to be used as part of a group, but how can I treat them as if they are part of the same group? How can I enforce that relationship between multiple values? So as you look on screen right now, this is an example of how not to do it. Here you can see that I have a series of numbers, or variables rather, defined as variable names number 1, number 2, number 3, number 4, and I assign their values appropriately, right? Now the problem with this scheme that I've cooked up here is that I'm relying on a name, and names of things are fragile. They're not enforceable because we're making up the names ourselves. The compiler wouldn't care if we misspelled one of the names, and it would be just fine with that, and we could probably work our way through that, but still they're just kind of loosely connected together and only connected because of the meaning of the name that they have. It's not a foolproof approach towards creating related values and treating them all as a single unit. And that's really the intent here. Now, previously, I compared a variable to a bucket that's created in the computer's memory that's just the right size for a single value of a given data type. Now, to extend that analogy a little bit further, you can think of an array as a bucket that inside of it contains other little containers, other little buckets that you can put values into, okay? So another way to think of an array is that it's a sequence of data all collected together in the same variable or bucket in the computer's memory. Now, I hesitate to use the word collection or sequence. Those have a certain connotation for programmers. Collections definitely have a specific connotation to .NET developers, but you can think of an array in a sense as a grouping or a collection of data, lowercase c, collection of data, okay? So you declare an array just like you would any other variable. You start with the data type that you want to create, and then you say how many elements, or rather how many of those little sub buckets inside of the big bucket that you actually want to create. And so in this particular case, what we want to do is create a quick example of an array in action so that we'll be able to revisit this example a couple of times and learn more about arrays in the process. So the first time we'll use kind of a longhand format here. Let me get rid of this because we know that's not right. So let's go ahead, and you can see that I've already created a project called Understanding Arrays. Pause the video, take a moment to create a new project named Understanding Arrays, catch up to where I'm at, and then unpause the video and we'll continue on. And what I'm going to do is create a new array. And so to do that, I'm going to create one named numbers. And then I'm going to say how many little subcontainers I want inside of it, and then give it the data type. All right, there's actually a shorter way to do this. Let me just show you the short way because nobody ever does it this way. All right, so here we go. In this particular case, you have to remember that this number is 0 based. So while it says 4, there's actually 5 containers because you have to count 0 whenever you're dealing with arrays. All right. So there's, in other words, we're creating a bucket in the computer's memory, a variable named numbers. Inside of that bucket, there are like 5 containers, and we're going to reference each of those containers by their ordinal position, 0, 1, 2, 3, 4, 5 little subcontainers inside of our array called numbers. They're all going to be integer values inside of it. You can't mix and match. All right. And so now that we've declared our array, we can actually start assigning values and retrieving values from the array using this style syntax. So for example, if I want to reference the first item in the array, I'm going to use parentheses and then the number 0. So parentheses are doing double duty, just like the equal sign did double duty. Remember, the equal sign was the method invocation operator. Now it's also used for so that we can access individual elements of our array. So in this case, we're going to set the first little subcontainer inside of our array, the first element of our array, at index 0 equal to the value 4. And here I'll just go ahead and keep working with the next element in the array. We'll set that equal to the value of 8. And then we'll set the next element of the array equal to the value of 15. The next element in the array equal to the value 16. And then the next element of the array equal to the value 23. Okay? And that's roughly what we see that we accomplished here. The good news now is that I can just treat this array with the keyword numbers, and I can access all the items inside of that without, and they're all collected together, I guess you could say, inside of the same memory area and the same label. In this case, the name numbers. So I would verbalize this in one of a number of different ways. For example, I would say that numbers sub 1 equals the value 8, or the numbers array at index 1 equals the value 8, or I might say the second element of the numbers array equals the value 8, or something along those lines. Okay, so this is called the index, the value, the numeric value to actually access an individual element, or what I was calling a subcontainer inside of the array itself. So the numbers are indexes, and they allow you to access an element of the array. And here we're assigning the values, and we can retrieve the values in the same way that we would any other variable. Okay. So that's the nomenclature that you would use to talk about them. Now, what happens if, for example, I try to access one more element of the array? And so here, in this case, I'm going to try to access number sub 5. And here, let me do console.write, write line. And we'll just do something like, tell me how many items are in the array. How can I tell how many items are in the array programmatically? I can use a property called length. Okay, so give me the length of the array. In other words, give me how many items are in the array. And then we'll just do console.readline. So let's see what happens here when we attempt to use an extra element of the array, attempt to assign an index outside of the 5 that we defined here as the original size of the array. All right, well, we get our first exception, runtime exception that we've experienced while coding in Visual Basic. Here we have an index out of range exception wasn't handled. In other words, we were able to compile our code, but when we were running our code, we ran into a problem and it stops the execution of the code. The user can't proceed. In fact, what they'll see on their screen is dramatically different than what we see on our screen. In fact, let me just kind of stop the running of this application and show you. If we were to release this application as is, our end users would see something much uglier. And so I'm sorry for this quick aside. I just want to show you what you would see here. We'll talk about this all in depth a little bit later. Let me run the app and notice what happens. You get immediately this, stopped working. A problem caused it to stop working correctly. and then you get this unhandled exception. It spits out all this information. That's what your end user would see. As a developer running the application, Visual Studio kind of steps in and it puts up a friendly message box and explains what the situation is and how to fix it. But ultimately, the index 5 is out of range. In other words, there's a range of accepted values. And since we have created an array with 5 elements, but we try to access a 6th element, we're going to get an exception. So we can't do that. Okay. We can do something like this, console.writeLine, and we haven't looked at how to actually access a given element of an array. Here we'll do, we'll use that replacement code that we learned about earlier. So the third element of the array contains, and then we'll just do like that. So we'll use the open and closing curly braces with the number 0, and then we'll access that third element of the array. In fact, the third element of the array is not 3, the index of 3, it's the index of 2, right? All right, so just make sure you catch that. So let's run the application again. And you can see the third element of the array contains 15, the total length. The total number of items in the array is 5 items. Okay. Now, what if we wanted to actually display on screen the value of each of the items? Well, this is where that for next statement comes in. So I'm going to type in this. Watch this. This is cool. For tab, right? So we're going to go from index equals, and remember, we can't start with 1. We got to start with 0. And then we'll need to go numbers.length. But this is going to give us the total number of items, and we want to convert the number of items into a 0-based index. So we're going to have to subtract 1, right? So this is going to give us 5 items, but we really want to go from 0 to 4. So that's why we did it this way. Okay. Just remember that little dance you have to do. And now we'll go console.writeLine and then numbers, and then in between the opening and closing parentheses, we'll use the index variable. That will allow us to index into each of the items in our array and print them out to screen. And so we see each of the 5 items there. Now, let me take a moment here and just comment some of this stuff out, because I want to show you an alternate way to define your, and not only define the array, but then also initializes values all in one shot through an initialization syntax. So here we're going to go dim numbers. Now, instead of giving it the number of items we want in our array, I'm just going to leave it empty. So I'm going to add the open and close parentheses, but I'm not going to put a number inside of it. I'm going to say I want these to be integers. And then I'm going to use an opening and closing curly brace. And inside of that, add a series of numbers like so. And when we run the application, we'll get the exact same results that we got last time. And you might be wondering, well, how in the world does this work? Okay, so we were able to create an array of type integer, and instead of saying explicitly how many items we want in the array, at the point of initialization, we'll just allow the number of values that we type in here to dictate the number of items in the array. So this will automatically create a numbers sub for 5 elements rather in the array, and it automatically puts values into each of the elements. Element 0, 1, 2, 3, and 4. Then we just print them back out to screen, and that's how that works. Okay, let's comment all of this out. And moving on, let's look at the fact that we don't have to just use integers. We can also use strings. So here I'm going to create dim names. And I'm going to use that same style of syntax that we just used a moment ago. I'm going to say I want an array of names. And I'm going to set them equal to the names of some people that I have known once upon a time. Not personally, unfortunately. That would be pretty cool. All right. right, and then what I want to do is iterate through each of the items. Now I could use this same syntax that we used here and get the length and iterate through each index for this new array called names, but there's even an easier way to iterate through each of the items, and that's with a for each. So I'm going to type for each tab tab. Well, let's do that again. For each tab tab. There we go. So for each name as string in names. All right, and then here we'll go console.writeLine name. And let's go ahead and run it and see our names printed out to screen. Now let me explain what just happened there. So here we create an array of names. There's going to be 4 elements in the array. And here we're using the for each instead of the for. And this basically just says, hey, you've got an array or a collection, in this case an array. So let's just look through each item in the array. We'll copy off the current value as we're iterating through, and we'll stick its current value as a string inside of a temporary variable called name. And then we'll just work with the name variable here as we console.write it out to our application's user interface. All right. Now you can also do some other very interesting things. For example, what if you wanted to take a string and you wanted to reverse it? So you wanted to write the whole string in reverse. Let me tell you a tiny little story that on my very first job interview, I was asked to take my name. They made me go up to the whiteboard and write my name on the whiteboard. And the guy who I actually became good friends with afterwards, but at the time I was pretty flustered. He said, okay, write code to take your name and print it backwards. And I had no idea how to do that, but I promised him, said, I don't know how to do it now, but I promise you within an hour after this interview, I will know. And so I did. I wrote him an email, found his email somehow, wrote him, and he was impressed enough by the fact that I was willing to figure it out that he didn't say, no, don't hire this guy. At least I don't think he did. But at any rate, I got the job. So I don't want you to go through that same humiliation that George put me through. And so here what we're going to do is create a little example. And we'll start off with one of my favorite motivational sayings. All right, and so remember what I said about the line continuation character and how you don't want to have to scroll off to the side of the screen every time just to see all of your text. It's much easier if you just, for example, pick a spot, add a double quote right in the middle, space, underscore, and then go to the very next line and tab your way over a little bit, and then add. You can either add the ampersand before the line break, or you could add it after the line break. But basically, we're going to make 2 strings, concatenate them together using the concatenation character, and this use the underscore character in order to get them all to essentially be one line of code, even though they're spread across 2 different lines of code. So there I have a very long sentence split up onto 2 lines of code as my text. And now what I want to do is convert each of the individual individual characters that are part of the string. Remember, we even said that this was a string of characters. Well, really, a string is just an array of individual characters all kind of, put together. So what if we could take that string and convert it back into an array of characters? And fortunately, there's a really easy way to do this. So I'm going to create something called a character, or a char. I'll call it a char array, an array of characters as char equals my text dot to char array. So notice that the string data type has a method that Microsoft wrote that allows me to take that string and convert it into an array of individual characters, like so. So now here I have this char array, this array of individual characters, and I can do some really interesting things with it at this point. For example, I can use the array class and say array.reverse, and then give it my char array. What do you think will happen here? Yeah, it takes all the characters and reverses their ordinal position. So the first will be last and the last will be first, and all the others will follow suit as well. So now if I do a for each tab for each item in my char array, and here I'll just do console.write, not write line, just write my char, or actually item, because that's what I'm calling it here. This is the little temporary variable that we'll use. Then I think it's going to reverse that string for me. So there you go. This took that entire sentence and it reversed it. So you can read it backwards. You can get what you want out of life if you help enough other people get what they want. Very cool. Thank you, Zig Ziglar, for that help. All right, so you could use the for next if you prefer. I like this for each because it is so elegant and it just copies in the current value. You don't have to worry about lengths and indexes and things of that nature. You're just going to grab the next item and work with it. All right. So at any rate, hopefully this was pretty enlightening. Arrays are great. You'll learn about something called collections a little bit later in this course. Collections are awesome. They're like arrays on steroids. We're going to talk about those much later near the end of this course. But let's just continue on. We're learning lots of great stuff and we're compiling this toolbox. You're doing awesome. We'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, I want to show how to define and call simple methods. And we use the term method as an umbrella term, at least at this point, to talk about both subroutines and functions. We've been using them up to this point, but how do we create our own? Well, that's what we're going to learn about in this lesson. So creating methods will help us in a number of different ways. First of all, they'll help us to better organize our code. And you'll see that here in just a moment. Secondly, they help to eliminate duplicate code. And it eliminates the need to copy and paste the same chunk of code multiple times. And I'll talk about the dangers of copy and paste in this lesson. But methods also allow us to encapsulate a specific feature of our application in one method, and this makes that feature reusable across our entire application. And depending on how we package it, it could make it reusable across multiple applications, but that's kind of an advanced topic. And then finally, whenever we need to update that one feature of our application, instead of looking all over our source code for everywhere that we copied and pasted that code, all we got to do is change it in that one place where we defined that functionality. And all we do is just make our change in that one spot, and then every place in our code where we call into that method, it will gain the benefit of those changes that have been made. So there's a lot of benefits to using methods. It's actually one of the most important building blocks as you're building larger and larger applications. So it's definitely something we need to get under our belt. And just remember that a method, whether it's a sub or a function, it's simply a block of code that is given a name. So if it's a sub, it's going to be sub, whatever my name is, end sub. Or if it's a function, it's going to be function, whatever my name is, end function. And so whenever you go to, since it has a name, you can call it by its name in order to invoke the code defined inside of that code block. All right, so we would call whatever my name is, or whatever I called it a moment ago. All right, so again, it's one of the most important building blocks as we're getting started here for building good larger applications. Okay, so this is one of the times where I'm going to ask you to make sure you download the code associated with this lesson. Here I have a before and after folder for this particular lesson. And I want you to grab the contents of the before folder, which should be called, which is a solution and a project called Simple Method. I'm going to copy that. And what I want to do is put it in my projects folder. Now, instead of navigate to my project folder every time, what I did was I dragged and dropped the folder reference to this quick access area here inside of the File Explorer. So now if I want to get to my projects folder, I just click projects there, and then I can simply right click and paste in my folder. And now I can double click and open up the solution file, and we can begin our work inside. And so basically what this lesson is just a little name game, and let's go ahead and play it so you can see how it works. This is going to ask me a series of questions like, what is my first name, what's my last name, and then where was I born? I was born in Oak Park, Illinois, and then it'll take each of those, Bob and Tabor and then Oak Park, and it will reverse them and then print them to screen. Okay, so this is using the algorithm that we learned about when we looked at character arrays in the previous lesson. We're just going to use it multiple times, and this will make it a great candidate for extracting out some of that code and putting it into methods. So as you can see here, the code that actually implements that little name game is actually pretty hairy. What we wind up doing is re-implementing the same code a number of times in order to do that reverse string algorithm. So I'm doing it once for the first name, once for the last name, and once for the city. And so we're essentially, here's the first name, last name, and city. Here's the first name, the last name, and the city. All right, so you can get the feeling that we've reinvented the wheel a couple of times here, and that is an opportunity for us to improve the quality of our code. What we want to do is reduce the duplicate code in our application, first of all. And duplicate code in and of itself, there's really nothing wrong with it. There's no way that you can completely remove duplicate code from your application, but duplicate code is usually the result of copy and paste. And so invariably what will happen is you say, well, I need to reverse not only the first name, but I also need to reverse the last name. So let me copy and paste from up here, and I'll paste it down here. And invariably what happens is you forget to change maybe the variable name from first name to last name, or whatever the case might be. And so you subtly introduce a bug into your application that now you got to hunt down and figure out. But furthermore, if you have the same code repeated many times, then whenever changes are requested in your application, you're going to need to go and find every time you've implemented that particular feature of your application and change it in multiple spots. And that will lead to subtle bugs as well, because chances are you're not going to find every implementation of that given feature. But if we were to be able to step back and say to ourselves, you know, I'm really doing the same thing 3 times, and extract out those things that are common across all 3 of those implementations. So the little algorithm that is required to, you know, convert a string into an array of characters, to reverse it, and then combine it back together. If we were to take that and extract that out and then leave in the only things that are different about each of the implementations. I'm going to use it for a first name. I'm going to use it for a last name. I'm going to use it for a city. Well, now you've got this nice separation. I can take all of the code related to reversing the array and put it into its own method, and then I can call into it 3 times, just passing in what's different as an input parameter to that method. All right. So the second reason that you'll want to actually break up your application into methods is to simplify the readability of your code. So if there are several lines of code that do the exact same thing, you're going to find that your code is less readable. So as I'm looking at this code and I'm trying to understand what it's doing here, it's just got a lot of thick code that I have to mentally parse through to understand. Okay, I see what they're doing there. All right, I see what they're doing there. I see what they're doing there. I see what they're doing there. Wouldn't it be easier if I just took out all the code that knows how to reverse an array and put it into a method called reverse array or reverse string, or, you know, reverse string. That would be a good name for the method. And now I can just look at that name, reverse string. It's nice and friendly. It encapsulates all the functionality required, all the code required to reverse the string. And now as I'm reading through my code, it becomes very obvious what this application is attempting to do because I've made my code much more readable. So you should strive to make your code human readable, make it read as much like an English story as possible. And one of the ways you do that is by choosing good names for your variables and for your methods. And you want to tell a story as you're going through that main section of your code that calls into the different methods to do all of its dirty work. Okay. So you should strive to make your code human readable. It'll make it easier for you 6 months from now when you look at your code again. It'll make it easier for your teammates who you've asked to help you maintain the code. And it will also make you look like you really know what you're talking about. So maintenance and maintaining code is a big deal. And whether it's you maintaining your own code or other people maintain your code or you maintaining other people's code, there's a form of communication that has to go on. And part of that communication is the words you choose to use and the way you spell things and the conventions that you use. All right. So code readability, super huge in order to reduce the friction of understanding what code is supposed to be doing as you're building your applications. Okay, so what I want to do is introduce a few methods and try to reduce the complexity of this application. So what I'll do to begin with here is start off by maybe taking something really simple like taking this, for example, and moving it into its own method. So I could, for example, create a sub called display result, and inside of here, let me just say I want to pass in a message as type string. So now we have an input parameter, one input parameter, and we're going to let the user pass in what needs to be displayed out to the end user. So here I might do something like console.write results colon space and then console.write, and in this case just the message. All right, that's pretty easy, and we can easily just replace this line of code with this display result. I don't know that we've made a huge improvement to our code. However, it is obvious what it is that we're trying to do now. By making our code more readable, we're displaying the end result. All right. Small improvement, but really the key here is how do you define your own methods? Use, in this case, a subroutine. A subroutine is different from a function. It basically is fire and forget. I want you to execute, and then I don't want to hear back from you again. Go do your work, and then quietly end your execution. So we also see now how to define a parameter. In this case, we're defining a very simple parameter. It is just a string that we're passing in, and this allows us now to use IntelliSense. As we add the opening and closing parentheses, you can see that we get this message of what's expected. We're expected to pass in a string called the message, and so we then can just type in the result and it'll satisfy that. All right, so that's one version of this method, but that method's not all that useful. What might be more useful is if we were to do something like this, sub display result, and you can see that, and we're spending a lot of time here just kind of concatenating strings together. So this and equal is just taking the current value of results and adding the current item to it. So I know you probably haven't seen that before, but that's what it's doing there. I think we can simplify and remove just like all of this code by just creating a more clever version of display result. So for example, we could give it the reversed first name as string, the reversed last name as string, and then the reversed city as string. Okay. All right. Now, there's a couple of things here. The first thing that you see is that all of these input parameters that we've defined are separated by commas. So in this case, we have one input parameter, we're accepting one string, and in this case, we're accepting 3 strings separated by commas. All right. I may want to move these to separate lines because, frankly, it's a little bit annoying to have to move off to the side of the screen. Notice in this case, I didn't have to use the line continuation character whenever we're defining or calling methods, and we want to put those methods parameters on separate lines just to kind of line them all up and make them all kind of nice and compact as opposed to just moving off the side screen. We don't have to use the line continuation character. So that's a huge score for us. All right, so the next thing that we'll want to do then is do something like this. In fact, here, I'm just going to copy this. And in this case, we'll just go and instead of using one replacement code, I'm going to use 3 replacement codes. So instead of just using the curly brace, open and close curly brace, and then 0, I'm going to use also open and curly brace, close curly brace 1, open and close curly brace 2. And then I can pass in all of the things that I want pushed into that format. So, for example, reversed first name, comma, reversed last name, comma, and then reversed city, comma, like so. And here again, I don't have to suffer with my code running off to the right-hand side of the screen. I can just go ahead and hit enter on the keyboard to move them down to the next line. And now, even though this does take up a lot of lines of code, they're really just parameters that have been moved to the next line. All right. So it's really just, what, 4 lines of code as opposed to what I have here, about 8 lines of code. Okay. And the next thing you might be wondering is, how in the world did we name our new method the same as our old method? What we did was we created an overloaded version of our method. So you can create more than one definition for a method. Now look what happens in IntelliSense. Whenever I type in display result and use the open parenthesis, you'll notice that IntelliSense will show me that I have 2 versions of this method. The first one accepts 1 string as an input parameter, but if I use the down arrow on my keyboard, or the down arrow in this case, on the little IntelliSense pop-up, then you can see that there's a second version of this method which will allow me to pass in 3 different strings, the reversed first name, last name, and city. Okay, so why would you ever want to create 3 different versions of the same method? Typically, you want to create multiple versions of a method if you're creating a framework that other people will use. You can even do it for your own use. If you need to be able to call a given method in several different ways, depending on the usage or the purpose. It doesn't really make sense in this case because, you know, this application is so small, I could really just go and delete this first version if it wasn't for the fact that I was just trying to teach you how to create an overloaded method. Now, the key to creating overloaded methods is this. The method signature must be different for each overloaded version of your method. And a method signature is the number and the data type of the input parameters that are accepted as input parameters to the method. So in this case, we have 1 input parameter of type string. In this case, we have 3 input parameters of type string. We could create another version of display result that had message as integer, and Visual Basic would be just fine with that. Why? Because the method signature is different. Even though we have 1 input parameter, their data types are different. Okay? But what we can't do is this. We can't say other message. All right. Now in this case, we're going to get an error, and you can see as we hover over, it says that it has multiple definitions with identical signatures. Well, but wait a second. I named this message and I named this other message. The method signature has nothing to do with what you name the input parameter, only the number of parameters and the types of each of the parameters. So these are essentially the same method signature, even though we are using a different name for the input parameter. Okay, let me delete all that. All right, so that's a overloaded method. This forces us now to rethink how we actually are calling our code here. So I'm going to be able to delete like all of these lines of code here, all of these lines up to that point. Okay, and what I'll do is just called display result. I'm going to use the new overloaded version of it by using the down arrow on my keyboard to give me that little guidance there. And so the first thing is called, I think, first name array, and then last name array, and then city array, like so. Now I don't think we're going to get the satisfaction from this that we want, but let me try and see what this looks like just now before we go too far. Okay, and it actually does work. We don't have to do anything else. How does it work? Well, fortunately, console.writeLine is smart enough to take just about anything we throw at it. And it doesn't know how to deal with an array of characters, but it sure does know how to take an array of characters and how to flip it around and display it as a string, so we don't have to do the for next at all, fortunately. Now, we could go the extra mile if we really needed to and do something like string concatenate or concat. And what that would simply do is just take each individual element of the array and add it together. But again, fortunately, in this particular case, console.writeLine does this for us, and we don't need to do that. Now, the funny thing about console.write and console.writeLine, if you take a look at their definition, there's 19 overloaded versions of WriteLine. So again, it will take just about anything you give to it. You can see that the fourth version of it will take character arrays. And so that's essentially what we've given it. You know, we've given it that string, but we've also given it character arrays. It knows how to deal with it. Okay. That's because somebody nice at Microsoft said, you know, it might be useful if we gave overloaded versions of console.write so that no matter how you call it, it will actually do what you think it will. So look how much code we've been able to eliminate by just by being a little smarter about creating a method and then passing in the appropriate values. Okay, but we still have to clean up some of this initial stuff here. We're actually collecting these values. And so what I want to do next is actually create another method. And this time what I want to do is create a function. And a function is just like a subroutine, but a subroutine will fire and then end quietly, but not a function. A function will end and return back a value. So, for example, let's just call this get reverse string, like so. And we'll type in message as string. And we're going to expect a string to be returned from this function. So notice we've defined our input parameter, but we've also defined the data type that we would expect as a return value when we call get reverse string. So inside of this code block here, this function, we can do something like this. So dim message array is char array equals message dot to char array, character array, array dot reverse, using that message array we just got our hands on. And then what we want to do is return string dot concat, like we just learned about, and give it the message array. And that should, again, take all of the individual characters and munge them together back into a string. We're going to return that string back to the caller. All right, so let's see how that's going to affect what we're doing here. This really gets pretty simple at this point. We don't have to, and we've already eliminated some of this application, but we can get rid of, yeah, pretty much all of this code right here, these 6 lines of code. Get rid of that. And what we can do is just wrap get reverse string around the console.readline, like that. How crazy is that, right? So get reverse string, passing in a string, whatever's returned from readline, and we'll save it here in last name. Get reverse string. Now we're going to need to change these input parameter names to first name, last name, and city instead of what they were formerly named as, because we already did some of the work outside of our display result. And now look at this. We've really pared this down to just a few lines of code. And we can easily see what the code is attempting to do. We're going to grab whatever the user types in and reverse it and then display that to the screen. And so now it's starting to read a little bit more like a paragraph. And we can see that it still works, hopefully. Let's test it to make sure. And it does. Awesome. Okay. But before we say that this is finished, what I want to do is create one more version of this reverse string just for kicks. Now, what we've been doing up to this point is just passing an input parameter with using the default technique, which is something called by value, which means that whatever we pass in here will actually just be a copy of the actual value that gets passed into our method. But what if we wanted to actually make a change to a variable itself? In other words, what I mean by that is we create a subroutine called subReverseString. And instead of just passing in the message as string, we'll say, tell you what, instead of just giving us a copy of the value, so in other words, just instead of giving us Bob or Tabor, the value, give me the actual memory location where I'm storing the value Bob or the value Tabor. Give me the memory location, the bucket in the computer's memory. I want to manipulate the data in that bucket. All right. So I know that's kind of an odd way of looking at it, but here we're just passing and saying, oh, yeah, the value that we've gotten back is Bob or Tabor. But in this case, what we're saying is I want to actually have a link to that location in the computer's memory, and I'll manipulate that directly from my reverse string subroutine. All right, so to make this work, we're going to have to redo our code a tiny bit. Specifically here, and we'll just change this around a tiny bit. Instead of calling getReverseString right there, let's get rid of it. I'm going to call it, we'll call reverse_string right there as we're making the call in. Now you can see I'm going to get some problems here because this does not return a string. So I'm going to do it a little bit differently than that even. All right. And this will add some lines of code, but I just want to show you the difference between by value and by ref. So let's take, let's go reverse string, and we're going to pass in first name, reverse string last name, and then reverse string city. Okay. All right. So here, what we'll do is, instead of the default, which is by val, we'll say instead, give me a reference. So I'm going to say, pass me in by reference. So this will give me an actual connection to the variable first name or last name or city in the computer's memory. And now I can manipulate that directly. Okay. And so I'll just do dim message array as char. Array equals message.toCharArray, like so. Whoops. And then array.reverse message array. And that should be all I need to do, because this message, whoops, I think I need to do one more thing, which is string.concat. Actually, message equals string.concat message array, like that. Okay, that should work. See how we're going to manipulate the value of message, but we're not returning anything? That's because we're actually manipulating the value up in the bucket. So now let's run the application, and it still works. Okay, pretty cool. So we learned quite a bit in this lesson. Now, before we kind of wrap up here, On Developer University, I issue a decree to students, and that is that no method should have more than 6 lines of code in it. If it has more than 6 lines of code, it's probably trying to do too much in the system. Now, of course, rules are meant to be broken, but as a rule of thumb, this 6-line rule will keep your code nice and tidy and readable. Now, I've broken that rule here only because I'm trying to illustrate some ideas, but ideally we would compact this down and make this much smaller. Creating more smaller methods is preferable to creating one monolithic method with just a ton of code inside of it. So we want to create lots of small methods, create methods with good names, and let those methods drive the storyline of the application as it unfolds, as it's executing. Okay. But in this lesson, we looked at how to define our own methods, creating subroutines, which fire and then end quietly, versus functions which fire but return something of a given data type, and we declare that with the as data type name at the end of the function. We looked at creating input parameters, and we looked at creating multiple input parameters. We looked at creating overloaded versions of methods by creating methods with different method signatures, and a method signature is simply the number and the type of input parameters for a given method. We looked at how it looks like from a consumption standpoint when we use IntelliSense to show us the different versions of our methods. We looked at passing values into methods using both by val, which is the default, we're just passing the value of the bucket in, making a copy of it essentially and passing it, versus by ref, where we're saying, actually, let me deal with the bucket directly, like we did here, so that I can manipulate exactly what's in memory. So when I'm reversing those strings, I'm reversing first name. It started off as Bob, or Tabor would be a better example, and ends up as Robat, so that when we're displaying the result, it will it'll be actually manipulated by the point we get to that line number 20. Okay, and even though we've added a lot of extra code here, we really did not dramatically expand the number of lines of code. Notice we only went from like 50 to 53. A lot of this can be stripped out, right? So we could have completely reduced this code down to just a handful of lines of code. Very cool. Now, if we ever need to manipulate how the reverse string algorithm works, we just change it one little spot. If we ever want to change how the code is displayed, we change it one little spot, and we're done. Okay. All right, hopefully that all made sense, and hopefully you're starting to get a sense of what it means to write your code correctly, to make it readable, maintainable, to think and have a strategy for your code. Maybe rules of thumb that help you to keep the scope of the code on a per method basis down as small as possible. Nice and tidy, nice and understandable, nice and readable. Okay, so that's pretty much, that wraps up this topic. We'll continue on the next lesson. We'll see you there. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this video, we're going to take a look at another iteration statement. We're going to look at the while iteration statement. So if we kind of do a quick review on the iteration statements that we've already learned about, first of all, we looked at the for iteration statement, which allows us to loop through a block of code a preset number of times based on how many items that we've kind of decided in the for statement itself. So we create a counter of sorts, and it will iterate through the number of times in our counter. So there's a preset number of iterations through a given block of code. We also looked at the for each, which iterates through a block of code once for every item inside of an array. And so again, that's kind of a preset. You decide ahead of time how many times you're going to iterate through a given block of code. But what about those situations where you don't know up front how many times you need to iterate through a given block of code? You need to decide that inside of the block of code. Inside the block of code will dictate how many times to iterate through the block of code. I'll give you a quick example of that. Well, in those cases, you'll use the while statement, and you'll test to see if a certain condition is true. If it's true, you'll continue to iterate. If it's false, you'll stop iterating. You'll break out of the loop. And then we'll also look at the do while statement, which is very similar, except it guarantees that you run through the block of code at least one time. So we'll look at that subtle difference in this lesson. To begin, you can see that I've already created a new project called while iteration. So you can pause the video, catch up with me. I just created a new project, named it while iteration, and there's going to be a lot of typing. So what I'll probably wind up doing is pausing the video while I type, and then I'll pause the video, or you should pause the video after I'm finished typing so that you can type in all the code that I typed, and then we'll explain it and walk through it together. All right, so here we go. I'm going to start with a really simple example of the while, and then we'll blow it out to a much more interesting example, something that's very practical that we would probably wind up using in a real console window application by creating a menu. But let's start simple. And so again, a lot of typing. I'm going to pause the video right about now. Okay, so this is a pretty simple example, like I said a moment ago. Here, all I'm doing is using this while and while statement to create a block of code. And we'll continue to execute this block of code until the user response variable is no longer true. When we set it to false, then we will break out of this while and while statement and continue on with the execution of our application. Now you'll see here that I am keeping track of a counter. So I have this counter variable that I've created in line number 5, and then line number 8, you can see that I'm adding 1 to that counter variable by taking the current value of counter and adding 1 to it. This is just to let me know that how many times I've actually run this block of code, just for a simple example. And then I'm going to print that to screen that this code block is executed that many number of times. And then I'm going to ask the question, do you want to continue or not? If the console.readLine is equal to y for yes, then we'll return true. When user response is true, then we'll go and execute this block of code another time. But if it's false, then this will no longer be correct or true, and we'll break out. And let's watch this actually run. The first time through, I'm going to type in the letter Y and hit enter. I'll type in the letter Y and hit enter. I'll type in the letter Y and hit enter. And then I'll type in the letter N and hit enter. And now we've finished, and I can press enter to exit. Okay. So what the while and while statement does, just to recap, is that it will continue to execute a given block of code until a given condition is no longer true. In this case, user response is kind of the key that we're using here to determine the whether we should continue running through this block of code or not. All right, so again, a very simple example. What I'm going to do is actually select this entire block, comment this out. It's not a very practical example, so I want to give you something much more interesting to work with. And so for this next example, we're going to create a menu system like you might have seen if you ran DOS programs way back like 25, 30 years ago. Okay, so here we're going to go ahead and start typing. I'll pause the video and then you can catch up. Once I finish typing in, you'll want to pause the video, type in some of the code yourself. Okay? All right, so you can see here that, and again, please pause the video. I'll give you an opportunity to type in all of the code. I'll give you a nice clean screen like this. Pause right now because we want to start by writing this code to display a menu. So we're doing something similar here with the user response. We're just going to call it display menu this time as a Boolean. We're setting equal true, and while display menu continues to be true, then we'll continue iterating through. Now, you can see here that I did not have like an equals true. That's kind of redundant. You don't need to do that because display value, or display menu rather, is already a Boolean. It's going to be true or false. So all we need to do is just check whether the expression, in this case, it's just a variable, equals true or false. Well, display menu already equals true, or it's going to equal false by its very nature because it's a Boolean. So you don't have to do the equals true or equals false part whenever you're evaluating a Boolean. Okay, so here's what we're doing. We're actually calling this other function called main menu, and then main menu will return back to us a Boolean, and then we'll decide whether to rerun the main menu based on the response that we get from main menu. So the real work goes on in this function main menu is Boolean. Here I'm going to clear out the console calling the clear method. All right, so that's a new method in the console. Here we'll just wipe out everything that was currently being displayed on screen. Then we're going to say, would you like to either play the print numbers game, the guessing game, or would you like to exit out of the menu system? Here we're going to retrieve the result from the user. What would you like to do, 1, 2, or 3? And here's where we then decide what are we going to actually do. Are we going to call into another method called print numbers because they want to play the print numbers game, or are we going to call into the guessing game method, and I'll show you those in just a moment because they selected number 2, or do you want to return false? All right, so in these cases, these methods will return a true or false. Here, when they want to exit, will return false. That'll get bubbled up through main menu into our main, and display menu will be set to false, so we'll break out and end the program at that point. Okay, so if they type in anything else, then we'll return true, which will return back to here, which will then set display menu back to true, which means we're going to call main menu again. We'll clear out and then say, all right, well, you didn't give us 1, 2, or 3, so I'm going to give you another chance to answer the question. And if you ever get confused about the flow of this application, just set a breakpoint and step your way through it using the debugging tools, right? So you can see how this actually works. Now, inside of the print numbers and the guessing game, for now, all I did was just implement console.writeLine. We're going to come back and flesh this out. So I've just stubbed out this method for the moment. But in both cases, we're going to return true, saying, okay, we finished the guessing game, or we finished the print numbers game. Why don't you just go ahead and re-show this menu to the user so they can decide what else they want to do inside of our application. So the nice thing about this little setup, and you can use this same little scheme that I've cooked up here to create multiple menu levels inside of a DOS-based, or rather a console-based application, okay? We'll flesh out these to show some more features of the while statement, and then also we'll look at that do while loop as well. Let's run the application and see how it works. So the first time through, we see there's a choose an option 1, 2, or 3. I'm going to choose number 1. And even though, unfortunately, you see that nothing really happened, the reason is because I forgot one line of code in both of these. Console.readLine, because we want to be able to show that text before we continue on. Okay, here we go. Let's do it again. Print numbers game here. I'll press number 2. The guessing game here. I press number 3, and it exits. All right. So that's how the menu system works. Now let's focus on another aspect of this print numbers method and the guessing game to look at 2 different coding examples revolving around the loops, the do while and the while loop. Okay, so I'm going to pause the video again here as I type in some more code. All right, so I went ahead and fleshed out the print numbers method. You can pause it and catch up here. And then I also created this guessing game method. You can see most of it on screen right now. Pause it right here if you want to catch up. And then you can pause to see this end part in lines 82, 83, 84. So like I said, a lot of typing. But you'll definitely want to catch up with me and type all this in. Let me explain a few things about how this works. So the print numbers game, let's just go ahead and run the game and see how it works. Let's choose number 1, and we can type a number. I'm going to choose the number 7, hit enter, and you can see all it does is just prints out from 1 to 7, and that's pretty simple, right? Then let's play the guessing game. It's a little bit more involved, and we get to guess a number between 1 and 10. This is where things start to get a little bit more interesting. I'll guess number 3. That was the wrong answer. Number 4, number 2, number 6, 7, 8, 9, what did I miss? 5? All right, it took be 9 guesses. All right, so we randomly choose a number from 1 to 10. It's pretty cool. And then we keep asking, what do you want to guess the number? We could improve this, and maybe that's a good exercise for you to say you're getting warmer or you're getting colder or it's higher or it's lower. Maybe give some hints as well. But now we can exit out of the game. So the print numbers game, recall, it was fairly simple. All we're doing here is just allowing the user to type in a number, and then we're going to actually read that number from the readline method. And notice that I've got this little cint. We're converting readline because it returns to us a string value, as you can see over there on the right hand side. But what we need to work with is an integer value, and the bucket sizes are different, so we're going to need to convert from the string, which if they type in the letter, the alphanumeric character 7, we need to convert that into the integer value of 7. Those are two different things, all right? So now that we have an integer, we can work with it in a mathematical sort of way, adding numbers to it and so on. As long as it's a string 7, if we were to attempt to add 1 to it, we'd probably get 7, 1 instead of 8, okay? At any rate, we create a counter just to keep track of how many times we're actually iterating through, and we're going to continue to iterate through until we get to the same result value that the user typed in, at which point then we'll pop out of our looping statement and continue on. All right, so for each number from 0 to, or as long as we're continue to be less than the value that was typed in, we'll continue to iterate through, but when this is no longer true, then we'll pop out of the iteration statement, okay? All right, so let's move on and look at the guessing game now. In the guessing game, you type in a number, and we are going to try and guess the number that the computer has selected. How do we get a number that the computer selects? We're going to use this class called Random. Random is a class created by Microsoft. Now, it's similar to the console class in so much that it's part of this library of code that Microsoft's allowed us to use inside of our applications, and it specializes in creating random numbers. But the way that we're using it is a little bit different. Like in this case, notice that all we had to do is just say console class.clear, console class.writeLine. Whereas in this case, we have to do something a little bit special. We have to create a new instance of the random class. And so we're creating a compartment in the computer's memory, a bucket in the computer's memory sufficiently large enough to hold this random data type. All right, and so we're going to call that bucket in the computer's memory random, lowercase r random. All right, so it's a little bit different than in the usage, and I'll explain the reason why, the different usage in an upcoming lesson when we talk about classes. All right. But at any rate, so now that we have an instance of the random class, we can use the random class's methods. In this case, we're going to use the next method to grab a number between 1 and 10. So we give it what's called the lower boundary. So I want a number that starts anywhere from 1, but I don't want you to go to 11. So that's the upper boundary. Don't go to 11, 12, 13. Stop at 10. So it's going to pick a random number from 1 to 10 and store that number here. We're also going to keep track of the number of guesses for the user. So if it took them 5, 6, 7 guesses, whatever the case might be. And then we're also going to create this incorrect Boolean flag, because I'm going to anticipate that the user will be incorrect a number of times. And this will be what ultimately breaks us out of the do while loop and say, you were correct. It only took you 12 guesses, okay? And then we'll actually show the number of guesses on screen. Now, what happens inside of this code block is important. Notice that we're not using the while statement, we're using that do while loop that I alluded to a moment ago. And remember, the quality of the do while loop is that it guarantees we're gonna run this code at least one time. So in this case, I need to at least one time make sure that the user can see that they can choose a number between 1 and 10. And then every subsequent time, I'm gonna ask them again, all right, you were wrong, which is pick a number between 1 and 10. You were wrong, pick a number between 1 and 10. So I needed that inside of the code block, inside of my loop, and I needed to run it at least once. That's why do while loop made sense in this example, okay? Now, we're going to retrieve the guess from the user, and then we're going to increment the counter of guesses. Now I could have done something like this, like I did previously, guesses equals guesses plus 1, but I chose to use a little shortcut, which is the plus equal, and so those two lines of code are equivalent. I just had to type fewer characters. So take the variable guesses and add 1 to it is essentially what line number 74 says. All right, next up, we're going to take a look here at the little check that we do. Now, we're going to grab the random number from the user. And this is the important part. Notice that random number is an integer, but I'm going to convert it to a string by calling the toString method. I could have done something like we did earlier with cstr, like that, and that would work just as well. So I'm going to convert this value to an integer. I'm going to convert this value to a string. I'll just go ahead and leave it like this. So we're converting data types. So this is an integer, but I need it to be a string so that I can compare it to the result. I just did the same basic thing 2 different ways here in these 2 different methods. But it's essentially the same kind of check. If the guess is incorrect, then incorrect will equal, or I'm sorry, if the result is equal to the random number, so if they guess the correct number, then it's no longer incorrect. It'll be correct. So we're going to set incorrect equals to false, which will then break us out of the loop. However, if they are in fact incorrect, incorrect will stay true. And we'll just say, hey, you're wrong, try it again, and we'll loop through this block of code another time. But assuming that they got it correct, we bust out, and then we just merely print this to screen, and then we return true in order to get back to our menuing system and allow somebody, the user, to choose a new game. All right. So hopefully you learned quite a bit in this lesson. We looked at a simple use case where we're just using the while statement in order to evaluate something and decide whether we should continue to iterate through the block of code based on something that happens inside of the block of code. We looked at how to create a menuing system using the while loop. And then we also looked at using the while loop in some creative ways in a more practical example here. And then we looked at using the do while just to compare the while versus the do while. The only difference is running the block of code a guaranteed time, at least once, versus not running it potentially one time. And then we also looked at a few other things like converting types using the cstr, so convert to string and convert to int method. We also looked at using the plus equal operator. So we also looked at the random class and how we're able to generate a random number. Now we can create some interesting little games. All right, so hopefully that was a pretty helpful lesson. A lot of typing, but again, that's good for you, creating muscle memory. New observations come whenever you're typing the code in yourself as opposed to just watching somebody else do it. So make sure you're getting your hands dirty in the code. All right, we'll continue on the next lesson. We'll see you there. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. Now, many types of applications that you'll wind up writing involve text, whether it's text that you'll need to feed into other applications, or text that you'll retrieve from end users, or text that you will actually format for display to an end user. So there's this notion of massaging data, changing it in subtle ways in order to format it specifically for input to another software system. Professional software developers spend a lot of time taking data, changing it in some way, and then putting it into another format for ingestion into another software system, or formatting the data for display, or looking at the data that's been input or by an end user or by another system and ensuring that it's in the right state, that it looks correct in order for it to be used inside of our application. So mastering the manipulation of strings is a vital skill in Visual Basic. Furthermore, the string data type can hold a lot of information. It's actually, when you compare the buckets and the sizes of the buckets in the computer's memory, the string bucket is a massive bucket if you want to continue that analogy. So efficiently working with strings is another vital skill in Visual Basic. And in this lesson, I'm going to demonstrate several common string manipulations that are made easy by both Visual Basic proper as well as the .NET Framework class libraries and the inherent functionality that it baked into the string data type, the string class. Okay, so you can see that I've already created a new project called Working with Strings, and we're going to do several different things. We're going to work with special characters inside of our literal strings. We're going to format strings for display using the replacement syntax that we've already looked at a couple of times. We're going to look that it has actually more functionality than what we've seen up to this point. We'll look at just basic string manipulation, pulling things out, putting things in, breaking it apart, things like that. And then we'll take a look at working with large strings more efficiently by using a special class called the string builder. All right, so let's begin by looking at how we work with literal strings and special situations with literal strings. So for example, I might create my string equals my so-called life, and I have a couple of options here. If I want to say this in an ironic way, I could separate so-called using a single quote, but what if I needed to use a double quote? Unfortunately, if I use double quotes, it's not going to look quite right, and I'll get some errors here because we're not able to tell the Visual Basic easily that we just want to use a double quote here inside of our literal string. So to fix this, you can escape double quotes by using double quotes together. So when I pair up double quotes like so, we're saying we want this to be treated as a double quote inside of a literal string. Same thing with this second instance right here. And so we're able to treat the whole thing as a literal string. And if we were to print this now, let's go console.writeLine my string, and we'll go console.readLine. It will actually print out correctly for us. And I just hit the F5 key on my keyboard to run it instead of hitting the little run button, the start button on my toolbar. You can see it formats it correctly, my double quote, so-called double quote life. Great. All right, so next up, let's comment that out, and we'll take a look at what if I need to add a new line or a line break in between a literal string. So here I might have my string equals what if I need a new line. All right, and I want to put maybe that new line character right here. How do I do that? Well, we've already seen the little technique that we've used to kind of add two literal strings together using the ampersand character, right? And so what we can do is actually in between the ampersand characters use the special constant called VB new line. All right, and there's a bunch of these little constants that are available for VB. If you type in VB and you look in IntelliSense, some of these have very specific usages that may not make sense here, but I'll show you a couple of these throughout the remainder of this lesson. But for now, we just need something that tells Visual Basic that we want to create a new line right in the middle of our literal string. So let's go ahead and run our application now, and you can see that we were able to break onto a new line, even though it's one literal string here that we created on line number 6. All right. What if I need to add a tab in the middle, a tab spacing in the middle of my literal string? So what if I need a tab in my line? So the same thing would be true here. I'm going to go ahead and start the process by splitting these two segments into two literal strings and appending them together using the ampersand. I'll add a second ampersand and glue them together with then a VB tab. So another constant from Visual Basic, the VB tab constant, and now when we run the application, you can see that it puts a tab spacing in between the two segments of my literal string. Okay, so that's how you insert these special characters or these special situations into your literal strings. All right, next up, let's talk about the formatting, the special formatting that we did inside of strings using, remember, console.writeLine, and we were able to say, hey, there's this replacement syntax, and I can replace that with something like Bob. So I can do hello, comma, and then the replacement code 0. Whoops, and let's go ahead and just remove that part. So we did that, right? And we could see something like this, right? So what if, let's get rid of that, and let's go back down here. What if I need to do that same sort of replacement code, but inside of a literal string? Instead of using console.writeLine, because you saw that wouldn't work, I can use string.format, and it's identical. We can do the same sort of thing with that. So hello, comma, replacement code 0, Bob, exclamation mark, and let's go ahead and dim this. String equals string.format. There we go. That's the correct incantation. And we get the results that we're looking for. So string.format will allow us to add the little replacement codes, the formatting replacement codes here inside of a literal string. Here I just used another literal string, but we could use a variable or whatever. All right. So that's a very simple case, but let's look at some more interesting cases. So for example, we already looked at an example where we were able to use multiple input parameters. So string equals string.format, and then we were able to do something like the make 0, the model 1, and the maybe even year 2. Of course, this is 0 based, and we will do, so we have a very specific format that we want to print our string to screen. And then we can also then add in the values that we want. Like for example, BMW, 745 Li, and 1995. All right, and let's go ahead and put some of these on separate lines so you can see them. So I'm going to add a line continuation character right after the equal sign. And then I'm going to go ahead and split these off into different lines as well for readability's sake, like so. So this is all one line of code, even though I split it off into multiple lines. And now let's see what we get whenever we run this. And the key notion here is that we're able to insert multiple replacement codes inside of a literal string by just supplying then a list of input parameters after the template that contains the replacement codes. It's 0 based, so the first item, the second item, the third item will be replaced in to those replacement areas that have the curly braces and the index. Now we can mix things around. For example, like I could take the 2 and put it here, and take the 0 and put it there. And then I could also use the same replacement code twice inside of the same string, so that I could essentially use that same number 1995 2 times. Of course, this will be nonsensical because the make is not 1995, but you can see at least I'm able to switch around the order. It does not have to be just in the exact same order as inside of the template as we have the items that we're passing in. But this is still element 0, 1, and 2. We're just putting them in different places inside the template and even reusing them multiple times. All right, let's comment all of that out. And now let's take a look at an even more interesting usage of this. So my string, and say that we wanted to format a string for a specific purpose. Like we wanted to take the number 2335, and this number, we want to represent it as currency. So in that case, inside of the replacement code, we're going to use the colon and then a special replacement code formatting syntax, and this will represent this as currency. Now, if you're in another country, and for example, if you're in Great Britain, it will represent this based on your operating system's locale feature. So you may have it represented with the British pound sign as opposed to American dollars with the dollar sign. And so it's smart enough to know how it should be represented on screen. In this case, you can see the dollar sign 2335. All right. Here we're going to do the same thing, dim my string as string. Now, you may have noticed here that I was able to do this and not declare a data type. I don't recommend that you do that. It's kind of an advanced topic to explain what happens when you don't do that. I don't want to get into that right now. Let's just go ahead and fix the code. But that was my mistake, but it'll still work, okay? But it has a different connotation and some downsides, so we'll just not do that. All right, next up, let's format this number 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, but let's format it as a real number with commas and decimal points at the right spots. All right, so I'm going to use this special format code :N. All right, and so now let's run this, and you can see that it makes it into an easily readable number of 1,234,567,890.00. Okay, so that's the N formatting code. And then here, dim my string. What if we needed to represent a number as a percentage? So string.format, and we want to take the number 0.123 and represent that as a percentage. So again, we'll start with the replacement code 0, but I'm going to use :P this time. And now you can see that it will print out the number as 12.30 or 3% with the percent sign. It also uses the decimal place in the correct spot. So that's how you work with the replacement code and the formatting of a percentage. And then finally, you can create your own custom templates, I guess you can say. Replacement codes using, for example, I want to create 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. I'm going to create a phone number. So I want to use the way that you would represent a phone number in the United States. Which is 3 digits for an area code. So I'm going to use ###, which means just 3 numbers, the first 3 that you have here, and then a space, and then ### ###. Okay, so that's the format of a phone number. I could even do something like this, phone : just to kind of flesh out this example a little bit. All right, so now let's see that in action. Let's run the app. And whoops, didn't do something here. Oh, that's right. All right, I didn't give it the replacement. So here's what we need to do. Wrap a curly brace, set of curly braces around it, 0, and then : and now this becomes the template for the replacement code. Okay, now let's run the application. And you can see it formatted it using the numbers that I supply. What if I were to supply more numbers, we'll put a 1 here at the end, than what the template can hold? Let's see what happens. What's the behavior here? Well, notice that it pushes it to the it pushes it from right to left. So it's going to honor the template from right to left. Now it's going to push more digits into that area code area, unfortunately. It's not what we would probably want. However, we should probably validate our data to make sure it's an actual valid phone number before we do any formatting with it. All right. So moving on, we're going to talk about dealing with strings, large strings. We already said that the string bucket is very large. The problem with working with strings is that they are what's called immutable. So whenever I put a value inside of a bucket that's holding a string, or a variable that's holding a string, if I want to change what's in that bucket, I essentially, what's going on behind the scenes, the .NET runtime is going to create a second bucket. It's going to pull all the values into the second bucket, plus the new value that you want to append to it, and then it's going to remove the old bucket, and then it will change the label on the new bucket. And so it does all this for you behind the scenes, but it's a very intensive process to make changes. So if I were to do this, for example, just to kind of illustrate what you should not be doing. And let's go for tab index equals 1 to 100. And inside here, I'm going to go my string plus equals, or actually ampersand equals. So take what the current value of my string is, and I'm going to add on the index. Now I'm going to convert that CSTR to a string, okay? So that I can take this numeric value and then convert to a string and then append it onto the end of this string. Plus, I'll go ahead and append on a dash dash, just so we can kind of see that in action, like so. All right, and then we'll run the application, and you can see that it'll do it pretty quickly. We get from 1 to 100 with double dashes in between, but what we had to do, that little maneuver behind the scenes 100 times, and unfortunately that will be very processor and memory intensive. That's probably not the way that we want to append a lot of strings together. Instead, we can use a special class whenever we're working with a lot of strings, and we're going to do a lot of appending of strings, and we don't want to take up more memory and processing power from the computer than we absolutely have to. So we're going to use a special class called the string builder. So here in this case, instead of declaring my string as a string, I'm going to create it as string builder. And so in this case, you'll see that I'm going to type this class name string builder, but it cannot find the string builder class in the .NET Framework class library. Now the reason for this I'll explain later, but notice that as I hover my mouse cursor over it, it shows a red squiggly line. And this tells me there's an issue, the type string builder is not defined. Now I know that it exists in the .NET Framework class library. So what I'm going to do is actually utilize this little light bulb that popped up underneath the word string builder. And it gives me an option to either do one of two things, actually several things, but these first two are the most important. I can either say, give it to me because I know it exists in the system.text.stringbuilder namespace. Whoa, what's a namespace? We'll talk about namespaces later. So it's like a last name for your classes, all right? Or, as you can see, I can, as I get the little light bulb popping up here, I can import system.text. And when I do that, it will add this little line of code at the very top, the very first line of code, to import that namespace so that it can find this class inside of the .NET Framework class library. So, like I said, the class name is string builder. I know it's somewhere in the .NET Framework class library. I just have to go to the right shelf on the library to find that class. All right, and so that's all I'm saying here. Hey, go to the system.text shelf, and you'll find a class named string builder there. So we're just giving a little extra instruction to Visual Basic to where it can find this string builder class inside of the massive library of functionality that Microsoft gave us. Okay, so we'll just do that. And now that we've included or found that, I'm going to actually do as new string builder. Again, we'll talk about the new keyword a little bit later. And this time we'll go for tab index equals 1 to 100, enter. And inside of here, what we'll do is my string dot append. So we're going to use the append method, and it's more memory friendly than using the ampersand equals in order to append two strings together. This will not perform that little dance in memory that we suggested earlier. So in this case, all I need to do is use the index. All right. And I don't even have to do that little conversion, but I'm going to anyway. CSTR index to convert that number into a string, and then my string dot append, and we'll go with the literal string dash dash. Now the result will be identical. However, you're going to see a strange behavior here at the very, No, it didn't. Okay, very good. So you can see that we were able to get these exact same results. It was just much more memory friendly than doing it this way, okay, using the string builder. All right, well, let's continue on. I'm going to comment all that out and move on and talk about doing some string manipulations by being able to identify or manipulate the certain parts of the string. So I'm going to start off with a phrase from a song that I like. I'm going to add a space, and then last summer we took threes across the board, period, space, space. All right, so I have a leading space in front of this phrase, and then two trailing spaces at the end. And we'll look at how to trim those off in just a little bit. First thing that I want to do, however, is set my string equal to just a subset of these. So I just want to pull out certain words or certain phrases inside of the string, and I can use my string.substring. Look at that method that it gives us, and I can choose to say, hey, start at position number 13 and return back everything, count 13, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Bring back everything after that and then print it to screen. And you can see we did that. I can also say, well, this is the starting point, but I can also give it an ending point as well. So I'm only going to choose 15 characters then and print those out. So we took threes as opposed to the entire message. I just grab off 15 characters, put them in my string. I can do something like this. My string equals my string dot to upper, and that will make the entire string uppercase, like so. Or conversely, I can make it all to lower, like so. And it's all lowercase. Furthermore, I can replace characters. So my string equals string.format. Whoops, I'm sorry, string, let's start that over again. My string dot replace. And what I want to do is search for the old character, which will be just a normal space character. And I'm going to replace it with double dashes. So for every space that we see, it'll be replaced with double dashes. And you can see then we get the following with 4 dashes here at the very end, because we had 2 spaces here at the end of our original string. And you know, one of the other things that we can do with strings is get the length. So for example, let's go ahead and do my string equals string.format, and I'm going to say my string is so many characters long. All right, so we'll start there and say, show me my string dot length. Just like we used with the array to see how many elements are in the array, we can also do that with a string. Again, a string is just really an array of individual characters, right? So we can see how many characters are actually in the string and print that out. My string is 47 characters long. Very cool. Okay, now what I'd like to do, I'd like to use the trim function, and so we're gonna just add on to this. After trim, then we're gonna print off the length of our string. So what trim will do is actually remove any of the leading and trailing spaces for a given variable, or in this case a literal string, and then it will return back the new string without those leading and trailing spaces. However, in this case, since it returns a string, I can continue to call another function or property of the string, and I'm going to call length again. So I'm chaining together commands. This is a string. This method operates on the string and then returns a string. And since it returns a string, we can then go ahead and call another method that we get access to from the string class. and that is the length. So here we go, and we'll run it this time. And so we've cut off 3 characters. And so you can see after we've called the trim, it's only 44 characters long. Okay. All right. And so we can also, just so you know, do myString dot trim. We can only trim off the start or trim off the end. Okay. So you have some options there. You don't have to trim all the spaces. You can just do the first or the last spaces using the trim start or trim end. All right. So that's pretty much all I wanted to show you. But ultimately, I would say that you should take a few moments and look at the other functions that or methods that are available on the string class and just take a moment to learn about them, because there's a lot more that you can do. Some of these won't apply, but some of them will. And before you go and just start trying to manipulate strings and you know, write like more than 1 line or 2 lines of code to make some significant changes to strings, just remember that you could probably find an easier way to do that just using the built-in string method. You may have to get a little creative sometimes, but you definitely can figure out how to manipulate the string to make it exactly the way you want using the built-in functions. You just have to find the right combination of functions and call them in the right order, and it'll probably make your life a lot easier. All right, so that finishes up our discussion of manipulating strings. Let's do the same thing with dates and spans of time in the next video. We'll see you there. You're doing great. Thank you. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, we're going to learn how to manipulate and display dates. So how to add values and subtract values from dates. Date math can play with your head. How to display different parts of a date, or how to use some of the built-in features in Visual Basic and the .NET Framework class library to display dates in various formats. We'll also look at how to work with spans of time, so 3 years, 5 years, 1,000 days, whatever the case might be, and subtract and add values to those, and a lot more. So this will be fun. You'll need to work with dates for the same reason you'll need to work with strings. In business applications, dates are pretty used frequently for things like project management, for content management systems, for order management systems, and so on. So we've learned how to work with a string and an integer, and we've learned how to work with a Boolean. Now we're going to add a new data type that allows us to work with dates and times, and then later a new data type that allows us to work with spans of time. So we'll start off by working with dates. So here we're going to go dim my value as date, and if we were to just work with the date by itself, I think it's important for you to see this right off the bat. Let's go ahead and just write out the value, the default value of a date, and see what we get. Because at this point we've not initialized the date. So it's the equivalent of an empty string or the value of 0 for an integer, which is the initial value, and that's generally not what we want to work with. But I want to show you what you'll see if you were to work with an empty date. It'll give you some representation of a date. It just might not be what you want. All right, so let's go ahead and run the application. And so it's going to give us January 1st, 81 at midnight. Okay, so that's probably not the value we want to work with unless we want to see how many minutes, days, and seconds since January 1st, 1 AD at midnight. Instead, what we'll want to do is initialize that value either to a specific date in the past or future, or if we want to work with now, there's a special function in Visual Basic that allows us to work with this moment as the application is running. It's called the now function. So now whenever we run the application, we'll see that I'm recording this on May 24th at 10:35 a.m. All right, so what if we want to format that date for display? Well, there's a couple of different ways, a couple of different built-in features of dates that will allow us to format it for display, featuring different portions or representations of dates. So let's go my value dot to, and you can see there's just a bunch of these to methods. So to local time to long date string, let's use that one first, to long date string. Then we'll go console.writeLine, my value dot to short date string. Let's do the same with times, console.writeLine, my value to long time string. And then you're going to see that there's not much of a difference between the two, but I wanted to, for the sake of completeness, show you the to short time string as well. And let's go ahead and run the application. We should see 5 representations of now on screen. So again, this is without the default format. If we print it off, we'll just get the date and the time and the AM PM portion. The long, here let's compare these and put them right next to each other here. So the long date string will give us Tuesday, May 24, 2016, nicely formatted. And again, this will depend on the culture of your computer. So if you are in Europe or if you're in some other country, you might see the default representation of the date different than what you see on my computer, which is set to the culture being English United States. And this is a common way that we would represent dates. So here on the short date string, we just see the month, day, year. Again, you might see day, month, year, which is common in Europe and other countries. Then the time, the long time and the short time, pretty much the same. The only difference is that with the long time, we see the seconds, not just hours and minutes, and then AM or PM. And there's different ways that we can represent if we want something a little bit more custom. So for example, we can just pull off a specific portion of the date. In this case, my value dot month, and I'll use ampersand and then 2 dashes and then my value dot year. And so we can grab off just about any portion, even minute, milliseconds. We can pull off the time of day. We can pull off day of week, for example, day of week, day of the year, whether or not this is daylight savings time or not that we're currently in, the time of day, and so on. So I'm just going to pull off day of week just so you can see this, and we'll run the application. And you can see that the day of week is 2. This starts with Monday as the first day. I think Sunday as the 0th day. So just 0 based, I believe. But 5 would be the month, and then the day of the week would be the second item or the second index, which should be the 3rd item, I think. Okay, but what if I wanted to print something off a little more friendly than that? For example, what if I wanted to do the my value, and I wanted to see, for example, the actual the friendly month, like this is May when I'm recording this. So what I can do is call toString, toString, and then I can use a special formatting provider. And so in this case, I know that I can just use 4 capital M's in a row in order to grab off just the month and print that to screen. So you can see here, this will print off just the month of May. And for more information about that, there's this page you'll want to go search for online, custom date and time format strings. Search for this, custom date and time format strings, on msdn.microsoft.com. So just go to bing.com, type that in, and then it should get you to this page. And you'll see that there's all these different formats that we can use to pull off. Just, for example, D, lowercase d, would give us just 1 through 31. Day of the month would give us 01 through 31. So that's not all that helpful, but we can pull off the HH, for example, giving us a 12-hour clock, or capital H to give us a military clock. Okay, so you can see examples here. I use the 4 M's to give us, you know, the full name of the month, or we can use 3 M's to grab a abbreviated. For December would be DEC. For March it would be MAR, and so on. And here we can grab off the different years and different formatters for strings by just using toString and then passing in the formatter that we want to use. All right, so I just wanted to make you aware of that for reference. Now, I said earlier that we can also do some date manipulation by adding and subtracting days and hours and just about anything from our date. So here we go, console.writeLine. And here we're going to take my value and I'm going to add, and notice that I can add lots of different things to it. I can add a time span, which we'll talk about time spans a little bit. But more importantly, let's add days or hours or milliseconds or minutes or months or seconds or even years to the current day. So if I say, hey, I want to add 3 days, I'm saying what will be 3 days from now? So I'll go add days 3, and then I'm going to chain together another method. Now remember what I said about chaining previously. Here we have a date. I'm going to call the add days method to add 3 days onto the current date. And notice that it returns back to me in IntelliSense. You can see that it returns another date to me. So since it returns a date, I can call another method on the date, and I can do something like toShort date string like so. And now I'm going to say 3 days from now would be the 27th, right? So today is the 24th, 3 days from now is the 27th, and I print that out to screen. Let's go ahead and comment that out too. And like I showed you a moment ago, we can do lots of really interesting things here. My value dot add hours. So 3 hours from now toShort time string. And that'll say 3 hours from now would be 1:42 p.m. That's accurate. What if I wanted to subtract days? Is there a subtract method? No, there's not. But what you would simply do is just use a negative number. So in this case, I'm just going to subtract 3 days. So 3 days ago, toShort date string. 3 days ago would be the 21st of March. Okay? So we can just use a negative number inside there. Now, earlier I said that while we can create a date in the past, or I'm sorry, a current date, we can also generate a date for the past or the future by initializing its value like so. There's a couple of different ways to go about this. So let's take my birth date, for example, as new date. And notice that inside of the new date, there is an overloaded, what's called overloaded constructor. And I'll explain when we talk about classes and creating new instances of classes really soon here in the next couple of lessons. This will make more sense to you, but essentially we can call a method at the time when we create a new instance of a given class, and we can pass parameters in to initialize the state of that new object. Again, this will make more sense later, but just know that I can go ahead and provide, for example, some information as I'm creating a date. In this case, I can provide the year, the month, and the day to initialize an instance of date. So 1969 will be the year, the month will be 12 for December, and the day will be 7. All right, so this now I've created a new birth date, and let's just go ahead and console.writeLine this my birth date and see it represented here in our window. 12/7/69. Again, the United States version of this would be December 7, 1969 at midnight. Why midnight? Because we didn't specify a time. But we could do that as well by saying, I think I was born, let's see, do we even have a version of this that would allow me to pass in an hour? Yeah, I think I was born at like 7 in the morning. So let's go like 7:30 in the morning, even down to the second. Let's go 1. All right, so now we've given more information as we've initialized our new date to the past, December 7, 1969 at like 7:30 in the morning. Okay. Now, what can we do with this? Well, we can do anything that we did previously with it. We can actually use it to find out the span of time, how many days I've been alive, so on. We'll come back to that in a moment. But this is one way that we can create a new date in the past or the future by initializing it in the constructor. We can also do something like this, where we create my birth date as new date, but we don't have to initialize it right away. We can instead set my birth date equal to, and I can use a string pass in a string of the date representation using this parse method. So almost every data type, including integer and so on, they all have this parse, and they also have something called try parse, which we'll talk about later. And parse will take some string and say, I'll try to make this into a date if I possibly can. So I'm going to give it some random string. In this case, I'm going to try to make sure that it lines up with an actual date. And hopefully the parse method is smart enough to take that string and convert it into a date and assign it then to the my birthday variable, in which case you do get it to work again here. So that's another way that we can create a new instance of a date in the past or in the future. And then the final way is to use some to create a literal date. Now, in the past, we created literal strings, right? By using double quotes around a string. So I could create a string called 1969, or December 7, 1969. But notice that this isn't going to work. Let me see if it works. It works only because Visual Basic does it is very forgiving, like I said before. It will do conversions for you if it thinks it can. Okay, it's very clever in that way. We shouldn't rely on Visual Basic's functionality to do this. Instead, what I'd like to do is use the actual literal characters for a date, and instead of using double quotes, you would use pound symbols around a date, and that would make it into a real date. So we would get that. All right, but yes, we don't even have to use date dot parse with the string. We could just give it a string, and Visual Basic's smart enough to figure it out. But do not rely on that. It's called evil type coercion. Evil because it can get you into some problems. You should always be very deliberate about how you work with types in Visual Basic. Even though it forgives you, it can lead to problems if you're not very deliberate. Okay, so always use the correct verbiage and don't rely on Visual Basic shortcuts would be my recommendation. All right, so let's get back to what we were working with originally here and create, again, dim right? And now what if I wanted to work with the span of time? And so we're not working with hours, minutes, seconds. We're working with, at least in form of a date, we're working with it in terms of how long something took or how long something will take. So if I have my birth date, then I can also calculate my age as time span. So here's a new data type that represents a span of time, not a date, but the time between two dates. So in order to figure that out, my age, I'll take date.now, and since now returns a date, we already know that what the now function does, we'll go date.now.subtract, and then I'll pass in my birth date. And that should give me a span of time for how long I've been alive. Now what I can do is go my age dot and see how many seconds I've been alive, how many minutes I've been alive, how many hours, how many seconds, and so on. So let's look for the total number of days that I've been alive. And it'll come back with a very large number, 16,970.45 days. So whenever I run this, the number always gets larger every time I record the series, and I always feel a little bit older. So at any rate, that's how we would figure out then to use a span of time. And we can do that by giving it two dates. In this case, I'm taking the current date and subtracting off another date to figure out that length of time. Okay. And at that point, then I can take my age and say, 10 days from now. So let's add a span of time. So new time span, and we'll say, hey, let's give it the number of hours, minutes, and seconds, or the number of days, and so on. So let's give it in 100 days. Whoops. 100 days, 0 hours, 0 minutes, and 0 seconds. How old will I be? I'll be, here, let's set my age equal to myAge.add and then run it. 17,070 days old. Okay, so we just added on 100 days. Okay, so that's how you manipulate dates and spans of time, as well as manipulating times, printing out various portions of dates and times, and hopefully that'll give you all the tools. Again, my advice regarding dates and times and spans are the same as my advice with strings, which is if you're doing a lot of work to try to figure out how to manipulate a date time or a time span, you're probably doing it wrong. There are so many built-in functions, and we haven't even looked at them all, that are available from the .NET Framework class library or that are baked right into the date data type or the time span data type. Just do a little research online and search for the exact problem you're trying to solve, and chances are there are existing functions that will take care of the majority of it so that you're not writing so much custom code. All right, so you're doing great. We've made it so far through, and I would really say that at this point we've hit the halfway mark, because up to this point we haven't done anything all that complex. Things are going to start getting interesting now as we move on and talk about classes, and this is always sort of a big hurdle for people conceptually. The syntax of classes is easy. It's just the conceptual nature of it. So don't get discouraged. Everybody has this little hurdle, and I'll try to do my best to explain it in a way that's understandable. Just take it in stride and understand it in the context of how the .NET Framework class library was built. And if you understand it in those terms first, then everything else will work and make sense for you. And that's all you really need to know at this point in your journey towards Visual Basic Mastery. Okay, so at any rate, this kind of concludes the first half of the course. What comes next is a little bit tougher. Don't worry. If you got this far, you definitely can do it. You have the power to stick to it, and I'll do my best to help out. We'll see you in the next lesson. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. Now, near the beginning of this series of courses, I said that modules and classes were containers for the methods that you create. But I did say at that time that classes had a special purpose, and I think you'll start to see that special purpose emerge as we continue through this series of courses. Now, the .NET Framework class library is a library of code created by Microsoft that we can use in our applications, right? And I explained that the methods that we can use in our application, like writeLine, readLine, and the others, they're all packaged inside of classes. So to get to a specific method, we would use the class name, then we would use the member access operator, the period operator, and then the name of the method that we wanted to invoke. And I explained that the console class contained methods that were all related to working with the Windows console. And we saw the random class, and the random class has methods as well. We only used one of them, but it has a method called next, which allows us to generate the next random number that the class can generate. So the methods are organized into the classes based on their relationship or their need, or kind of organized that way so that you can easily find what you're looking for. Now, truth be told, I totally oversimplified the explanation about classes because I really wanted you to gain some confidence in yourself and your ability to write Visual Basic code before we introduce classes. It's a little higher conceptual. There's nothing hard about classes per se. It's just that classes introduce the idea of object-oriented programming, and sometimes new developers find object-oriented programming ideas a little bit challenging, at least at first. Now, not to scare you away, but it took me a little time to kind of wrap my brain around object-oriented programming. Took me probably longer than most people, just because I was always looking for something harder, making it more difficult than it really was. The fact of the matter is that in one sense, it's very simple, and then in another sense, you spend the rest of your life trying to master it. Okay, so not to scare you off, but it'll be pretty simple, I think, once we get some basic explanations under our belt. The code that you write in methods are ultimately defining the classes of your application. So every method that you utilize from the .NET Framework class library is just a class, and that's why it's part of the class library. That's why they named it the class library. Classes are all around you. You've been using them up to this point pretty much for every little application that we've written. And so you're really an old pro at it. I'm merely going to fill in some of the details to what you already know in this lesson and the next few lessons and kind of round out your knowledge. And then maybe someday, whenever you sit down to build a real application, a new application, you'll start to see the value of classes, and maybe you'll even start to think like an experienced software developer who might organize their methods into the various classes to help in a number of different ways, to help organize their thinking, to make their code more maintainable and so on. But at this early point in your software development experience, I just want you to be able to utilize the .NET Framework class library efficiently. So I want you to be understand the nature of classes and how to create an instance of a class, create an object, how to utilize properties and methods of a class, and so on. So the truth of the matter is that I couldn't possibly cover everything there is to cover about object-oriented programming and specifically about classes in this course. There's just not enough time because it's a vast topic. I have an entire course devoted to it on devview.com, and then you can go on from there and read books and books and books about object-oriented programming. I just wanted to present enough information to you to help you get comfortable with the basics of how to use the existing .NET Framework class library from Microsoft. Use those library classes in your applications. And so in order to illustrate how Microsoft put together the .NET Framework class library, we're going to build our own custom classes and to show you how they built the class library. All right, so what I want to do is start talking about the need for classes and talk about working with related properties. So suppose that I want to create an application that keeps track of data about cars, because I own maybe a company that deals with a car lot. I'm selling cars on my car lot, and I want to keep track of all the cars on my car lot. All right, so I want to keep an inventory of all the cars that are currently in my possession as the owner of the car lot. So what I could do probably to begin with here is to create a series of variables about a given car, and I just maybe want to keep track of 3 properties of each car. So I have one car on my car lot. I'm going to say car number 1, and I want to store its make as a string, and I want to store its model as a string, and then I also want to store, whoops, this should be car 1, and then car 1 year as integer. And so then maybe I come along and I need to add a second car. I've got 2 cars in my car lot now. I might need to go car 2 make as string, dim car 2 model as string, and then dim car 2 year as integer. And then what if I get a third car? Well, here we got to do that all over again. Car 3 make as string, dim car 3 model as string, dim car 3 year as integer. All right, and then I decide, well, you know what I really need to do is not only keep track of the make, model, and year, but I need to also keep track of the color for each of the cars. So, I gotta do car 1 color as string. All right, and then gotta go down here, add car 2. You can see that this isn't a very efficient way to keep up with all the cars on my car lot. Okay. First of all, I'm kind of relying on just a naming convention, just like I did with arrays. Remember when we talked about that? Relying on a naming convention to keep everything kind of bundled together, and there's no way to enforce that. There's no way to enforce that. What I'm saving in car 3 color isn't related to car 1. Why? Because these are just loosely related together, and the only way that they're related is in my own mind, and the only reason they're related in my mind is because of what I've named them. So this isn't a very good technique for keeping related attributes of a single entity, a single object, a car in this case, into one logical container. When I think about it, arrays really aren't the right way to go about this either, because you can only store a single data type inside of an array. And furthermore, how would I keep track of, if we were to say car1 and, say it had 4 attributes, how would I be able to say that attribute number 2 was always the model, regardless of car1, car2, car3? So that arrays aren't really the right solution for this either. What we would probably want to do instead is actually to create a new class of information, a classification, a type. And that type would be a car or an automobile. And a car would have different properties. And then whenever we went to represent a new car on our car lot, we could just say car1 is actually type of car. And since it's a type of car, we know that it has a make, model, year, color, and so on. So here's what we want to do. We want to create a new class. And inside that class, we're going to define the properties, the attributes of a car that are meaningful in our application. Now, there's a lot of attributes about a car. We could say sticker price. We could say the number of miles that it has on it. But those things may not be relevant to the application we're building. So we really just want to model those properties that are interesting to us inside of our application. So what I want to do is add a new file to my project. We haven't done this yet. And there's a couple of different ways to go about this. The easiest way, in my opinion, is just to go to the project menu and select add. And one of the options is to add a class, and it will pop open a new dialog called the add new item dialog. It'll already pre-select class. We can add a lot of different types of things, but class is what we want. Let's name it car.vb and click the add button. Okay, so now we have, you can see here, a public class car. I'm not going to talk about the word public just yet. That'll come in handy here when we talk about accessibility modifiers a little bit later. But for right now, all I'm really interested in doing is defining what a car is inside of my application. And again, car lot, I just want to keep track of the make, the model, the year, and the color. So what I'm going to do is create 4 properties of a car that are general, and they're applicable to every car that's ever been created on the face of the earth, okay? So it's a generalization of the idea of a car. So in this case, public, and we'll give it the name property, make as a string, public property, model as string, public property, year as integer, and let me fix that E in year, and then finally public property color as integer, as a string. Great. Let me change the R. I know that it's not case sensitive, but I like making my code read correctly. Great. So now I've got a car class, and it allows me then to create new instances of cars. Each car will be defined or differentiated as a make, a model, a year, and color. Now I can create a new bucket in the computer's memory sufficiently large enough to hold a new car object. It's just like an integer. It's just like a string. It's just like a date. It's just like the console class. It's just like the random class. It's just like every other class or data type that we've worked with, except we created this. It's a custom data type. It's a custom class, and we get to define how that class actually works by creating its properties and its methods. Okay. So now let's suppose that my aim is to use that car definition, that car class definition, to create instances of the car class that represent individual cars on my car lot. So I want to create a bucket in the computer's memory, an instance of the car class that will hold each of the cars. So I might have 2 or 3 different cars in my car lot. I want a variable of type car that will hold all the information about one specific car on my car lot. All right. So let's go ahead and talk then about creating a new instance of a class versus the class definition itself. The class is the blueprint. All right. But what we want is an instance, or we want that blueprint to turn into an actual representation of a specific car. So what we need to do is take this car class and say, I need a new bucket based on this car class definition, and then I'll fill in the details about it. So I need to take the pattern, take the blueprint, and then instantiate it, create an instance of it, realize that from the theory of what a car is to an actual instance of a real car, like my car sitting in my driveway right now. Okay. So, in the real world, you can use the same blueprint to create many different houses, right? The blueprint's just on a sheet of paper, but the house actually is at a physical address. And, in some neighborhoods, they call them cookie cutter houses because they all look the same, right? Well, you could use the same pattern to create the same shirt or pair of jeans over and over again, or the same recipe to create the same cake or the same casserole and get the same results each time. That's the purpose of the pattern. That's the purpose of the blueprint. So each time you want to build a new house, it'll be at a different address, all right, a different street address. Each time you follow the pattern, you'll create a different shirt. You might use different fabric. It might be a slightly different size, but the pattern will give you the overall shape of that given shirt. Or every time that you create a new shirt, you can sell it to a different customer. There's an instance of it that you create from the pattern. Each time you follow a recipe, you're going to create a different meal available and that can be eaten by a different person, okay? So the same is true with classes. Each time you create a new instance of a class, you have a new object that's distinct and separate from the other instances of that class, all right? It lives on its own, in other words, is what I'm trying to say. So think of the class as a cookie cutter. You can't eat the cookie cutter, right? You can eat the cookies that you make from the cookie cutter. So when you instantiate a class, you create a cookie or an instance based on the shape of the cookie cutter or the class, okay? So I'm going into a lot of conceptual explanations of the difference between a class and using the class, or the cookie cutter and using the cookie cutter, or the pattern and using the pattern, the difference between the blueprint and actually using the blueprint to create a new house or whatever, okay? So hopefully I'm making that distinction extremely clear. Once you can get that clear in your mind, things will come so much easier, all right? And so what we want to do is create a new instance of a car. Let's go ahead over to our module VB in our sub main and create a new car. So dim my car as car, all right? Now at this point, all I've done is created a label that I can attach and say this is of type car. Now, in order to actually create the bucket in the computer's memory, I have to use a different keyword. My car equals new car. At this point, the new keyword's like a factory. It takes the blueprint and it creates an instance of the object, in this case a car, and it essentially creates that bucket in the computer's memory. And at that point then, we've created the item in memory and we've got the name or the label for that bucket, my car. And so now we're ready to work with my car. And we can do something like this. My car dot make equals Toyota. My car dot model equals 4Runner. My car dot year equals, I think it's 2010, and then my car dot color equals white. Okay, so now that I have a bucket in the computer's memory labeled my car, I can set the properties or the attributes of my car and describe my car using the various properties that have been predefined for a variable of type car. So here we've got a class, but the class is called car. An instance of my car, or of the car, is called an object. So here's the class and here's the object. Here we create a new instance of the car class in the computer's memory. We instantiate it, we bring it to life based on the fact that we know its definition, the cookie cutter here, the blueprint. And now that it's in memory and we have a connection to it by its label, my car, we can start working with it. All right, and we can create a second car. Dim my other car as car. In fact, we can do this all kind of in one shot equals new car, like so. So we've done these 2 lines of code, except in 1 line of code. Actually, there's an easier way to do it with still less code. My other car as new car. All right. Actually, let me do that. Okay. So that's probably the shortened form that you'll find me using most often because I can do it all in the fewest number of characters possible. And so then my other car can be a make equals, let's go Honda. My other car is the model. Let's call it a Accord. My other car dot year is 2012. My other car dot color equals black. Okay. Now that I have 2 cars, I can console.writeLine, and I can print out the specific attributes of each car. So let's just do two things here. And let's take my car dot make and then my car dot year and print them out. Like so. And I can do the same thing here with my other car. I just copied and pasted that line, and I'm going to change what we're printing out. And here you can see I have a Toyota 2010, Honda 2012. All right, and I think the most important thing to realize about this is that I can set properties using the assignment operator, but I also can get the properties just like I can any other variable by merely referencing it using the name of the object. In this case, my car, it's the instantiated version of the class, so it's an object. So that's the difference, a class versus an object. Class is the blueprint, the object is the instantiated version of it that has, it's different from every other instance because it's a different bucket in the computer's memory, okay? So hopefully I've belabored that enough so that you understand it. So you can see that we create many instances of a single class by giving each instance of the class a different identifier, a different name, all right? And so it's distinct from every other item based on the same class in the computer's memory. Now, I've merely hard-coded the values here in this example. Typically what you would do is retrieve those values maybe from an end user, letting them type in the values. We might pull it from a database or from a file and instantiate an object and then copy the attributes from the file into the object and then work with it and then save it back. So again, here we're taking baby steps, but that's how we would get information in. We probably wouldn't always just hard code them the way that we've done here. It would make for a very inflexible application. What we really want to do is either retrieve data from an end user or retrieve data from some file source or from some online source. Okay. Now I want you to notice also that IntelliSense was smart enough to show me all of the attributes that we've created, right? As well as a few extras like equals, get hash code, and get type. That's because every object or every class is actually based on a kind of a grandfather. It inherits from system.object in the .NET Framework class library. So even though we're creating a custom class, it's really borrowing from the definition of what a class really is that's defined in the .NET Framework class library. So we get some functionality for free, like the toString method, the getType, the getHash. That's where all these other things come from, but they don't really have any functionality just yet by default. We could override their default implementations and do something interesting with them, but we won't do that in this video. Okay, so I just wanted to point that out. Now, the next question is, how long does this instance of the car or the other car stay around? Well, as long as we're using my car or my other car in our application, then it will continue to stay alive. But when we stop using it, it will die. And we'll talk about the scope of variables, but specifically about objects, as well as object lifetime in an upcoming lesson, because it's a very important concept. But essentially, when we get to the end of our sub, what will happen is those two cars will be removed from the computer's memory, thrown in the trash, and that memory is now freed up for other applications that we have on our computer. Okay. So also what I wanted to point out here is that we used a shortened version of defining a property. There's actually a longer version that allows us to add more functionality inside of our properties. So this version is called an auto-implemented property. We're able to create a long version of the property just by typing in the word property or prop, have it highlighted in the IntelliSense and then hitting tab. And here you can see a fully implemented property. And I don't want to really get into all of it, but you can see that it does have these two little sections here, the get and the set. So that's the two operations that you can perform on a property. You can get or retrieve its current value, or you can set its current value by passing it a new value using the equal sign, the assignment operator. This full-blown version of a property allows me to step in and write custom code, custom logic, so that when anybody tries to access and retrieve the value of an attribute or change the value of an attribute, we can stop it and say, wait a second, before we give away the value that's inside of our new property, let's make sure that they have the appropriate level of access, because I may not want to give away some super secret information if the person who's currently logged into my application is not of a certain level inside of our organization. So this is where we could do some gating and stop people from accessing information at this property level. We could also then do some validation and say, you know, a car can't be, 2030. That year hasn't even come yet. So we could validate the set and only allow certain values to be set. So if we tried to set, for example, the year to 2030, we could throw an error and say, no, you can't do that. So that's the purpose of a full-blown property definition, but we're not going to use that, not at least in this video. I just wanted you to be aware of the fact that this is a shorthand version of creating a property. This version of the property allows us to get it or set it, and set it to any value that you could typically set into a string, even if it doesn't make logical sense inside of our application. Okay. Now, since we defined a data type, just like string or integer, we can use those as input parameters to functions. So what if I were to create a little helper method here and to determine the value of each of our cars? What we could do is create a new function. So I'm going to call this determine market value, and then I'm going to pass it in by val my car as car, and I'm going to return back a money value. And whenever you're dealing with monies, you want to deal with decimals, the decimal data type. Okay. So when you're dealing with money, you want to work with the decimal data type. It's like integer, except it allows you to have values after the decimal place. And so in this case, what I could do is do some super secret formula here to figure out what the value of any given car is. I could even go and search online to find the value of the car, but we're not going to do that. Instead, I'm just going to hard code and return, I'm going to return the value of 100 for the car. So we're going to pass in my car. We're going to do some evaluation on it. We could like retrieve its properties here, mycar.make. So maybe we'll do that in a future example. But we could evaluate it, pass it to something online, get the value, and then return it back. So here, if I were to, let's comment this out. And let's just do this. My car, let's go determine market value, and we'll pass in my car. All right. Then we'll see what the current value of my car is. All right. You can see that it's 100. Let's go ahead and format it like currency, right? So use the :C formatter. Now we can see the value of my car is actually $100. All right. So the point here is that we can use now this data type car that we define just like any other data type, integer, string, date, whatever, and we can use it as input or as return values from functions that we create. But there's maybe an even better way to do this. Let's talk about creating methods inside of our class definition. So I said before that a class is really just a container for your methods, but I haven't shown you any methods. I only been talking about the properties, but we can also create methods inside of our classes. So let's do that. Instead of putting that determine market value here as a function that we pass the car into, we should be able to just create it here inside the class. It will have access to all the data that it needs in order to make the determination, so we shouldn't have to pass in anything. We'll just say, let's go just public function market value as decimal. Okay, so we're not passing any values because we're going to be able to access the attributes of this car. So let's go ahead and we could do something like, the super secret formula right here. We could actually look online for the value and then return it. But what I'm going to do is something a little bit different. We'll just write some really crazy logic here to determine the car's value. So I'm going to create a car value as decimal. This is ultimately what I'm trying to determine. I'm just going to create a variable that'll hold it. And now what I want to do is find out the current year of the car. Now I could just type year like that and it would work. But what I would really prefer to do is to say not just year, because year, where did this come from? Is this just some, it might be difficult to remember the properties of a car. If I were to look at this in the future and say, I don't know, I'm looking at this function, it's not clear to me where this year word came from. So what I can say is for this instance of car, this current instance, give me the year attribute. Now I prefer doing that. Clearly, Visual Studio would say, well, you could probably simplify this, and it gives me the little light bulb under it, and it said just remove the me qualification. All right, so we'll just go ahead and leave it off. But remember, if you want to reference this specific instance of the class and retrieve its attributes, its year, its make, its model, then you can use the me dot. All right, but we'll get rid of it. So at any rate, if the year is greater than 1990, then the car value, we'll just hard code it to $10,000. Otherwise, if it's older than 1990, then we'll make the car value just $2,000, and then we'll return the car's value, like so. Okay. And now let's go ahead and rework this line of code. And we'll just go console.writeLine. In fact, let me just borrow almost everything inside of here, except we'll change how we make a call. And in this case, we're just going to go mycar.determine mycar.market value. Okay, I thought it was called something else. And so now I'm going to be executing a method, so I have to use the method invocation operator on it. It's not a property. Properties, I don't have to use the method invocation operator. Even if I try to, I'll probably get an error. All right, it lets me do it, but again, that's only because Visual Basic is very forgiving, and I can probably leave it off here too and it will still work. But again, I want you to be purposeful and think about the usage of a property versus a function, or rather a method. Let's run the application, and you can see now that our Toyota is worth $10,000. All right, so what do you make of all of this? Well, in this lesson, we used a very concrete example, the example of a car. And a car is easy for all of us to conceptualize. It's tangible. There's a real-world equivalent. We can think of what a car really represents in the real world. We can model it fairly easily because we know the attributes of a car, just like we know the attributes of, a pad of paper or whatever the case might be. Now, you're going to be building applications, especially in this series of lessons. And typically, you're not going to be responsible for creating your own custom classes. I think your main exposure to classes will be what we've experienced so far, which is those classes, again, which were created by Microsoft and available in the .NET Framework class library. In most of those cases, the classes that have been defined in the .NET Framework class library do not have real-world equivalents, like something tangible, like a pad of paper or like a car that we can sit inside of or touch. In other words, the classes inside of the .NET Framework class library are more conceptual in nature. For example, I might work with a class that represents a connection to the internet. Or I might work with a class that represents a stream of data as it's being streamed into me from some other source, flowing from one place to the other like a pipeline. And we already saw that there were objects like a span of time. It's difficult to put your hands on time, right? But there are objects in the .NET Framework class library that represent a span of time between two dates, okay? So very conceptual in nature. In these cases, we're not working with something tangible that we can touch and we can feel, but we're working with something, again, a construct of our own minds, or something that is that we can't touch inside of the computer. Now, as you mature as a software developer, you might want to invest more time in learning how to create your own library of classes that interact with each other in some meaningful way as a means of breaking down real-world problems into conceptual problems and turning them into code by abstracting their features, their most identifiable features that are important for your application, into a series of classes, okay? And that process that you go through to turn something in the real world into something conceptual is called object-oriented analysis and design. And that's not something that we're going to cover in this series of lessons. You can spend years learning how to do it properly, but I do have some courses on devu.com that will help you learn that if that's something you're interested in. I spent a lot of time actually thinking and talking about object-oriented programming there. So, all right, to recap, a class is a data type, just like any of the data types that we've learned about up to now. It's similar to those basic data types like integer and string, and it's also similar to those complex data types like console and random that we've used up to this point in time. And you can define a custom class with properties, as we saw here, and methods, like we saw here, and we can actually then utilize them by creating new instances of a given class and then using the member access operator to either set or get the properties or to call the methods that have been defined on our classes. And inside of those methods, we can access the various attributes of this instance of this given class, and then make and create business logic around it to, in this case, for example, determine the value of the car. All right, so don't worry. I've got a lot more to say about classes. If you don't understand everything there is to know about classes just yet, why you need them, that's okay. Don't fret about it. Just make sure that you understand the process that we went through to create a new class, how we created properties of the class, by using this syntax, public property, then the name of the property, and then as whatever data type that we want to make that property. Understand the purpose of when we typed in prop tab and we were able to create the full version of a property, and we see here the get versus the set for that property. How we created a method. We could have used a sub. We used a function because we wanted to return a value, but again, how we created a method inside of a class, and then we were able to access that either property or method by using, again, the member access operator for a given instance of our class. And if you understand just that much, then you're doing all the right things up to this point. We'll fill in more details in the coming lessons. So if this didn't make sense, there's nothing wrong with watching this video a second or third time, or even watching other videos that might help you better understand classes. But do this, stick with this. Don't drop it right here, even though we're at a conceptual hurdle for you. A lot of people have a challenge with this, and don't make it harder than it really is, at least not at this point. Okay, so you're doing great. Let's continue on to the next lesson. We'll see you there. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, we're going to continue on with classes and object-oriented programming. We're going to talk about the lifetime of object references and how .NET manages the memory that your objects use. Secondly, we're going to talk about constructors, which are special little methods that run at the moment you create a new instance of a class. And we'll talk about why you even want to use constructors. And then finally, we're going to talk about shared methods and properties. Shared is a keyword. In other programming languages, it uses the term static, meaning that you can use that particular method or property without creating a new instance of an object first. So that would explain the console window, and it's different from how it's different from the random object that we used in previous lessons. So let's go ahead and get started. And this is one of those cases where you probably want to use the code that I'll supply. You can find it wherever you're currently watching this video, or wherever you originally downloaded it from. There is a folder called Before, and you should be able to find in the Before folder an object lifetime project, and you want to copy that somewhere on your hard drive. I'm going to put it where I put all my projects, here in the project subfolder of Visual Studio in my documents directory. Okay, so now let's double click the solution file to open up Visual Studio, and you'll see that I've already created, pretty much just copied the code that we worked with previously here to create a car class with the make, model, year, and color. And then you'll notice also in the module VB in the sub main, we're creating a new instance of the car, setting its attributes, and well, there's a little bit of something that we'll come to a little bit later. Let me go ahead and delete that for now. All right, so at any rate, what I want to do is actually focus on this line of code, line number 5. What's actually going on here? Well, the .NET Framework runtime, when it encounters this line of code, will have to go and create a spot in the computer's memory large enough to hold a new instance of the car class. So that's that bucket analogy we've been using. It's going to create a new bucket in the computer's memory large enough to hold a new instance of this custom class that we created, right? So the computer's memory has addresses in it, similar to the address where you currently live in your home or apartment. So admittedly, the addresses in a computer's memory looks a lot different than the address you might live at, 123 East Main Street, some city, some country, and then some postal code, right? It actually uses hexadecimal values as addresses, but they're addresses, they're known addresses nonetheless, and that's how the .NET Framework runtime knows where it put your buckets. It keeps track of the addresses, and it keeps track of the address and the little friendly label that you give it whenever you create a new instance of a given object. In this case, my car is at this address. It uses that address, looks up into that address in the computer's memory, finds the bucket, grabs the values out, and lets you work with them. Okay, so the .NET Framework's first job is to find an empty address where nothing else is being stored right now whenever you create a new instance of an object. And so that address has to be large enough in size to store a instance of our given class. So it creates the object and then it grabs the address of that object and copies that address down. And so it always knows where to find that object in memory that we've labeled my car in this particular situation, so that you can always get back to that object in memory. And so you can store that reference in your variable, but really all you're doing is storing an address in that variable. And behind the scenes, the .NET Framework runtime knows what it means. It goes and finds the actual bucket at that location. Okay, so my car in this case is simply holding an address, or what we would call a reference, an object reference, a reference to the instance of the car class in the computer's memory. So whenever you need to work with that instance of the car class, you just use the my car identifier. We can set and get attributes, we can call functions, and the .NET Framework takes care of the rest for us. Awesome. So it gives you this illusion that you're actually working with the object itself, but in reality, you're just holding onto a reference to an address in the computer's memory, and then the .NET Framework runtime takes care of all the rest and makes it hidden from you. So an analogy that helps me understand references to objects is kind of, maybe to extend the analogy of a bucket, a handle on the bucket. We've used the bucket analogy several times up to now. So whenever you store an object in memory, .NET gives you, the developer, basically a handle that allows you to get back to that bucket, so you can hold on to that bucket. All right. So what happens if you let go of the handle? Well, you'll no longer be able to get to that bucket. The bucket will no longer be accessible. Why will it no longer be accessible? Well, one of the missions of the .NET Framework runtime is to keep the memory region clear and get rid of stuff it no longer needs. And so the .NET Framework runtime goes through and cleans up memory every once in a while, and it does that by counting references, or counting how many handles you're actually holding on to. So if we're no longer holding on to a reference or handle to that particular object in the computer's memory, to the car class, then it's going to remove that instance of the car class from the computer's memory because it thinks we don't need it anymore. So it frees up that space in memory so that other programs can actually use that for their own needs. So this process of cleanup is called garbage collection, and there's a lot you can learn about garbage collection and how it works behind the scenes. Not all that important for the moment, but what I want to do is actually run a quick experiment. And I want to actually use that line of code that I accidentally left in a moment ago. So my other car as car equals my car. All right, so here we go. At this point now, we did not create a new car in the computer's memory. All we did was say, I want to create another handle, and I want to attach that handle to the same handle that my car is pointed to. So we essentially just copied the reference from my car to my other car. Now we have two handles attached to the bucket in the computer's memory at this point. Okay. And to prove this, here, let me just show you how I can prove this. So console.writeLine, and we'll go my other car dot make. That should be sufficient to prove this to you. Then what I'm going to do is go my other car. I'm going to set the color from whatever it is to black. And then what we'll do is console.writeLine. We'll go my car dot color, just to see what color it is. Is it still white or is it something else? So this should prove that we're now dealing with two handles to the same object in the computer's memory. So let's also write a console.readLine real quick here, and let's run the application. And you can see the first thing we get printed out is Toyota. So that was what we got from my other car, even though we never set explicitly the make attribute of my other car. Because it's referencing my car, it's able to grab out Toyota. And then next, we're looking at my car. We set its color to white, but since my other car is pointed at the same object in memory, we can set it to black, thus affecting the color of my car and setting its color to black as well. All right. So now you have two references to the same object in the computer's memory. And I think the important thing here is that you can create a variable that can hold a reference, but you don't have to create a new reference necessarily. You can just copy the reference from another object. All right. So another analogy that kind of helps me is, because you don't think about multiple handles on a bucket, maybe you could think of it like strings on a balloon. After you cut the last string on a balloon, what happens? If it's filled with helium, it's going to float off into outer space and you never hear from it or see it again. All right. So the same is true whenever you're working with references here in your application. When the references go out of scope, in other words, whenever the current thread of execution of our application exits through the end sub, and it leaves the code block where the variable and the object of the object, the variable holding the reference to the objects in memory are actually defined, then we actually lose those references. We're essentially cutting the strings off because we're exiting out of the application, or at least out of the scope of this method, and those variables are no longer accessible. The .NET Framework comes through and says, oh, hey, car class, it looks like nobody's looking at you anymore. Time for you to go away. And so it takes it and removes it out of memory. All right, so that is known as reference counting, to see how many references are still attached to a given object. The .NET Framework will count the references. If the references go to 0, the count goes to 0, then it will remove that object from memory. So at some indeterminate time in the future, after we exit out of the execution of our application, then the .NET runtime with garbage collection feature will come around and will count references. It'll remove the objects in memory, freeing them up for other applications. Now, what if we wanted to explicitly remove our references? In other words, what if we explicitly wanted to cut the strings to the balloon before we go out of scope because we hope to use that particular variable again, or we're working with a lot of objects and we want to free up the memory? We can actually do something like this. So here I'm going to set my other car equal to nothing. All right, so when we set this equal to nothing, we're saying, hey, instead of pointing at something, point at nothing. So now if we were to try to reference and go console dot writeline and go my other car dot, and we attempt to get the color out, let's see what happens when we run the application. We're going to get an exception that there's a null reference exception. There's a reference, but it's null. In other words, we don't know what it's pointing to. It's pointing at nothing. So we can't access an object that is pointing to nothing in memory. All right, let's go ahead and stop that. Now, if we were to set both of these to nothing, so my car equals nothing, we would actually probably kill off this line of code as well. And then at some future point in time, some indeterminate point in time, the object would actually be removed, but it doesn't really matter from a practical purpose because we don't have any access to that object in memory anymore. So in some situations, this indeterminate amount of time, because the garbage collector will run whenever it feels like running, there are some rules and memory pressure that force it into action, and otherwise it will just be dormant. But if we need to be specific about removing objects, and we want to be explicit about removing objects from memory because we have a very memory intensive application, we can do something called a deterministic finalization approach that allows us to say, hey, stop everything you're doing .NET Framework runtime and remove it now. And we might want to do that in situations where we're holding on to some connection, maybe to a network resource, to a database, to a file, and we want to sever that and make sure that at the moment that we say we want it to be severed, we want it to be actually severed so that it frees up that resource so something else can actually use it. So that might be a scenario where we would want to be very specific about it removing that object from the computer's memory, but otherwise we can just let the .NET framework do it on its own and not really worry about it. That's a little bit more of an advanced concept. We're not going to cover that in depth in this series of courses. However, if you were to search for the words deterministic finalization online, you'll find some articles about it out on MSDN, maybe even some videos. All right, so the next thing that I want to do is focus on the little subtle usage of the opening and closing parentheses, because hopefully there's something about that should jump out at you. And that little something is the fact that we're actually using the method invocation operator here whenever we create a new instance of a class. So whether you realize it or not, whenever we create a new instance of a class, like the car class, we're actually calling a method called a constructor. And it allows you, the developer, the option to write some code at the moment that a new instance of our class is instantiated, that moment when that new instance of the class has been created in memory. We can write code at that point to do things like, for example, put the object itself into a valid state, just like we would any other initialization that we've used for other variables or even the array, as we learned earlier. So this means that we can use our the special constructor method to construct or initialize the values of properties so that our objects are ready to be used on the very next line of code. You may not always be able to do it that way, but it's definitely an option to use. So I want to create a quick example here of why you might create a constructor. And that'll allow us to set the properties of the car at the moment whenever we create a new instance of the car. So to create a constructor, you use the public sub and then the new, and the new keyword represents a constructor. So here I'm going to do something like maybe I would load this from a configuration file to populate the make, the model, the year, and the color. I might actually load it from a database, or maybe grab it from online somehow. But in this case, what I'm going to do is to actually hard code the make property so that by default all new instances of the car class will automatically be or have its make property populated with a real value. All right, so here what we'll do is just say make equals, and then we'll say Nissan. Okay, so now whenever we create a new car, what we can do right away is console.writeLine and then look at mycar.model, or was it make? I think it was make, sorry. And you can see that initially, by default, the car is in a valid state, setting its property to Nissan. Of course, then we cover that up by setting it equal to Toyota and print it out a little bit later, but at least you get the idea of how you can use it. Now, admittedly, this doesn't make a whole lot of sense right here. I'm just showing you the technique that you would use, not really the rationale. But let me show you an overloaded version of a constructor. So like you created an overloaded method in one of the previous lessons when we talked about methods, and you did that by creating different method signatures, you can do the same thing with constructors as well. The method signature, you'll recall, is the number and the data type of the input parameters. So we can create a second public sub new, and as long as we change the method signature, so at least in this case add one input parameter, then we'll have a different version of our input parameter. Will be two different ways that an object can be created. So let's do this by val, and then I'm going to do I'll use a underscore. Now I'll just call this the make value a string, by val model value a string, by val a year value as integer, and then by val color value as string. Okay, and then here what we would do is just do a mapping from make equal to make value model equal model value, year equals year value, and then color equals color value. All right. So now, whenever we create a new instance of car, and let's just do that here, for example. In fact, let me just comment out everything here so far. And we'll essentially do all of that in one line of code. So dim my car as new car. But notice now I have two versions of my constructor. The first version will accept no input parameters, but the second will accept 4 input parameters: the make, the model, the year, and the color. All right, so here we go. Let's go Toyota, 4Runner, 2010, and white. All right, so we're able to now run our application. In fact, yeah, let's go ahead and run it. And you can see that we still get Toyota printed out. Why is that? Well, because we were able to use an overloaded constructor to pass in all of the values we wanted to populate at the time of instantiation, instead of doing it in subsequent lines of code. All right. Just to kind of reinforce the overloaded nature of it, we can't create another overloaded version without any input parameters. Why? Because there will be multiple definitions with identical signatures. All right, but I do want to say this. If we were to remove this version that accepts no input parameters, what happens then when we go back to this line of code? Well, whether you realize it or not, there is a default constructor. Now in this case, because we have at least one constructor defined here, let me comment that out, we get a complaint. But once I get rid of that, notice that we're able to call the default constructor, and it doesn't really do anything. But if you were to look at the code that's generated, the car class will have an empty method called new, and it will call that. Nothing happens, but just know that behind the scenes there's a default constructor that's always created for your classes. So you can always use the method invocation operator after the creation of the instantiation of a new class, and you can know that at least it will work. It won't throw an exception. However, once you declare a single version of a constructor, then from that point on, you won't be able to use it, because the default constructor will be covered up by your new constructor. All right, and furthermore, even if you were to create this version like we saw earlier, it will cover up the default constructor as well. All right, finally, I want to talk about another keyword called shared. And what you can do with the shared keyword is to create methods, especially methods, but also properties that do not require you to create an instance of the class in order to use them. So many times classes that we're going to work with related to building .NET applications, they don't require that you create a new instance of them first in order to start using their methods. And a good example of that is the console class. We didn't have to create an instance of console. We just started using the methods of the console class like writeLine, readLine, clear, and others. So another example, when we were working with arrays, you remember I used the array.reverse method? We didn't have to create an instance of the array class. We just started using the array.reverse method, and you typically would use this whenever you need methods, but you don't really need to keep the state of an object. You just want to collect together a bunch of utility methods that do something in your system, but they don't rely on a specific instance of a class in order to operate. writeLine, readLine, clear, they're all available by just referencing the class name console, because when Microsoft created those methods on the console class, they marked them with the shared keyword if they were writing it in Visual Basic. All right. So you can create your own shared methods as well. And so our objective here at the outset is really just to utilize the .NET Framework class library and understand the difference between a shared versus an instance class. So there's instance methods and there's shared methods. There are instance properties and shared properties. For the most part, up to this point in the car class, we've only used instance methods and instance properties. But what I want to do is create another class, and I'm going to call this public class carlot. And here what I want to do is create an add to inventory method. So public sub add to inventory, and what we'll do is go by val new car as car, and then I'm not going to implement the body of this because we really don't have anything at this point that would help us with this, but the body of the method goes here. I might save this instance of car in an array, or better yet, in a collection, which we'll learn about later. Okay, but the focus here will be just on the fact that we can mark this with the shared keyword. And now notice in our module1.vb, what I can do here is go carlot dot add to inventory. I didn't have to create an instance of carlot because the add to inventory method is shared across all instances of carlot. It doesn't depend on an instance. It's shared. So in this case, I would just pass in like my car, and then it would perform whatever operations on it. You might also notice that I was able to define a second class inside the same file. I typically would want to move those out into their own files, but for such a small version of a class, I can just create it right here inside of another file. Okay. Now, why you might want to use the shared keyword, that's a little bit more complicated. It might require a longer discussion of design patterns and coding heuristics. Again, I just want you to know that it's available, and more importantly, I want you to know that you're going to encounter shared methods as opposed to instance methods like we created previously, and then also with our constructor. You're going to encounter them in the .NET Framework class library. And then why you would actually use this inside of your own application might not be obvious now, but you can pick that up a little bit later as you're designing your own code libraries that other developers on your team might utilize. So it's not really important why you use them just yet. Just know that they're in use in the .NET Framework class library, and there's a reason, and we're not going to talk about that reason in this series. Okay? So let's recap what we talked about. In this lesson, we talked about the lifetime of an object, including what happens when there are no more references to an object in memory, and how the .NET Framework runtime employs garbage collection to remove objects at some point during the execution of the application. We looked at constructors and talked about when they're actually invoked, how to create an overloaded version of a constructor. We talked about the default constructor and why it's not available if you create any other version of a constructor. And then finally, we also looked at the shared keyword, essentially to create utility methods inside of classes so that we don't have to create an instance of the class in order to utilize that particular shared method. And we've seen instances of this all over the place whenever we were working with the console class, the date class, and so on. All right, and you'll continue to see those in the .NET Framework class library. That's the important part. All right, so if you don't completely understand the notion of shared or any of these other ideas, just I would say for now, just go ahead and continue on. Just understand basically conceptually what it is, and we'll learn a lot about some of these other concepts as we continue to move forward. Okay, so let's continue on the next lesson. If you got this far and you're with me, you're doing great. We'll see you in the next lesson. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devview.com. Now, we haven't spent much time talking about the scope of variables up to this point. We did see how scope would impact the lifetime of an object in the previous lesson, talking about as object references go out of scope, so as the current execution flow for the application extends beyond the end of the sub, what happens to our objects in memory? Well, they get garbage collected, right? But I want to take some time and talk about scope, and I want to make sure that you understand local scope and scope at a module and class level, and so that you can more completely understand the topic, and then we'll use that as a launching board to get into visibility. And so there are visibility modifiers like the public keyword, and there's also a private keyword. There's several others in relation to writing classes, and then methods and properties inside of those classes, and how those keywords, those accessibility modifiers, change the visibility of classes and their members. All right, so before we jump into accessibility modifiers, like I said, I want to talk about variable scope. So let me start by saying that whenever you declare a variable inside of a block of code, that variable is really only alive and accessible for the life of that block of code. Meaning that whenever that block of code has finished executing, the variable defined inside of that block of code is no longer accessible. Its values are disposed of by the .NET Framework runtime. So I want to see how that applies to common code blocks that we've been working with up to this point, and kind of extend out from there. And to begin, what I want to do is go to the before folder for this lesson. And so wherever you currently are watching this video, or where you originally downloaded it from, there should be a folder of code. We're going to look at the before folder to grab out our understanding scope project. And I'm going to copy it. Personally, I'm going to copy it into my projects directory here so that I can find it with all my other projects. I'm going to double click the solution file inside of that project folder, and you'll see that we have just a simple car class, and then also our module 1.vv with an empty submain. And so what I want to do is create a small project to understand scope a little bit better, and I want to test how variables that are defined inside of a code block work as we move outside of those code blocks. And so it's going to be a very simple example at first, and we'll just keep building on it. But any variable, whether it's a simple type like strings and integers, or something more complex or custom like the car class, it still applies what we'll talk about here in this lesson with regards to scope. And I just wanted to make you aware of that as we get started. So to begin with, inside of here, let's start with a console.readline. And then above that, I'm just going to create a for statement. So for index equals 1 to 10, in fact, I'm going to change this from index just to the letter I to stay consistent with the rest of my code I'm planning on writing. And while we're inside of this code block, the I that is declared here and initialized to the value of 1 and will be incremented as we go through the for loop, we can access its value inside. And we can see that quite obviously. We can print out 1 through 10. But what happens if I try to access that outside of the code block in which that I was defined? Well, in that case, we try to go here and print it out and run our application. First of all, we get a compilation error. We get a little red squiggly. I is not declared. It might be inaccessible due to its protection level. Its protection level has nothing to do with it or its accessibility level. The fact of the matter is that I is out of scope because it was declared inside of this code block. It's not available outside of that code block. All right, so that's the lesson here that we want to take away. So we're going to look at some other common usages and show what you would have to do to make this work. So let's go outside of this and do dim j as string equal to an empty string. And then inside of our code block, I'll just go j equals I dot toString like so. And then can we actually view it here? And so actually let me do this just to make sure we know what we're dealing with here. So j equals, and then let's do I is, all right, so that should be pretty clear. Let's go ahead and run the application. And now you can see that, first of all, I is 1 through 10, and then because j was declared outside of our code block, our for next loop, we're able to access its value, its current value, which was set to the last value that I was set to, which was 10, and it's printed out here outside of our code block, right? Okay. So now let's take this one step further, and what I want to do is define a variable outside of submain. We've never done this before. When I create it like this, it's called a field, a private field. So it's a variable that's accessible then to all of the methods that are inside this module, all right? So we'll use the private keyword, and I'll come back to that a little bit later, private k as string, and I'll even initialize it to just an empty string, all right? So here what we'll do inside of the loop is exactly what we did here, I.toString. And I am pretty sure that we're going to be able to access it here as well, but we'll just make sure by doing that. Now outside of this, we'll call or we'll create a private sub helper method like so. And then inside of this, what I'm going to do is console.writeLine, and we're going to go k, but we're going to do it from our helper method. Like that. And then we'll print out the value of k. And then finally what we'll do is we're going to need to call that helper method here. So again, I can just call helper method by giving it its name and using the method invocation operator. And now let's see if we're able to access the value of k inside of this method, even though we created it outside of all of the methods and set its value inside of our submain. Let's run the application. All right, and you can see the results here when we get near the bottom, k is equal to 10, and then when we call the helper method, its value is 10. So we're able to access, or the scope of the variable defined here outside of, or as a, you could think of this as a relationship, as a sibling relationship to submain and private sub helper method. It's accessible then to its siblings at the same level, all right? So let's continue on. Now let's go inside of this for loop, and we'll go and create an if I equals 10, then we're going to dim L as string equals I.toString, and I'm going to do console.writeLine. L, and then we'll print the value of L right there, okay? I think you should probably be able to figure this one out without me telling you, but I'm going to go ahead and try this anyway. What do you think will happen here? Well, you can already see we get a red squiggly line. L is not declared. We're trying to access it outside of its code block. Now, what if we were to do this? We know we can't access it there. Can we access it in this code block? Well, no, we still can't because it's outside of the code block in which it was declared, so it's no longer accessible. So unfortunately, those will not work. All right. So hopefully, if you've had any confusion or misconceptions around variable scope, this little exercise that we just went through will help clear some of that up. And now what I want to do is to move on to a more important topic of accessibility modifiers. Why do we use public and private, for example? So in the methods that we've written in the previous lessons, we always started with the word public. In this case, I started with the word private here for this little variable and for this method. And public and private are called accessibility modifiers. They're used to implement a tenet of object-oriented programming called encapsulation. So in a nutshell, classes should be little black boxes, like black boxes on an airliner, which record every move that the airline or that the airplane makes, and so if it does crash, then they can find out. But the black box will has no other controls on it. It'll just automatically record everything. And so I think maybe even a better example might be those old style television sets. You may have had one in your home. I'm a little bit older, so I remember the days when my parents or even my grandparents, you'd have to get up from your seat and actually push a button or turn a knob in order to turn the television on or off, or to turn the volume up or down, or to change the channel, okay? There were no remote controls. The kids were the remote controls back in those days. So you had only just a couple of knobs and dials and buttons. And there was maybe also a place on the back to attach an antenna, and then maybe a plug, and you plugged in the television set into the wall, but everything else was enclosed, encapsulated inside of this magic box, okay? It's all self-contained. And as a kid, I would be fascinated whenever my dad popped off the back of the television set to replace a tube, to fix one of the tubes. Yeah, you used to be able to do that sort of thing. It still seems like magic to me that, first of all, my dad could even figure that out. And then secondly, you know, all the complexity inside of the box once we opened up the back and took a look at it. Now, all I know as a kid, and even to this day, all I know is the public interface, the buttons, the knobs, you know, the electricity. I can plug it in, I can hook up the antenna, but that's about it when it comes to television sets. And frankly, you know, that's all you really need to know about a television set to use it, right? As the consumer of the television, I just need to know the simple controls, and everything else is encased inside of plastic, and it's all hidden from the end user. And that's the way that it should be when you create your classes. Classes should be like little TV sets that are all the complexity of it is closed off. You just have a couple of public interfaces that consumers of the class can utilize, but everything else is hidden in private, so that somebody can't get in and just start making changes to it and potentially break the class. All right. So the behind the scenes functionality, especially for methods, should be encapsulated behind interfaces like public methods and public properties. Now, classes may have private properties, or rather private fields, like something like we created right here, as well as private methods like the one that we created here in this module, and to use as like helper methods, and they're used to enable all the magic that goes on inside of our class. But the consumer of the class doesn't know anything about these private members, these private properties, and the private methods. It has, and it shouldn't have, any knowledge of the underpinnings of the actual class itself. All that the consuming class needs to know about is what's publicly exposed through public properties and methods. All right. So in a nutshell, private means that the method or the property, but specifically the method, can be called by any other method inside of the same class definition, but it can't be called outside of the class definition. So that's why I use the term private helper method, because typically a helper method, that term helper method, is used to provide some additional functionality that outside of a given class, it should not be able to see it, but inside the class, it just provides some additional features that can be utilized by the public methods. All right. So, at any rate, a public method will then be accessible to outsiders. That's what they'll call to get their work done. Private methods are going to be used by insiders, those who are those methods that are also declared inside of the same class. So here what we'll do in our car class is actually create a private helper method. In fact, I'm going to call this private function helper method as string, and I'm just going to do something really simple. Howdy partner. All right, so all it does is just return a string, nothing fancy at all. But let's pretend for a moment that that's all the business logic and complexity of our application, and it's all hidden there inside of a private method. Now, I may create a public method. So public sub do something important, like so. And here I might just do console.writeLine, and then I'll call the helper method, okay? So just a real quick caution, you probably don't want to ever put a console.writeLine inside of a class. There's a long reason why we have two concerns now that are munged together in the same code. I don't want to go into depth, but typically you would just want to return back a string and then let module 1 actually print that to screen. But at any rate, just felt like I needed to give you a little bit of a caveat there. So let's go here after we've done all of this work. In fact, let me select it all and I'm going to comment it all out. And here what we'll do is go dim my car as new car, and then my car dot, and notice that I can see the do something important, but I can't see that little helper method, okay? Because it's private, it's hidden from me. So all I can know to do as the consumer of the car class is to call do something important. Behind the scenes, I don't know what's going on. Now, you know, that's a little bit of a misnomer. I, as a programmer, can look here and see, oh, I see what it's doing. But we're talking about this from the perspective of the code that's doing the calling. It cannot see into the implementation of that class. It shouldn't have any knowledge of what's going on and how it's actually doing its implementation. So yes, in a sense, because we're the programmer, we can see what's going on inside, but we don't want any other objects to go in there and fiddle around and make any changes or be able to call the helper method independent of the higher level public do something important method. All right, so you have to kind of use your imagination and work anthropomorphically in the code, looking at it from the perspective of the sub main, not from the eyes of the software developer. All right, so here, let's run the application now. You probably guessed what you'll see. Just the words howdy partner. Actually, the example is much less impressive than the concept itself. Admittedly, this is extremely mundane. It's a simple example that's only real value is to illustrate the notion of encapsulation. So we're hiding the implementation, but exposing a public interface that's available to consuming code like submain. All right. So the purpose of this lesson is to better understand the notion of scope, because we said once variables, especially those variables that are holding on to references to objects in our computer's memory, after they go out of scope, then those variables values are no longer accessible. The .NET runtime gets rid of them. Garbage collection then will remove any of the objects in memory that no longer have any references to them. Furthermore, it's important to understand that there are parts of classes that you have access to, and then there are parts of classes that you won't have access to. So there are probably many more methods in the .NET Framework class library that you don't have access to because they're hidden behind the private accessibility modifier. All right. Now, if you ever do decide at some point in the future to build your own custom classes, then you should strive to expose public methods and give a simple, straightforward, obvious usage for your class while keeping other helper methods that implement the logic of your class privately tucked away and not available to the prying eyes of the consuming code. All right. You want to give the code that's calling into your class a way to use the class properly through the methods that you designed and the input parameters and the return values. So this removes ambiguity whenever you're very clear about the way to call into a class. It makes its usage much more clearer and obvious as well. And so in the .NET Framework Class Library, methods and properties are exposed using the keyword public. They may also use private methods, but we would never know about that, right? So they might use other types of accessibility as well. We only talked about public and private. There's one called protected. There's another one called, I believe, internal, and some others. But they're used primarily whenever you're building a much richer inheritance relationship between classes, when you're building this rich class hierarchy, a library of functionality, and most of us probably won't need to do that, not for some time. So you really don't need to know those just yet. But again, they're available. It's just kind of beyond the scope of what we want to talk about here, absolute beginner topics. But some of those topics I cover on DevU, especially for C# developers. So just to recap, in this lesson we talked about variable scope, how variables have a lifetime based on the code block in which they're defined. When the current code block is part of the current scope of the execution at runtime, the variable will be available, but once you exit out of that code block and the flow of execution extends beyond the definition of the code block, then those variables will no longer be available. We also talked about accessibility modifiers like public and private and how that impacts the way that the .NET Framework Class Library is accessed, that we can only get to the public methods. And even perhaps someday when we build our own class libraries for our own applications, we might want to use accessibility modifiers to control what the consumers of our classes actually can see. And we want to hide any helper methods behind the private keyword while exposing methods using the public keyword. All right, so we're doing great. Hang in there. We're getting close to the end, believe it or not. A lot of the complexity we've already covered. You're doing great. We'll see you in the next lesson. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. Previously, I said that the .NET Framework Class Library is just a collection of classes that contain methods filled with functionality that you can use, but you didn't have to worry about, you didn't have to write them. Somebody at Microsoft has already created those for us. In fact, Microsoft has spent tens of thousands of man-hours writing code, and we get the benefit of it by all we have to do is just know that the code exists, call it by its name, and utilize it inside of our applications. That's pretty cool. So since the Framework Class Library is so large, its developers split it up into multiple files. So if you had to load every single line of code in the Framework Class Library, every time that you wanted to run a simple application, it would be excruciatingly slow and it would require a massive portion of your computer's memory. So these library code files are called assemblies, and all of the classes and methods are split up into different assemblies. In fact, when you create your own projects, you are creating the basis for a .NET assembly as well. In fact, there are two kinds of assemblies that we're talking about here. The first kind is an executable assembly, and the other kind is a library. All right, so just make sure that you understand that there's two different kinds of .NET assemblies. There is a executable assembly that has a .exe file extension. And then there is a library that only has code. There's nothing really executable about it. You can't just like start it by double clicking it. It just contains functionality, and those have a .dll file extension. Again, it's intended to be used by other code that is executable. All right. So every time that we run an application here inside of Visual Studio, what happens is that in an executable .NET assembly is generated for us inside of the bin directory for our project. So if we were to take a look at, here, let me just pop open our projects folder, and we were just working with, which one were we working with here just a moment ago? I think we were working with understanding scope. So if we were to drill into the project folder, we'd see a bin directory. If you drill into the bin directory, there will be a debug directory. If you drill into there, you'll see a number of files, but the most important is the understanding scope.exe. If we were to double click it, then we would get the results from the previous video. All right, so there are some other files that are included here which help Visual Studio's debugging experience connect to the executing assembly, and so you can safely ignore these. They're just regenerated every time that you want to create a new version of or rerun your application in debug mode. But at any rate, the .NET framework has to already be installed on the computer where you're going to actually execute this program in order for it to work, because it will load itself into the .NET framework runtime, and like we talked about near the very beginning of this course, and it will live inside of that protective bubble. Now, fortunately, just about every copy of Windows already has the .NET framework installed in a location that's globally accessible by all .NET applications, so you don't have to distribute the .NET framework with your applications whenever you want to distribute it to other people. And so that location is called the Global Assembly Cache. Unfortunately, that's not something we have to worry about. It's just sitting on everybody's computer. So back to my original point, whenever you create your application, you indicate which of those framework class library assembly files that you intend to use. And you say, well, wait a second, I don't remember ever declaring that I wanted to create an executable versus a library, but actually you did whenever you were actually choosing to create a file new project. You were selecting a console application, and by default it'll create an executable for you. However, we could, and we will in the next lesson, create a class library, and that'll allow us to create a .dll file that only contains classes with methods inside of it that we can then use from other executable applications, whether it be a console application or a Windows or even a web application. All right, so let me just cancel that. So at any rate, let's go ahead and get started by creating a new application here called Resolving References. You can see that I've already taken the liberty of creating a new project called Resolving References. And what I want to do is talk about the references to the various classes that you'll need access to in order to get work done. The classes defined in the .NET Framework class library, how do we add a reference to those and utilize them? We've already seen this one time whenever we were trying to use the string builder class. Remember, I try to use dim my string builder as new string builder. And at that point, I got the red squiggly line, and it said string builder is, the type string builder is not defined. And I said, well, I know that it exists in the .NET framework, but what I needed to do was to actually get a reference to the namespace where that particular class lives. Now, sometimes you're going to need to add a reference to an assembly that's not currently referenced by your project. But as you're getting started, that will not happen very often. If we take a look at the Solution Explorer and you were to expand references, you can see that there are all of these references to these DLL files. Even though they don't have the DLL file extension, they are actually all saved in different DLL files. And you can see here in the Properties window near the bottom right-hand corner that in this particular case, the system.xml.link is actually saved in a file called system.xml.link.dll. And same is with system data, it's saved in a file called system.data.dll. All right. And so there's a whole bunch of files. Here's system.dll. These are all references that were added for us by default whenever we created a new console window application, because these are common namespaces and assemblies that contain stuff that we will typically need as software developers. So that's one of the functions of the project templates as we create new projects. So typically you're not going to need, especially as you're getting started, you're not going to need to add any additional references, because you're not going to use a custom DLL, although we'll do that in the very next lesson. Most of the functionality will be in one of these namespaces, in one of these assemblies, all right? Or maybe you need to add a reference to an assembly that's created by a third party. Maybe not you, maybe not Microsoft, maybe some other company. And again, in the next lesson, I'll demonstrate how we'll create a reference to an assembly that's not already referenced inside of our project. But once a DLL is referenced in our project, we might need to then find it by its name. Now, again, I said a little bit ago that the .NET Framework class library is massive. There are tens of thousands of classes defined in the full .NET Framework class library across all of the assemblies. And so in a few cases, there were the same class name needed to be used. And so when that happened, the creators needed a way to tell each of those classes apart. So they introduced the concept of a namespace. So namespaces, like I said earlier, are like last names for your classes. So for example, my first name is Bob, and you might try to say, hey, Bob likes coffee. And somebody else might say, which Bob are you talking about? I know like a dozen Bobs, and there's like a billion Bobs in the world, okay? And they say, oh, no. You know, Robert Theron Tabor. All right, well, they may not use that formal language, but if you were to disambiguate me by my full name, my middle and my last name, you could probably uniquely identify me to the world. I'm pretty sure I'm the only Robert Theron Tabor. That middle name is pretty unique. I know there's a lot of Bob Tabors out there. But at any rate, this disambiguates me from every other Bob or every other Bob Tabor out there by using my full name. So namespaces in the .NET Framework class library disambiguate class names. So now you could use the full name, or you can just add an import statement. In this case, you can see that I have the name string builder, but my program doesn't know where to find the string builder class. Now you can see there's this little quick actions light bulb that appears off to the left hand side, or if I hover my mouse cursor over it, I can then select to either import system.txt. We did that last time. Remember how it added that to this import statement then at the very top of my file. But let me comment that out. That should give us an error message again. And this time, let me just use the full namespace. And you're like, well, that's not really the full namespace. That's right. The full namespace is system.txt.stringbuilder. All right. But since system is assumed to be part of your the namespaces that are imported by default, you don't need to add it. You can just go text. But honestly, if you're going to go to that extent, I would recommend that you go ahead and use the full name to remove any unclarity. So those are two ways in which you can find the classes in the .NET Framework class library that you already have references to, that you're already referencing the assemblies that live in the global assembly cache on the user's computer. All right. So, by the way, a couple of things that you probably need to know about. Number one, your project will automatically have a namespace, and it'll be the name of the project. If you want to change the default namespace for your project, what you'll need to do is select the project inside of the Solution Explorer. You can right-click and then select Properties. And you can see if we go down to, the assembly name will be Resolving References, and the root namespace will be Resolving References. Now, we could change the root namespace, but we should probably leave it by default. So whenever we're calling into, for example, if we had some classes, it will automatically know that those classes are in the same namespace as Module 1. If not, we could import that new namespace, or we could add the full name of the class. So resolving references.car, for example. why is this important? Well, typically, whenever you want to build applications, you're going to want to do something and you're not going to know how to do it. So at that point, you're probably going to open up a web browser and you're going to start doing some searches out on the internet. So for example, say I wanted to figure out how to write text from my application to a file, to a text file on my computer. So what I might do is do a search in Bing. So search, and I'm going to just refine this search and say I only want to search Microsoft.com. Write to a text file and then Visual Basic. All right, and this will probably get me to a good article on how to write text to files in Visual Basic. Happens to be the top answer there. And so now what I might want to do, and they give me a couple of different examples here. All right, now it looks to me like this particular article is cheating a little bit. It's using the My Namespace, and that's not really going to accomplish what I want for this video. We're going to talk about the My Namespace in the very next video and how the My Namespace makes some things extremely simple. We can find most of these types of functions just by using the My Namespace. It's special to Visual Basic. But this isn't a good test of the functionality because, frankly, we're cheating a little bit here. Let's go back and instead let's search for something different. We're still going to search Microsoft.com, but this time let's go Visual Basic retrieve HTML string, and let's see how to retrieve data from a website using Visual Basic. All right, so. Not sure this is exactly what I'm looking for either, but I happen to know if I were to do the searches for something called the web client, I'd be able to find some examples in Visual Basic. There we go. Let's see this example on MSDN. And here I'm going to go to the VB version of this and see if it gives me any good examples down here near to the bottom on MSDN. Yeah, and so here we have the VB version of our code, and I can kind of look through and see how this will actually work. And this seems to be like a pretty advanced example. What if I look for this download string? I happen to know that that's the method I'm looking for. And again, we're looking at the VB version here. And so, yeah, this is a little bit more like it. This is what I want. So here they give us the ability to put in an address and then grab the content from that address. So I'm just going to copy these 3 lines of code, Control C, and then I'm going to go over here and I'm going to paste these in. Now, yes, here's what I wanted to demonstrate to you. When you paste in code from the internet, sometimes you're not going to have the references. You're going to need to resolve the references. Now, you'll see that this little light bulb will pop up sometimes, and it will give you the import statement, or it'll automatically type out for you the entire namespace for the given class if it recognizes it. However, what I'd recommend, so you can keep your fingers on the keyboard at all times, is to hit the control period, and this will open up that little dialog and allow you to use the up and down arrows to choose which of these you want. In this case, I want to import system.net. That's the namespace where the web client class is from. And then in this case, all we need to do is pass in, I think, just an address as a string. So I'm going to type in my website, devview.com, and then it should be able to give us back all of the HTML from my website and print it off to the console window. So let's see if that worked. There we go. All right. It took a second, but we got it. And now we've got all of the HTML. And I'm going to go ahead and hit enter. And so you can see that we were able to copy code off the internet. We had to resolve the references by hitting control period on the keyboard in order to bring up that little menu and eventually add a import statement for the namespace for the class that we want to use. And then we can continue on. All right, so that's all I really wanted to illustrate is how to work with namespaces and how to resolve references to classes that are referenced or that we have references to because they're part of assemblies that are referenced in our project, but that we have not yet imported the namespace into our project's consciousness. All right, so we're going to continue on and take a look at the My Namespace in the next video, and we'll continue on from there. And we'll see how we can utilize the My Namespace to do some pretty cool stuff without having to hunt and find all of the classes that we might typically need in order to do interesting things with our applications. So we'll see you there. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. So we saw the My Namespace pop up ever so briefly in the previous lesson whenever I was trying to find a good code example to write text to a file. And I saw the help article on MSDN. I'm like, oh, they cheated. They used the My Namespace. Well, the good news is that the My Namespace is available to Visual Basic developers, and it's unique for Visual Basic. Basically, the developers of Visual Basic went around and found all the most useful classes in the .NET Framework class library that we'd want to use for finding things out about a computer or about the file system or working with the network or working with specific peripherals, and made them all available in one concise tiny little spot so that we can always go there first to see if they've got something for us to use or if we have to go out on the internet and search to find some code snippets to actually help us implement some functionality. So at any rate, the My Namespace is automatically available to all Visual Basic projects. All we have to do is kind of navigate around and find what we're looking for inside of the namespace, and I'll show you how we'll do that in just a moment. So in this lesson, what I want to do is just show you a smattering of cool little things that you can do with the My Namespace, get your creativity flowing, and then maybe you can use it for something on one of your future projects. So it's great for things like getting information about the current computer that you're running on. It's great for working with files and folders on the computer, working with command line arguments into your command window application, and then also working with configuration files like the app.config file. So we'll show examples of all of these and a little bit more, but note that there's even more that you can do with it, and you just can take a few moments and navigate your way around using IntelliSense through the My Namespace. You can see that there are things like the application namespace, the computer namespace, the settings namespace, the user namespace, the web services namespace. All of these are shortcuts into the full .NET Framework class library, giving you quick access to some pretty cool functionality. All right, so let's start off really simple. We'll just do a console.writeline. And here we're going to go my.computer, and we'll just grab out the name. But notice here, now that I'm in the My Computer namespace, I can get to things like audio and I think the screen as well. You can get to the clipboard to copy and paste things onto the clipboard, to the clock, to the file system, find out information about the hardware of the computer you're currently on, work with the keyboard and the mouse and the network and the ports and so much more. So very cool. So in this simple case, let's just grab the name of the computer, and then also what I'm going to do is grab the amount of memory that's currently physically available on my computer. But even note that about the info class, I can grab things like the UI culture, what language and country that I'm currently have installed in Windows 10, the operating system name and version, the platform that we're running on, total physical memory, and virtual memory and things like that. So let's just grab the available physical memory. And then console.readline, and then let's just run the application. And I have a really crazy name for my computer. I didn't build it myself. I did build it, but somebody else installed the operating system. I would have had a cooler name than desktop, OULNDHDO, but meh, whatever. And then here's how much physical. Looks like I have, I'm not sure how many gigs that is. Is that 1.7 gigs or 11.7 gigs? I'm not sure. I guess I could format that nicely with a string.format, and then here, let's use our, like that, remember? And let's get a better idea. So yeah, I have 11.6 gigs of memory, I guess, available. Nice. Okay, so let's comment that out. And now let's move on and look at another example here. Suppose, for example, I wanted to just take a look at all the subdirectories available in my documents. So I might do something like this, dim files as, or just dim files equal, and I know you're not supposed to do this, but I'm going to do it anyway in this case. mycomputer.filesystem, and I want to, and you can see all the things you can do. You can copy directories and files, create a directory, delete the directory and file, determine if a directory exists, search inside of files for text, and so much more. Move, open files, read, rename things. A lot of cool features here. So let's get directories, and I have to supply the topmost directory that I want to use and look inside of. So we're going to go users Bob and then documents. We're going to look inside of all of the subfolders. For documents, I'll just do a for each through each of the items in the files and do a console.writeLine and print those out, so each item. And so now let's run the application, and you can see here are all the subfolders inside of the C users Bob documents directory. Pretty cool. Great. And so now let's go ahead and comment that out. And the next thing I want to do for my next trick, I'm going to actually do this. Inside of the code that's available for this particular lesson, there should be a folder called test, and it just has three text documents with a famous saying in each one, like now is the time for all good men to come to the aid of their country. There's a couple of others like that, and I'm just going to copy that entire folder, and I'm going to put it on the root of my C drive. So I'll just paste it there. And now what I want to do is come back in and do the following. So dim files equals my.computer.filesystem.find in files, and here I'm going to give it the directory to search in, that test directory. I'm going to say search for the word time. Tell me which files have the word time in them. And then I have to give it whether I want to ignore the case or should it honor the case. Let's just say ignore case. And then finally I have to give it a search type. Just do this, file IO dot, and then we want to choose search option dot. I can either search all directories or the top level only. Doesn't really matter in this case, but I'm going to only search at the top level. And now it should retrieve back a bunch of strings. We'll parse through the strings and print them all out to screen. But here we see that only one file has the word time in it. Let's confirm that by opening up our test folder and looking at the fact that here is the word time in this text file. It's not in this text file, and it's not in this text file. Okay, so it worked. Very cool. All right, next up, what I want to do is actually, let's comment this out for the moment, and we'll stick with the file system for a moment because it is so handy to do stuff like mycomputer.filesystem.copy directory, and here I'm just going to take that test folder and I'm going to copy it into a new folder called test2, and this will allow me to overwrite the folder. So yeah, I'll say, yeah, go ahead and overwrite it if it already exists, which it does not. So now here we'll just do console.write just to give us some feedback that we finished, and we'll run the application. It finishes almost immediately, and then here we'll go back, look at our C drive. Now notice that we have a test2 folder. It has the same 3 documents that the test folder has in it. Very cool. Okay, so let's comment that out and let's move on to the next example. What I want to do is now show you how to work with arguments that you can pass in to your application. So many times console window applications have the ability to pass in extra information as a series of information that is just, you use spaces to delineate between each argument you want to pass in. Then you use those arguments inside of your application to branch and to decide what functionality to enable. What we can do is one of two things. If we want to open up a command window and navigate to our My Namespace project, we can go Documents, so CD Documents, CD Visual Studio 2015, CD Projects, CD My Namespace. That'll get us into the Solution folder, and then we're going to go CD My Namespace to get into the Project folder. Then we're going to go CD bin to get into the bin directory, and then I think there's a debug directory, right? So we'll go CD debug, and then I'm going to do a dir, and you can see all of the files that are currently there. We'll come back to that in just a moment. What we'll do here now is actually do dim arguments equals my.application, and here we can get at things like the culture, the UI culture, info. I'm not sure what you can get from info. Oh, okay. Oh, info about this application. Right. Okay, I get it. And more importantly, though, I want to look at the command line arguments that are going to be passed in, and then we'll go for eaching our way through each item in the arguments, and we'll just do a console write line to show that we can actually retrieve them out and display them on screen. But ideally here we would do some logic inside of our application and change the functionality based on the arguments that are being passed in. So let's go ahead and just run the application once to compile it. So that will get it compiled, but now I can open up here and just go my namespace.exe, and then I'll just do A, B, C, and D. Notice that I use different capitalization, and it actually prints out each of those to a different line using console.writeLine. Very cool. Now, if I didn't want to go to all this work inside of the command prompt window to navigate into the project directory, I could use a special feature inside of Visual Studio that allows me to adjust the properties of my project. So I'm going to right-click on the project name in the Solution Explorer and select the Properties option. And here we're going to go to the Debug tab on the left-hand side and type in our arguments. I think we already did A, B, C, D. Let's go E, F, G, H, and I. All right, so we're giving it 5 more command line arguments. We'll save this and then rerun our application. And this time you can see that it gives lowercase e, uppercase f, lowercase g, uppercase I, h, and then lowercase I. And we can basically test our command line arguments right here from inside of Visual Studio. So just so you know. All right, let's comment all this out. So that's another very cool little thing we can do with the My Namespace. Let's move on and talk about one other thing. Let's stay in that properties editor and go to let's go to settings. So here we have this little grid where we can actually add settings that we can write to and retrieve between runs of our application. So we might want to save the user settings, what their preferences are in this app config file. And we could write and open up that app config file and look at the XML ourselves where it stores all these values. But this is a much nicer editor that we can work in. So I might want to store something like first value and set that equal to Bob. And then go second value and set that equal to like Conrad, right? So now we have 2 strings that are stored in our app config, and I can retrieve them out and use them inside of my application using the my.settings.firstValue. Notice that it automatically creates a property called first value and creates one called second value automatically because we created those keys inside of our settings tab of our properties. So let's go, let's do this, console.writeLine, and we'll do a before, and here I'm going to just print out my.settings.first value, and then my.settings.second value. And then I'll tell you what we're going to do. We'll have a little fun here. Let's grab this. Let's make a change to it. We'll set first value equal to Beth instead of Bob. And then we'll set the second value equal to Grant instead of Conrad. And then we'll save those changes. And then we'll go ahead and print this out again, except this time we'll do after. And let's just grab this and just add an empty line there. All right, so this should be interesting. I'm going to get rid of that too, or actually let's just comment it out. Okay. All right, a lot of typing here, but hopefully you can see what I'm doing. I'm going to open up and grab the current values inside of the app config, and then I'm going to change the values and save them and then display what the new settings are here in my console window application. And you can see, whoops, we get the before and the after as the same. I wonder why that happened. And let me try this. Try to reset our settings here, and let's go ahead and run it now. All right, there we go. Now we got what we needed. All right, very cool. Okay, so I'm going to go ahead and stop right there, but as you can see, there's a lot of things that you can do with the My Namespace. There's even more. I'll let you go ahead and explore it and learn more on your own. But at any rate, I'm going to go ahead and move on to the next topic. If you're still with me, you're doing great. Keep pushing through. We're so far along at this point. We're just tacking on other great information to make your applications even richer. And we'll do that, continue that process in the next lesson. We'll see you there. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. Previously, I said that the creator of the console window project template, whenever we go File, New Project, and we select console application or console window project, it added references to the parts of the .NET Framework class library that we might find useful. However, if there was a need for some class that didn't reside in the assemblies that were by default referenced in our project template, then we could add a reference to it ourselves. And the way that we would do that, and you can see I just have a little throwaway application that I'm calling typical console application. The way that you can do that is to select the references node inside of the Solution Explorer, right-click and select Add Reference, and that'll pop up the Reference Manager. And you'll see that there are a number of different categories here. We'll choose Assemblies and Framework. And here you can see all of the assemblies that are part of the .NET Framework class library. You can see some of them already have little check marks next to them indicating that we already have references to those. Now many of these, I don't know that anybody has used them all. There's just so many of them, and you only choose the ones that you need for your specific application. Some of them are specific to types of application, whether it be a Windows or a web application. Some of them deal specifically with data, accessing data from a database or accessing data in the cloud. Some of them have to do with just security. Some of them have to deal with I mean, there's just everything you can possibly think of. It's going to be represented here in one of these. So if I needed one of these, what I could do is just find it. For example, system.data.link. I might want it to create or maybe SQL XML. I want to work with XML and save it in a SQL database. I might then add that reference by clicking the checkbox next to it and then selecting the OK button, and now it's added that reference to my application. I can use all of the classes and namespaces inside of that if I need it. Now, if I wind up not needing it, I don't have to worry about removing the reference. This is really just a convenience for compilation. The .NET compiler, the Visual Basic compiler, is smart enough to know that we really didn't need a reference to that particular assembly, and we didn't use any of the namespaces or the classes inside of that assembly, so it'll safely ignore it on its own. All right. Now, that's one way that we can get those additional libraries that were created by Microsoft for specific purposes into our application. But there's also a wealth of free open source libraries that are created by third-party companies and teams of individuals that provide many common features that we might want to add to our application. And so the repository for those open source projects is NuGet. And what we can do is go to Tools and go to the NuGet Package Manager. And while we could use the Manager console, I recommend that you, starting out, use the Manage NuGet Packages for Solution. This will open up a visual editor. And what we can do is browse for a specific type of library. Perhaps we know the name of the library that we want to use. Let's say I want to add some logging capabilities to my application. I might choose this Log4Net, and there's a bunch of different ones, but I might select it and then say, oh yeah, I want to add that to this project, this typical console application, and I want to install the latest stable version of it, but there are some other options that I could choose from down here. I'm just going to go ahead and click install, and now it's going to grab down all of the assemblies and references to other dependencies that I would need in order to use that Log4Net library of functionality inside of my application. So I just wanted to show you how to use it. We won't be using Log4Net, but you can see that it's now been added to as a reference inside of my project. It's also copied down some of those library files into the actual project. Here, let me find it real quick. Look for typical console application, and here you can see that there's a packages folder where we have the Log4Net, and there's a bunch of different versions of it. And then when we go to actually utilize it and compile it in our application, it'll show up in our debug directory as well. At this point, we haven't added any references to the DLL, so there's no need for the compiler to copy the library over into our debug folder. So at this point, we don't even we don't see it. But I just wanted to make you aware of the NuGet Package Manager. But then there's a third scenario where we might want to create our own library of code to reuse within our own company or within the projects that we work on individually. Maybe we could even open source them and distribute them to others through NuGet at some point. So what I want to do is create a code library. We haven't done that up to this point. And I want to use some of that logic from 2 lessons ago where we were actually able to go out online, grab all the HTML off of my website. And what I also want to do is not only display it in a console window, but also save it into a text file. And we'll call that something like scrape web page. All right. So what I'm going to do is create first of all, a new project, and this time I'm not going to choose console application. Instead, I'm going to choose class library, and we'll call this class library my code library. All right, something very generic. We'll click OK, and yeah, we can save off the changes we made there. Okay, as you can see, this code library only has a class. I could rename this class something like, oh, I don't know, my class. Again, very generic. And here what I'm going to do is create a public function scrape web page as string. All right. It doesn't like the name my class. Let's call it the scrape class. And so then we'll create a scrape web page function. And here what I'm going to do is just start off by using the web client. So we'll go a dim client as new web client. Of course, it won't be able to find it. I'm going to hit Control period on my keyboard to import the system.net namespace. And the next thing I'll do is go dim reply as string equal to client.download string, and we're going to pass in something into the scrape web page function. So we'll go by val, let's go URL as string. So we'll pass that URL into the download string. That should work. And next we're going to do a, I guess we won't do the console.writeLine. We'll just return the string, or actually reply. There we go. And the next thing we're going to do is also go file dot write all text. I happen to know that that's what I need from the system.io namespace. So we're going to import system.io. So write all text, and then we're going to give it a path. So I'll just go ahead and pass in a path. That'll be the second item that we're going to need to pass in, by val path as string. All right, and so let's go ahead and pop those on different lines. And I have to also give it what I want to write. So in this case, we'll write the reply, and then we'll return the reply. So hopefully that will work. Let's go ahead and build the solution. And what I'm going to do is change this from the debug to the release version. So the debug version creates extra code that allows Visual Studio to attach to it. The release version is when I'm finished with my code and I may want to distribute it and use it in other projects, or actually put it on somebody else's computer. So I go ahead and select the release configuration, and then I'm going to choose build solution, and it should build into the release, the /bin/release folder, my code library.dll, as you can see here, and it looks like it succeeded. So what we'll do now is actually create a new project to utilize that class library, and I'm going to call this my client and click OK. And here what we're going to do is actually add a reference to that DLL that I just created. So there's a couple of different ways to do it. I'm actually going to right click and select add reference again, and this time what I want to do is just use the browse feature, and you can see that it found that I currently have this DLL in my users Bob documents Visual Studio 2015 projects, my code library, and so on, because it's under the recent DLLs that I created. But if it wasn't, I'd have to use the browse feature, and I'd have to go and search using this open dialog to find that DLL somewhere on my hard drive, and that's not going to be as pleasant. There's a lot of friction in that experience. This time, just for the sake of illustration, I'll go ahead and use this recent item, but I probably would have to use the browse in order to find that DLL on my hard drive. All right, so let's get started. I'm going to need to create an instance of scrape. So dim my scrape as new scrape, and it doesn't see scrape in the IntelliSense. So clearly I did something, you know what I need to do? Control period. And I need to import the my code library namespace into my module1.vb. Why? Because the default name for my namespace is the name of the project. So I need to import the namespace for the code library I created that contains the scrape class, and then it will be able to see it. All right. So now I have a reference to my scrape and I should be able to do like dim result as string equals my scrape dot scrape web page. There we go. And let's give it a URL and then a path where we want to save the file. So the URL will be http://www.devview.com, and then we'll use for the path C:/. I think I have an example folder where I've been saving some things. Example devview.txt, and that result will come back. I'll do a console.writeLine just to show that we can actually get that string back, and I'll do a console.readLine, and now I have hopefully successfully used the code library that I created in the previous step. So let's go ahead and run the application. Whoa, we got a problem. There's a syntax error where, let's go ahead and add an underscore there. Probably should have done it like this instead. And then we'll add that there. Okay, let's try and run it now. There we go. All right, so we grabbed all the text pretty quick. I'll go ahead and hit enter to finish that. And now let's take a look at the example folder. There should be a devview.txt, and there is, and it has my entire web page. So that's how you can create a library with functionality to scrape web pages off the internet and waste everybody's bandwidth. But at any rate, you can see that it was made pretty easy by the fact that we were able to add a recent item. But what I'd like to do is actually recreate this project really quickly and just show you how to create this project. So we're going to call this the scrape, web scrape, I'll call it. Web scrape, and click OK. And what I'm going to do is I'm going to allow this web scrape project to be the console window application, and then I'm going to add another project to it. So I'm going to go to File, Add a new project, and I'm going to create a class library, which I'm going to call My Code Library. All right, it should put it in the web scrape folder. And here we go. I'm going to call this scrape. And here we'll go public function scrape web page as string. And I tell you what we're going to do. I'm just going to pause the video, copy and paste the code in here from the previous project. So let's go ahead and pause the video now. All right, so you can see that I've got two projects. The code library project will have a class called scrape with my scrape web page functionality in it. And I have a second project that will actually be the consumer of that code library. And here we'll go and utilize it by going, let's go scrape, and I'm going to hit Control period on my keyboard, and it doesn't see it. Well, what we need to do, as you can see, is use one of the options near the bottom, import my code library from my code library. All right. And so that will fix the issue, and it created a reference all in one shot. You can see it added the reference here as well. Very cool. All because it's right inside of the same solution. So let's go and do a dim my scrape equals new scrape, and then we'll go dim result as string equals my scrape dot scrape web page. Here we'll pass in the URL like we did before. Let's grab something different like Microsoft.com, and then we'll save it here C:/example/ Microsoft.txt, and then we will go console.writeLine, passing in result and then console.readline like so. And now let's run the application. And we're able to get back the Microsoft homepage. And if we were to navigate over to our example folder, we have a Microsoft.txt that has the web page in it. Great. Okay, so like I said, in larger projects, it's likely that you want to keep multiple projects into the same solution when they're somehow related. Here we've split up the functionality and created a shared code library, but we were able to access it then from another project whose purpose is to actually do the to call into that code library and then to actually show stuff on screen, save it to a hard drive, all that kind of stuff. But this is the exact scenario where using multiple projects inside of a single solution makes sense. So to recap, in this lesson, we talked about how to create a reference to other parts of the .NET Framework class library if they're not already added in by default, depending on the project template that you've selected. We talked about how to reference other free and open source assemblies that are created by other companies, a group of developers, or even Microsoft has some of their libraries out there on NuGet as well. We looked at how to create our own code library, which we did that for the first time, and then how to access it from our app. And then we looked at a second version of that where we actually created a solution containing both the client and the library in the same solution right here. And we were able to easily make a reference from the client to the code library in just one step by hitting Control period on our keyboard, that quick access step that we got in from IntelliSense, and it did everything for us in one shot. It was very convenient. Okay, so hopefully that's insightful and that helps you to understand how developers really work with splitting out the responsibilities of their application into multiple files for reusability's sake, for maintenance sake, and then also for distribution through other channels like NuGet or whatever the case might be. All right, so hopefully that helps, and we'll continue on and talk about collections in the next lesson. We'll see you there. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. So previously we looked at arrays, which allowed us to keep a sequence or a group of related values all packaged together in the same container, in the same bucket, the analogy I've been using up to this point, the same bucket in the computer's memory. And we created an array by first defining the data type and then the number of items that we hope to store in the array surrounded with parentheses. So if I wanted 5 items, I would do dim something and then use parentheses for as string, and I would be creating an array of strings in that case. And then once we had the data gathered together inside of an array, then we could iterate through the array and perform other operations on all the items in the array, kind of together as a group. But you recall that I said that once I introduced collections, you would see that they were arrays on steroids, and I almost exclusively use collections over arrays unless I absolutely have to. And I think you'll agree that collections are great whenever you're working with all data types, not just simple data types like your strings and integers, but then also with custom classes like the car class that we've been building ourselves. So the .NET Framework class library will use both arrays and collections depending on what it's trying to do, but you're often going to prefer to use collections because of some of the rich filtering, sorting, and aggregation features that it provides through a feature called LINQ, which stands for Language Integrated Query, which is an innovative feature that was added some years ago to Visual Basic and C# for basically this very purpose. If you're familiar with SQL, the what is that? Structured query language, then it's going to look a lot like that, or at least it was structured to look like that. And we'll dive into LINQ in the next lesson. But there are essentially a couple of different collections that we want to take a look at in this lesson. We're going to look at lists and dictionaries. and there's probably a dozen additional types of collections we could look at. Each of them have their own superpowers. They're used for very specific situations. However, I personally feel like if you were to understand lists and dictionaries, you'll use them about 95% of the time. So I'm going to introduce these to you, and then you can go off and learn about the other specialized lists and collections that you can use on your own. So suppose that I have a number of cars on my car lot, and I want to work with all of that data, all of the car objects collectively as a group, as opposed to just storing the data about each one of the objects individually. So to get this set up, what I want to do is actually point you to the code that's associated with this lesson. There will be a before folder, and I want you to copy out the understanding collections as a starting point. And if you're going to follow along, let's go to the projects folder and paste that baby in. And now we can open up that project, and we'll both be in the same place here. Okay. So as you can see, this project has two different classes: a book class, which I created. It has a title, author, and ISBN property, and then a car class, which only has a make and model property for now. And then you can see here that I've already created two instances of car and one instance of book. So we'll be able to start typing our code here in about line 17 or 18. But again, back to the example. Suppose that I want to work with all of these cars collectively and put them in essentially and group them together in a collection or an array. I probably will wind up using a collection because of the reasons that I said earlier. It gives me so many additional options here. So what I want to do is start off by talking about a specific type of collection called an array list. And I want to start by talking about it because it's a lot like an array, but it has some added features that are pretty nice. For example, array lists are dynamically sized, so you don't have to say ahead of time how large you want your array to be. You can also add and remove items really easily using some methods. And the other thing about this particular collection is that it'll allow you to put any data type into it. You don't have to specify that it's a specific type, whether string or integer or car. Of course, that's the downside as well. So let's go ahead and get started by creating a new instance of this array list. So I'm going to go dim my array list as new system.collections.array list. All right, now obviously I used its full name. Apparently I didn't need to because it's already been added to the default collection of namespaces. So I can just hit Control period on my keyboard, and I can choose the simplify name and just go ahead and remove that. And now we're working with the array list without the full name. All right. So now what I may want to do is go my array list dot add car1 and my array list dot add car2. And then what I can do also is do a for each for each item as car in my array list, and I can do console.writeLine and do item dot, and I can print out either the make or the model. Since it's strongly typed and I know what kind it is, I can say, hey, just print out the make for both of the cars in the array list. All right, and you can see that I get the list here. Now, one of the dangerous things about the array list is that it is so flexible. So what we could do with the array list is actually add that instance of book that I created, or actually it's just B1 is the name of it. I can add that to my array list as well. And when I run the application, I'm going to get an invalid cast exception. In other words, you can't convert a book to a car. So on the third iteration through, I try to take the book and say this is actually a car, and it says no it's not, and it won't let me proceed. All right, so I can easily break my application. Let me see if I can do something here and just remove that, and now I'll try to run the application again. Now I get a different exception. I said let's not call this a car, let's just make it an object so that it passes that test we're not going to check whether it's a car or something else. However, when I attempted to access the make property of the book, well, there is no make property of the book. And so I get a different exception, missing member exception. So I guess the moral of the story is that the bad news is you can add anything you want to the array list. It's very accepting, which is both good and bad. Now the good news is that I can honestly remove an item as easily as I can add an item to my array by using the remove method, and now the application works again because we both added but then removed that item from the array list. Okay, so I just wanted to show you what's possible. Now I already noted some downsides about the array list. While it is extremely useful and flexible and probably better than an array, the fact that you can put anything inside of it's kind of a problem. So what we want to do is actually use two better collections. They're called generic collections. They're generic because you have to define the type for the collection to make it specific. So let me go ahead and just type in some code and then I'll explain how this works. We'll use a list of T generic collection. So here we go. Dim my list as list of car equals a new list of car. My list dot add car1. My list add car2. And now we can do a for each in my list. Okay, so this is going to require a little explanation. Let me just make sure it works, and it does. What is this list of car? Well, its formal name is list of T, where T represents a data type, any data type that you want to make it specialized. So in other words, it's a generic collection, but we're making the generic collection specific by saying it can only be a list of cars and nothing else. So you'll remember that I was able to break my application at runtime, but it passed at compile time by adding a book, B1. But this time, we're going to get an error whenever we try to add the book to our generic collection, our list of car, because value of type book cannot be converted to car. All right, so it's better to catch these things while we're doing our software development. And by using a generic list, in this case, a list of car, we're narrowly defining the collection and saying it can only work with cars, so don't try to add anything else to it. Generally speaking, whenever you're working with data in software development, being very restrictive is better than being unrestrictive. Now, some people would disagree with that and say, for example, JavaScript allows you to be very dynamic, but then again, a lot of people shoot themselves in the foot with JavaScript. Whereas with C#, you're going to get those compilation errors ahead of time if you are putting those restrictions on your types up front, okay? And that's what we're doing here. So now let me show you one more type of collection. Generic collection is called a dictionary. And think about a dictionary that you're familiar with, like Webster's dictionary. You have a word that you need a definition for, so you go and you turn the pages until you find the word, and then next to the word is usually a sentence or a paragraph that explain or is associated with that word, okay? And that's the idea of a dictionary. Same thing is true here. You're gonna have a collection that'll have a key. In this case, you know, in the case of the Webster's dictionary, the key would be the term that we're looking up, and then the value would be the definition itself, which would be the sentence or paragraph explaining the key. So we can create that same sort of situation by creating a dictionary. So here we'll go dim my dictionary as new dictionary of car. whoops, I got to give it two things. I have to give it, first of all, T key and then T value. So the type of the key. And so in this case, I'm going to use a string as the key. And then I'm going to give the type of the value, which will be a car. So we're going to give our dictionary, whenever we create a new item in our dictionary, we're going to give it two things. First of all, we'll give it the key, which will be the car, so car1.make, and then we'll give it the actual car1 itself. So now we can find any item, any car in our list of cars by merely using the make. So here we'll go mydictionary.add car2.make and then car2. All right. And so let's go ahead and go console.writeLine, and let's look up my dictionary, and we'll look up I think, what do we have here? We have the geo prism. Okay, so we'll look up the geo, and then we can get to its make or its model, like so. All right, so I can index into the dictionary by supplying the make, which is the key, to get a specific instance of the entire object. All right, so let's go ahead and run the application, and you can see that now we find that the prism is the model because geo is the make. All right, very cool. Now we can attempt to go mydictionary.add, and we can go ahead and give it b1.author as a key, and then attempt to give it the book itself as the actual object that it'll be saving in the dictionary. However, we're going to get an error. The value of type book cannot be converted to car. So while author is a string and it would probably pass, unfortunately, or fortunately rather, the book is not of type car and it cannot be added. So it's restrictive, and that's a good thing because we catch those kind of problems while we're writing our code. Very nice. Okay, so moving on from there, we've got two generic collections we can work with, the list of T and the dictionary of T key, T value. Let's talk about object and collection initializers. So did you remember from before where we did this? Dim names as string equal to, and then I gave it, I think, Eddie and Alex and David, Lee, and Michael. All right, and then we were able to now, in one line of code, both create and initialize our array. Well, you can do the same thing with objects and with collections of objects. So here we'll create a new car. So let's do this. Dim my car as new car. All right. And then I can use the with keyword, and I can just do this. Dot make equals, let's make this a BMW, and then dot model equals 745 Li. Okay? Now I've created a new instance of the car object and populated its properties, all without the use of a constructor like we did previously when we were looking at creating constructor methods. I'm able to create an object and initialize it all in one line of code. Looks very similar to what we did with arrays, right? Very cool. All right, and then to kind of top it all off, I can use the same kind of process to create many instances of car and add them all to a new list of car, all in one line of code. Even though it'll be separated on different lines, it's essentially one instruction that we're passing into Visual Basic. So here we go. Dim my list of cars as new list of car. All right, so that's the first part. Now we're going to use the from keyword, from, and then opening and closing curly braces. And I'm going to go ahead and just make some room for myself here and then use my arrow keys to kind of navigate around. New car with, and here we'll go, make equals Aston Martin, and model equals DB9. Then I'm going to go to the end of that object initializer and go to the next line and create another new car with dot make equals Audi dot model equals the A8, comma, new car with dot make equals a Dodge, and then dot model equals the Dart. Okay. All right, so then at the very end, we'll just go ahead and collapse those last two curly braces. So it can start getting confusing because, you know, what curly brace belongs with what curly brace, but typically what happens is if you select one, you'll see that it's slightly grayed out, and it'll show you its corresponding opening or closing curly brace by giving it a little gray background as well. So whichever one you've got selected, it will show you its corresponding beginning or ending curly brace by highlighting it in light gray color. Okay, but essentially this is one line of code. Now what we can do is we can for each our way through for each item as car in my list of cars. And here we'll go console.write line. We'll just go item.make or model. Actually, we'll do item.model. Let's go ahead and save it and run the application. And you can see there are the three models of cars. And essentially, we were able to, in one line of code, create a new list of car and then create three new car objects and add them in to initialize that collection with new instances of the car object as well, all in one shot. Wow, that's pretty crazy, right? So at any rate, that's all I really wanted to tell you about. Let's recap what we talked about in this lesson. We talked about collections, both generic collections and non-generic collections. We talked about why you want to use a collection, especially a generic collection. Then we talked about the list of T and the dictionary of T key, T value, how to create those, why they're better than just your normal collections, because they enforce types and so they restrict the types that can be used inside of the collection, which means we can catch errors since it's strongly typed at compile time rather at runtime. Then we looked at an object initializer here, and then we looked at a collection initializer here. All right, and next up what we're going to be able to do is use the LINQ extension methods in the LINQ language in order to filter and sort and group our collections. And so that's one of the reasons why you'd want to use collections over arrays whenever you're working with lots of data. And so we'll do that in the next lesson. We'll see you there. Thanks. Hi, I'm Bob Tabor with Developer University. In this video, we'll learn about LINQ, L-I-N-Q, for filtering, sorting, and performing other group-related functions on collections like we just learned about in the previous lesson. So LINQ stands for Language Integrated Query, and it comes in two forms, and we'll look at both of those in this lesson. There's, first of all, the query syntax itself, which resembles SQL, the structured query language. So if you're already familiar with SQL, you will see some similarities and will help your adoption of LINQ. But there's also, in addition to the query syntax, there's a method syntax. So it's just calling a series of methods just like you would any other method, and you can chain those methods together like we learned about previously. Now the only little wrinkle here is that they use a special feature of Visual Basic called lambda expressions, which are these like mini tiny functions that you pass in as a parameter argument into those methods, and that can sometimes bend your mind a little bit if you're not familiar with looking at them. But we'll take a look at them, and I'll try to explain what each of the little lambda expressions do for us. And I'm only going to show a few examples of LINQ in this lesson. Frankly, you could create a whole course just around using LINQ inside of your applications just to demonstrate all the features of LINQ. So it's a pretty extensive topic. To get started for this lesson and introducing LINQ, I want to grab the source code for this lesson from the before folder, and I'm going to copy that and put it into my projects directory. And we'll paste it there. Great. Now let's open that up, and if you take a moment to catch up with me, you will be looking at the same thing I'm looking at right now. As you can see, I have a car class. It has make, model, year, and sticker price, and then I'm creating a new list of car, creating several cars using that object and collection initializer syntax to create 5 cars so that we can start filtering and sorting these cars and displaying them on screen. Okay, so first of all, let's just take a look at how to do a simple query syntax for to find all of the cars that are from BMW. So let's go dim BMWs equals from car in my cars, which is the name of the collection, as you can see here. Then where car.make equals BMW, select car. Okay? And then here what we'll do is just do a for each item as car in BMWs. And we'll just do console.writeLine. And here we'll just make it easy. We'll go use the replacement syntax and just use item.make, item.model, and item.stickerPrice. And we'll go ahead and just format the sticker price. All right, so let's run the application, and we'll see now that we get from our LINQ query only 3 BMWs out of the possible 5 cars on our car lot, and we're also displaying the model and the price. Awesome. Okay, so that's a simple case where we're just looking for and filtering by a single property of the objects inside of our collection. Let's go and make this a little more advanced. In fact, I'm just going to copy the previous example, paste it here, and we're going to say that this is almost identical, but instead of just filtering on one of the properties, I'm going to filter on 2 properties and find those BMWs that were created in the year 2010. All right, so what I want to do is just to add another item here, and we'll go item.year. Okay, and so now let's save it and run it. And we can only find one BMW that is a 2010 model in our list of cars. All right, so by using the AND keyword, we're able to add additional filtering criteria in our LINQ query. All right, so far so good. What if we look for just those newer cars? So let's start off by going dim new cars equals from car in my cars, where the car.year is greater than 2009. Let's just go ahead, first of all, and just select the car itself. And then we'll come back and do this a little bit different the next time through. I'm going to change this from BMW, since we changed the name of the collection we're retrieving back, to new cars. All right. And so let's run the application, and you can see now we get 2 cars back that were newer than 2009. And now let's go one step further and say we only want to select out certain attributes. So instead of select car, let's select just a couple of attributes and put them into a new data type. So car.make and car.model. And those are the only 2 attributes that we're going to use. Now, already you can see that we've got a small issue here. When I added this select new with, it doesn't like it here because I'm no longer working with a collection of cars. I'm working with a collection of something that resembles a car because it has 2 similar properties, but this data type that I'm actually creating here on the fly, it will only have 2 attributes, a make and a model. In other words, I'm creating a new data type. I'm projecting the data from car into a new data type. What's the name of the data type? I have no idea. We're just making it up as we go along. It has no name. It's anonymous. So we're creating or projecting out only a couple of properties from our query into a new anonymous data type, a class that we're creating on the fly that has no name. Now internally, Visual Basic will give it a name. So that's one of the problems here that we see, that we are, instead of working with a collection of cars, we're working with a collection of something called prime A, the little dash in the A. So all you need to know about this is we're just going to remove this as car part here, and it should work. Now, you'll see that we're going to get some more errors. Why? Because this new anonymous data type doesn't have the idea or any definition for a sticker price or a year. So we're going to need to delete those attributes as well. But now that I've done that, whoops. Okay, we got to also remove the replacement syntax here associated with it, and now we can run this. There we go. So I realize that I threw a lot at you in that little code example, but just reason with me here. If I don't need to pull back all of the data, and because I only want to display just a few properties of the data, then selecting the entire object out of the collection and putting it into a new collection might make that new collection just as large as the old collection. So I can be a little bit more savvy about only choosing those attributes that I really need and putting them into a new anonymous type. Now, you may never do this. I just wanted to show you what was possible. All right, so again, this is called projection, and we're projecting into an anonymous type in this example. But there were some ramifications from it. It was a little more complex, and I don't want to throw you too much, so let's just move on from there. And let's talk about, instead of filtering and projection, let's look at how to order, and this will be a simpler example. So ordered cars equals from car in my cars, order by car.year, and then select car. All right. And so let's just call this ordered cars. And then let's also add back in item.year. And let's go ahead, add back in the as car. And let's go ahead and run it. And so we should see a list of all 5 cars. And let's also add back in the display of the year so we can see that. All right, so now we're going in order from the oldest to the newest. So what if I wanted to actually sort them in the opposite fashion? I can order by descending. There we go. And now when we run it, it will start with the newest cars and go to the oldest cars. Great. All right, so we saw a few examples of the query syntax, and I didn't emphasize it at the time, but if you are familiar with the structural query syntax, things are in a little bit different order. Like, for example, in a structural query language syntax, you would see the select first and not last. However, the syntax is close enough that you can easily adapt your thinking to remember it and fumble your way through with the help of IntelliSense. All right, so let's start back over and remake a few of these examples, except not using the query syntax, but rather the method syntax. So here we go. Let's start with just finding all BMWs. So let's go dim BMWs equals my cars dot. So look, we're already using, instead of, we're using methods instead of using a syntax that looks like SQL. So here's where things get a little funky, right? I'm going to have to find all cars that, what was the criteria again here? That are BMW. Okay, so here what I'm going to do is pass in what's called a lambda expression, which is a mini method or a mini function. So I'm going to say the criteria we're going to use for the where clause is I'm going to create a little function and I'm going to pass in each car in my list of cars. And I want you to pass me back those cars where the make is equal to BMW. All right, see how we did that? So again, just think of this as a mini method. I'm not going to give the method a name. I'm just going to say, I'm going to pass you in every car in my list of cars. You pass me back all of the cars that match this function's body, the criteria that I'm defining here, where the make is equal to BMW. All right, and then at that point, we'll be able to then iterate through and look at each of the cars inside of that collection that we're getting back from the where clause. So we're in the application, and we get back all BMWs. All right, so what if I wanted to extend this and say, not only do I want you to give me back all BMWs, but also all BMWs, and we'll do the same sort of thing, where, so I'm just chaining on another method, another where clause here, and I'm going to pass in another little lambda expression, another little mini method. So function, and I'm going to pass you back, of all the cars that were passed back whenever we eliminated some from being just BMWs, now we're going to further refine that, and we're going to pass in each of those cars into this little mini function and say only return back those cars where the year is 2010. All right, so we're going to filter the original list, and then we're going to filter the list that came out of that, and then return back that list, and then we're going to iterate through each of the items. I think there's only one item that meets that criteria, a 2010 550i. Okay, great. All right, so now let's take a look at the ordering of cars. So let's go dim ordered cars equals my cars dot order by descending. So there's a whole method just for order by. We'll start off with the order by or order by descending. So here again, I'm going to say I'm going to pass in a little mini method to tell you what I want to order each car by, and I'm going to want you to order it by the year. All right, so let's go ahead and change this to ordered cars. And furthermore, I think we can, print out the year. Great. All right, so we've ordered them from oldest to newest, and then we can do the order by descending to create from newest to oldest. Great. Now, I personally prefer the method syntax. Once you get past what a lambda expression really is, once you can like rectify that in your mind, and you can look at examples online for help for a given LINQ extension method, which are these wheres and orders and order by. Those are extension methods that are added onto collections by the LINQ functionality. Then I think it's the easier syntax, frankly. And you can do some interesting things with a little bit less code. So one of the things that I want to show is, in fact, let's go ahead and comment that out. you can perform operations on the entire group as a whole. So say, for example, I wanted to get the total of all the cars on my car lot, their total value. So I might do something like this, dim the sum, and I'll go my cars dot, and notice here that there's a sum method, and I'm going to say, and give it one of the many functions, passing in every car from the list of cars. I'm going to say sum it by the car sticker price. So go through every car and add up the sticker price and then return back the total amount for me. And here we'll go console.writeLine, and we'll put in the sum, and here we'll say total value and 0C to format it like currency. And the total value of all the cars on my car lot are $250,000. Cool. Let's take a look at some of the other method syntax options that we have. So for example, we can aggregate items. We can get an average of, for example, each car's value. We can cast or convert each object from one type to another. We can get we can find out if an item exists in our collection, and we can find the first item or the last item. We can do the for each, which will be pretty cool. We can group by items just like we could in SQL. We can get the max and the min. We can do even complex unions between two data sets. So it can get pretty hairy, but let me just show you one other thing just so you're aware of it. I want to use the for each, and what I want to do is actually take every car and add $10,000. We're going to have the opposite of a sale. So instead of a function, I'm going to pass in a sub because I don't want anything to be returned back. I just want to operate on each item inside of each item that we pass in. So each car in my cars, I want to take the car and add $10,000 to the sticker price. And let me do this. So sticker price, let's do plus equals 10,000. All right, and then let's go ahead and print out and get a sum of all the cars, and then print that out here. And let's see what we come up with. There we go. All right, so there we go. We have increased the value of our car lot by 50,000. Why? Because we've added 10,000 to each of the individual cars. In fact, I could even make this a little bit shorter by just going here with the total value. Let's just go mycars.sum. We can do it right here in line. And function car, and inside of that, we'll do car.stickerprice. All right, so we're able to reduce that down to 2 lines of code, but I'll bet you I could even reduce this down to 1 line of code. Let's do inside of this, we can get pretty silly here and do sticker price plus 10,000. Let's see if that'll work. Here, I'm gonna get rid of that. And it's not a permanent change, but we're able to do it all in 1 line of code. You can see how crazy this gets. Let's go ahead and split that up into multiple lines here, just so you can kind of see it all. Not even sure what the right way to be split that out, but there you go. So we can get pretty crazy with this and do some really interesting things, all in a very compact syntax. It makes your code less readable, but you can do some powerful querying, filtering, sorting, and also group operations on your data with using LINQ, both the query syntax and the method syntax. All right. So that's really all I wanted to show you in this lesson. Let's continue on. If you're still with me, you're doing great. Follow along and then go ahead and do some experiments and even search for LINQ Visual Basic examples online or on Microsoft.com. Okay? So we'll see you in the next lesson. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, I'm going to introduce a new decision statement in Visual Basic. The if and the conditional, the IIF methods work great with a limited number of use cases, but when you begin to evaluate many potential cases and you need to branch off in one of, 10 or a dozen or 24 different directions, then the if and especially the IIF method, they start to become cumbersome. They're very wordy and they're very flexible and powerful, but it might be overkill for that particular situation. And I'll show you an example here in just a moment of where it makes sense maybe to use a new decision statement called the select case. But first, I want to talk about a special data type called enum, and specifically, what I said earlier with regards to working with data as a programmer. You typically want to restrict the values or restrict the kind of data that can be stored in a variable or any kind of data that you're working with. So admittedly, we're already limiting the kind of data that you can store in a variable given its data type, right? But even within the data type, I might want to limit the possibilities to just a few options, a few possible values. So typically, again, in software development, you want to limit and constrain your data to ensure its validity and its usefulness within the software system. So an enumeration or an enum is a data type that limits and constrains all possible values to only those that are valid for our application. So we may want to keep track, for example, of a series of to-do items. We might be creating a to-do app, and each to-do item could be represented by an instance of this to-do class, as you can see here in my Understanding Enumerations project. So, we might want to keep track also of the current status of an item, and maybe it should only be one of several different statuses, like maybe not started or in progress or on hold or completed. Now, as I'm going through and I'm developing my application, I certainly could use a string and then start comparing strings against each other. But the problem with strings is that you can potentially mistype a string. And so especially if it's going to be input by an end user, there might be some fat fingering, or they may not spell it correctly, or you within your own software development efforts, you might not have typed it correctly in one spot and subtly introduced a little bug whenever you're checking to see, if my to-do dot status equals not started, something like that. In this case, as it's represented right now, you might miss the fact that you are missing a T there, and this would never get executed. So you typically don't want to work with strings when you're doing comparisons. These are often called magic strings because they hold values, and because of the flexibility of a string, it can hold any value. But it might not make sense in our application, and so you typically want to constrain values, not use strings for purposes like this. Anything like maybe a title or a description, sure, use a string because you want that to be any potential value. But a status, you want to limit statuses to only a few possible statuses because you might be doing some business logic based on the current status, right? So an enumeration will help us by eliminating all of the possible values to just a few possibilities. So in this case, what I could do is to actually create a public enum and call it to-do status. And then I'll just type the possible values for a to-do status. So here we'll go not started, and you can't put spaces in between these. I might be able to use a dash or an underscore, but I'll just go ahead and use camel casing. In progress, on hold, completed, or deleted. And those are the only options for to-do status. Now I'm going to change the status of my to-do class from a string to type to-do status. And notice that this is almost like a data type in and of itself. I can use it as a data type for my variables or my properties inside of a class. However, it's constrained and it can only be certain values. Now notice that behind the scenes, not started is equal to 0, in progress equals 1, on hold equals 2. So if we were to save this to a file or save this into a database, what would be stored in the database is 0, 1, 2, 3, or 4 in the case of deleted. So it's 0 based, and each of these options have a value from 0, in this case, to 4. However, when it's being used here in our application, we can do something a little safer than what we currently are doing now. We could do to-do status dot, and we can only select one of these items from the list of possible enumerated values. So now I can do a safe comparison and see does my to-do status equal to-do status, and you can see here in IntelliSense the options, not started. Okay, and in that case, now these types, they're strongly typed. I know that it can only be one of these 5 statuses, and it can never be something else, and I can never fat finger it, because at runtime or at compile time, it'll do that type checking and make sure that if we come up with something crazy like something crazy, or we just were to type it incorrectly, we're not even going to be able to run the application. It's not going to build. It's going to give us a compilation error because something crazy is not a member of the to-do status enumeration. Okay, so hopefully that makes sense. Enumerations are used all over the place in the .NET framework. For example, the console window or the console class has a foreground color, and you can set that to one of several different enumerated values defined in an enumeration called console color. So I could make this, for example, dark red, and then whatever I type in, so console.writeLine, and we'll say hello world, and then console.readLine, it'll be limited to just those colors. You can see hello world, very dark red, just those colors defined in the console color enumeration. All right. So again, enumerations are a very good thing whenever you're working with data because it limits the possible values. Let's go ahead and create another quick example here, working with a different data type instead of to-do items. Let's work with superheroes and create a little application that allows us to see for a given superhero what their nickname is. And so I'm going to add another class to my existing project, and I'm going to call that class superhero. And in the superhero class, actually I'm not going to make it a class. I'm going to actually just make this an enumeration. So I'll just make variables of type superhero, not an entire class. So to change a class into an enumeration, you just change the word from class to enum, and then you start typing the names of superheroes like Batman, Superman, Green Lantern, and so on. Okay. And then here in our main program, what we'll do is ask the user to type in a superhero's name to see his nickname. And we'll go console.readLine, and we'll set that into a user value as string equals console.readLine. Okay, so now we have the user value, and what I can do is attempt to compare that to one of the possible values here. So I'm just going to do an if statement to begin with, but we'll come back and we'll replace this with something a little superior to an if statement. So if user value equals, we could just use magic strings, right? And say if it equals Batman, then console.writeLine, Caped Crusader or Dark Knight or one of the other nicknames Batman has. All right, but we don't want to do it this way. Again, because we don't want to work with magic strings, we want to work with enumerations instead. And so there's going to be a little bit of a disconnect because whenever we get content from the user, we're going to have to try and convert that into one of the enumerations. And if it doesn't convert, then we're going to need to let the user know that there's an issue. So what we're going to do is use this if superhero dot, and then we're going to do this try parse method of our enum, and I'm going to give it the user value that was typed in, and I'm going to try to let's look at the second version of this. Yeah, I'm going to ignore the case, and then I'm going to attempt to convert that into a into my value. Now I haven't created my value yet. Let's go ahead and dim my value as superhero. Okay, so what we're going to attempt to do is take the user value that they typed in, and we're going to try and parse that string that they type in into a type of superhero. And if we can do that successfully, then we'll go ahead, we'll go if my value equals superhero dot Batman, then console dot writeLine Caped Crusader, else if my value equals superhero dot Superman, then console dot writeLine Man of Steel, else if my value equals superhero dot Green Lantern, then console writeLine Emerald Knight, I believe. All right. And I think it's complaining because it wants things on separate lines like this. And if. All right, and then console.readline. And so let's run the application. And we'll type in a superhero's name, and I'll just say Batman, and it types out Caped Crusader. Now, obviously, I don't have a lot of checking here because if I put in Wonder Woman, I'll get nothing because we're just skipping over this. We were not able to successfully parse what the user typed in and convert it to one of the enumerated values. All right. And this is not that great of an example, admittedly, because we're allowing the user to type in and then we're having to attempt to convert it. But I just wanted to show that concept of how you would do it. The to-do example is probably something you're going to find more often because you'll have complete control of the data, and you may want to present the data options to the user in some sort of either selection, select 1 for Superman, 2 for Batman, or some drop-down list box in a web-based interface or in a Windows user interface, whatever the case might be. But let's go ahead and just leave this the way that it is for now. And what I want to do is come back to this example in just a little bit because I'm going to pair this up with the new, with a new type of decision statement. Instead of using the if, we'll try something else which will be a little bit more elegant than what we did here. All right, so I wanted to introduce a new decision statement, the select case statement. You know, the if then else if, else, end if. It's really powerful. You can do a lot of really cool things with it. However, if you need to do something simple, it can sometimes be overkill. Here's an example of something you can do which with the if statement that is actually pretty interesting. So I'm going to show you a complex if statement example. And you should be able to find that in the code folder wherever you're currently watching this video. And so, as you can see here, I can do some interesting things like use ORs inside of my if statements to look for ranges of things. So in this case, if the value that the user types in is less than 1 or greater than 100, I can give some specific feedback that the option that they chose was out of the normal boundaries. Now, if they select specific numbers, 42 or 23 or anything greater than 90, then we can give them a message that you found one of the special numbers. Otherwise, you didn't find one of the special numbers. So we can get pretty complex using the or and the and, like we saw at the very outset when we were looking at various operators. And here, let's just choose like 86. You know, you didn't find one of the special numbers, but if I type in 23, you found one of the special numbers. Okay, very simple example, but you can see that with an if statement, you can get very complex and test a lot of different cases. Let's close that down and close that out. What I want to do, however, is create a new project. So let's save what we have here in Understanding Enumerations. And we'll go File, New Project, and we're going to create one called Understanding Select Case. And let's create a similar example to what we did before, except we're not going to use enumerations this time around. So console.writeLine, and then type in a superhero's name to see his nickname. All right, and then let's go dim user value, a string equals console.readline. And then now we're going to use select case. And I'm just going to hit select tab, and you can see the format of a select case statement. And so what we'll do is evaluate this user value. And in order to make sure that we are comparing apples to apples, I'm going to call the toUpper function like so. So that, and here I'm going to hit tab, we can select and check for Batman, for example, or for Superman, for example, and I could continue to add additional cases, like Green Lantern. All right. Now here I can just do, you know, the console.writeLine and type in caped Crusader, console.writeLine, Man of Steel, console.writeLine, Emerald Knight. All right, and then the case else, we could just say console.writeLine, not found. Okay. And then here we'll do the console.readline, and that should end the program. So now let's run the application. And yes, admittedly, we are using magic strings, but you can see the elegance of and how quickly we were able to create a select case statement. Whoops, couldn't find it because I didn't type it correctly. See, therein lies one of the problems. But how quickly I was able to create a select case statement as opposed to using the if, else if, else, end if statement. All right. So at any rate, now let me do this. Let's combine these two ideas together, the select case, our enumerations. So let me close this project down and reopen up the previous project that we had, the Understanding Enumerations. And I want to take a different tact than we did here. And I'm going to comment all that out. In fact, I'm just going to push it down here below. Whoops, I'm going to actually use that. And so we'll go select, tab, We want to check my value tab. Here we're going to go superhero dot Superman, superhero dot Batman. We'll go another case, superhero dot Green Lantern. All right. And here we would go the console.writeLine, or I can just do something like a little bit easier. We'll just do dim result string, and then we'll do result equals Superman, or we could just do steel result equals Caped Crusader, result equals Green Lantern. All right, so then finally, let's just go ahead and go here at the bottom, console.writeLine result, and we should get the same results. Batman. All right, so it's a little tidier. You can see there's just a little bit less code involved than if we do the else if my value equals each time. And so for simple cases, this will suffice. We could also just put everything here on one line to even make it more compact by using that line ending character, the colon, so we can keep it real nice and tight like that. But at any rate, you can see how they're used together then in these situations. Okay, so that's really all that I wanted to demonstrate here. We talked about the value of enumerations to limit and constrain the kind of data or the amount of data that can be assigned to a given property. We looked at a couple of examples of that. Then we looked at how we were able to utilize the select case as opposed to the if statement in those situations where we just want to evaluate one particular value against a number of potential cases, as we saw here, and then take some action, some simple action based on that. It's a little less verbose than the if statement, if, else, and so on. And we looked at some complex if statements and a few other things like try parse, which allows us to attempt to, in this particular case, take a string that the user typed in and find a match for it in our enumerations. If it returns true that we did find a match, then we'll execute this code. But if it didn't find a match, it'll just skip over the entire, all the logic that we wrote inside of that code block. Okay, so doing great. Let's continue. See you in the next video. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devview.com. In this lesson, we're going to talk about handling exceptions that occur within our applications. We're going to discuss what can go wrong, why things go wrong, and how to build resilient applications that are impervious to crashing through the use of the try, catch, and try block in Visual Basic. So whenever the compiler catches a data type mismatch, an unresolved reference to a class, or some malformed Visual Basic instruction, it will refuse to compile your source code into a .NET assembly until you fix the problem. We've already seen this happen a number of times. We'll usually get the red squiggly line, we'll get the error list pop up. Those are called compilation errors, and those are good because we can catch those and fix them before we release the application to others, right? But there are other kinds of errors that happen only during runtime. In other words, they happen when the compiled .NET assembly is actually in the act of executing on somebody else's computer. So there are countless reasons why this could occur, but many times it occurs due to situations that are outside of the control of the software developer. For example, if you're creating an application that cannot read or write to the disk for some reason. Maybe it's because there's a folder or a file that's missing, or the file is corrupt, or because the network access to that resource is unavailable, or perhaps your application attempts to connect to a database and that particular table in the database that you were relying on is no longer there. Maybe the columns have changed names. Maybe the structure in general has changed. These and many more could cause your application essentially to crater, to experience an exception at runtime. Now, in some cases, the developer may not have foreseen a problem and therefore didn't account for it. For example, maybe the developer allows the users to type in their country, but the user misspells the country name, and as a result, we can't find a matching country, and we have bad data in our database as a result. Or perhaps the user is maliciously trying to break the application. Maybe they type in numbers instead of alphanumeric characters or alpha characters. So as a software developer, your job is to make sure that you account for every possibility, everything that could potentially go wrong with your application. A friend of mine was fond of saying that 80% of all code exists to solve 20% of all potential problems that can happen. So generally, software developers should be pessimistic about the reliability of any input into the program, especially input that's human in nature. Somebody types in a value and hits enter. Be suspicious about that value because it probably is wrong. It's probably not what you need. It's not what you need to accept, and you need to be, test it to make sure, is this really valid information that I can use in my application? So if you rely on a file or a network resource, treat it with great suspicion because it may not be there. If you rely on a user to type data into the application, treat that as absolutely evil. All right, you have to be very suspicious about anything you cannot absolutely control in your application. And this is the software developer's equivalent to defensive driving. You should always code defensively. So the way that a Visual Basic developer codes defensively is through the use of the try and catch and end try statements in Visual Basic, which we're going to demonstrate in this lesson. So let me give you a quick example of the kind of things that can go wrong. Here we'll create a quick example in our new project, Gracefully Handling Exceptions, and I'm just going to go dim content as string equals, and we'll use the file. We've used this once before. I'm going to go ahead and hit Control period on my keyboard and import the system.io namespace. File.read all lines, or read all text. That's what I want. Read all text. And if you recall, we had a path that we created earlier when we were going through the My Namespace project. We created a folder called test, and there was a test1.txt, and let's go ahead and write that out to our console window, and we'll just do that. And now let's run the application. Now in this particular case, I know that that file is there and the folder name is there, all right? But what if, for example, we were to either fat finger the name of the folder or the file name, and what if we didn't account for that possibility that that folder, the test folder, and that file, test1.txt, does not exist on our hard drive? Well, at that point then, what the developer sees when running in Visual Studio is this little nice message that says the directory is not found, or a directory not found exception was unhandled. So it will create a data type of an instance of a data type called the directory not found exception, and that object will have information about the exception that we encountered. And it will tell us and give us information about the issue, couldn't find the directory. Okay, so as a developer, I can see this and I can fix the issue. However, as an end user, you're not going to see this. You're going to see something much more ugly. And let me just go ahead and quickly build this. And then I'm going to open up our projects, go to Gracefully Handling Exceptions, and look in the bin directory and run the application. And this is what a user would see. They're going to get this ugly error message that says gracefully handling exceptions has stopped working. A problem has caused the program to stop working correctly. Windows will close it and notify you if a solution is available. And then it gives you all that error message stuff in the background, right? So it's a pretty ugly situation for your end users. You want to make sure that whenever you release the application to an end user that you are accounting for all the potential problems so that they never see that ugly error message pop up. All right. What we can do to kind of mitigate this is to take into account in our application anything that we don't have absolutely complete control over. Now we have control over writing lines to screens and reading lines. Okay, that's not the issue. What the issue here is attempting to access a resource that we as programmers do not have access to, or may not have complete access or control over. So in those cases, what we may want to do is to wrap a try around our code that could potentially be an issue. Now I deleted a little bit here, but I'm going to go ahead and put it back in and just leave it the way that it is. And I'm also going to just take this dim content as string, and I'm going to move it outside of the try catch. Put it right here, and then just do content equals, all right. And now I'm going to run the application again, and this time, well, we don't get any error messages at all, but we don't get any results either because we know that there was an issue. All right, so we can improve this by giving a little bit of feedback, and that's what the catch is for. What we can do at a minimum is just go console.writeLine. There was a problem, and this is the bare minimum. We'll run the application. At the very least, we'll get the message, this was a problem. So we tried to execute this code in this code block, but we encountered an exception, and as a result of that, I executed this code block, okay? And then we could continue on, and at least the application didn't die. I think we can improve this a little bit more, though, by telling the end user what the problem actually was. So let's go ahead and then use this error object, or this exception object, that has been returned back to us. So like I said before, whenever an exception happens, the .NET Runtime will create an instance of an exception object. An exception is kind of the grandfather of all exception related issues. We'll look at some others in just a moment. And so unless we specify a more specific exception, it will always roll up to this exception object. We can take a look at the properties of the exception object, things like the inner exception, the source, the message. And so let me just use the message and display that then to the end user. Now, in a real application, I might choose to log that exception into a log file so that we can diagnose the problem. Maybe I'll even take that message and send it, if I can, to a database where I, as a developer, can look at all the exceptions that have been thrown by the various users across all the users of my application, and be able to proactively find bugs and fix them. All right, but in this case, all we're going to do is just report the message of the exception to the end user whenever we encounter it. All right, so at least we're giving some feedback here. Could not find a part of the path. And so if a very savvy user looked at this and said, oh, I wonder if that exists on my file system, and they go and look for tests, and they're like, oh, there's no tests directory. Maybe I need to change the name of my directory, or maybe I need to report this error. Okay. I think we can even improve this a little bit more. And if we were to take a look at this read all text method, and I hover my mouse cursor over it, notice that it gives me a list of potential exceptions in below this, all right? So there's an argument exception, there's argument null exception, path too long exception, directory not found exception, IO exception. And if we wanted to learn more about these, we could just do, actually copy this, and then go and open up our browser, and in MSDN I might go site microsoft.com and then just paste in file.readAllText. That should bring me to the MSDN article for that particular method. And let's see. Yeah, here we go. Let's click on this version of it. There were two versions of that method, an overloaded version. And this will show me how the method is declared. But the most important part of this are the arguments, the list of potential exceptions rather that can be thrown from this and why they would be thrown. So for example, file not found exception. The reason why this happens is the file specified in the path was not found. Maybe the file is in an invalid format. Maybe the user doesn't have the required permission. Maybe there was some sort of issue when attempting to open the file. Maybe the disk is corrupted. Maybe the directory was not found, or it was inaccessible. Or maybe we just didn't pass in the right argument. So there's a lot of possible exceptions here. And as I'm looking through and understanding how to call this method, I can then account for some of these possibilities. So instead of catching just an exception, what I can do is this. Catch ex as, and then here I'll go directory not found exception. And then we'll go console.writeLine, and I can give a very specific message here. There was, let's say, we could not locate the C:/tests directory. Please ensure that it exists. All right, so now we're giving very specific feedback to the end user by checking for the most specific exceptions first and then the most generic or general exceptions last. Let's go one step further from this. If we found the directory but we didn't find the file, so here we go, catch ex as file not found exception. Console.writeLine could not find, locate the file test1.txt in the directory C:/tests. Please make sure the file exists. All right, so it's a little bit more specific here. Now what happens when I run the application? Well, the directory not found error is going to fire first because it's going to first of all look for the directory before it attempts to look for the file itself. But now let's go ahead and modify the contents of our C drive here. Well, actually, let's do this. We don't have to modify anything there. We'll change this to test, and then we'll just change this to test4. That file does not exist. I'll go ahead and make the appropriate modifications here inside of the text. All right. Just to make sure that everything looks correct. Okay. So now we've got the directory correct, but we're looking for a file that I know does not exist. And this time, we're going to give a descriptive error, could not locate the file test4.txt in the directory C:/test. Please make sure that that file exists. All right, very cool. So the key here is to look for the most specific exceptions first and then the most general exceptions last, or catch them in the order in which we know that they'll be performed. We begin by catching the most specific, which was the fact that we couldn't even find the directory, and then we move on and say, okay, well, next up, can we find the file itself? No. Well, if it's not that, then it could be one of a number of other issues, as we see here as we hover our mouse cursor over, but we'll just not account for those necessarily. We'll just say there was an issue, all right, and let the user figure it out on his own. Alternatively, we could go and implement a catch for every single one of those potential exceptions. Now, the last thing that I can do here is, it's not really necessary in this case, but I'm going to add a finally statement. And so here you want to add any code that should execute no matter what. So, for example, maybe you need to close database connections so that you're not, you don't have a lock on a database file, or close file connections for the same reason, because you don't want to keep a lock on a file so that another application can't access it. Maybe you want to clean up any work that you've done previously and just make sure that it's adequately destroyed. Maybe you want to set your values and maybe set content equals something like no data found, maybe something like that. Let's see what that will do. All right, so there we go. Not only do we print the error message, but then finally we'll always execute no matter what. Of course, that might be a problem if we actually did find the data. So that might not be the best one. Maybe it's something like maybe to do an if statement. So console.write if content.length equals 0, then no data found, otherwise just print out the content. I'm just doing this off the top of my head. Hopefully it'll work. So let's try that. All right, so that case it works. Let's see if we move this to test 3. All right, it didn't print it in that case. Oh, it did. It actually printed it a second time. So maybe we just need to put nothing in that particular case. All right, that would probably be the better course of action. So there you go. We just get it printed one time instead of twice. All right, very good. So as we look at the entire structure of this try, catch, finally, end try block, on the surface, it might seem to make sense to you to just wrap your entire application in a try-catch. And frankly, that's a little bit on the lazy side. Some developers have done that in the past, but they often will be ostracized by their end users because you wind up doing something very cryptic like we did here, where we just create a general exception because we're not taking the time to understand all the specific exceptions that can pop up. And we just say, there was a problem here, you figure it out. All right, that's not advocating for the end user. And typically, whenever you do something like this, you're going to be printing out messages that the .NET framework will generate. They're intended to be understood by developers, not end users. And so you'll see some error message that no normal human would be expected to understand, except for the guy who actually wrote the application. So the reasons that developers do that and sometimes take that approach where they just wrap an entire method in a try-catch is because they leave the exception handling to the very end of the software development process. And that leads to this catch-all situation where you're just like, oh, we're pretty much done with the app. I just need to wrap everything in a try-catch. And just it's a lazy approach to just slapping some code up at the problem and hoping that it takes care of it. But in the meantime, when users run into issues, it's maddening for them and very frustrating. And I'm sure you've been there and you've seen those maddening error messages before and you have no idea what to do next. You want to try to avoid that as a software developer. Take pride in your code. Take the time to understand the kinds of exceptions that can happen. Ask yourself when you type in code, what am I relying on here? What are the potential problems that could pop up, and account for them the way that I've done here in these. But then also be reasonable. You don't have to implement every single exception. The ones that are probably the most likely to happen are the ones you want to catch. All right? So you should strive to put the same amount of attention into protecting your user from having to guess what to do next or how to fix a problem. If you, the developer, can fix the problem, then and the end user doesn't even have to know about it, then awesome. That's what you should do. But if you can't, well, then at least identify the exact problem like we've done here in these lines of code, and then tell the user what they could do to try to diagnose the problem on their own, and at least you'll help them from not feeling stupid. The worst thing you can do is make a user feel like they've done something wrong or that they feel dumb whenever they're using your application. That's what makes your application polished, and it's what users expect. A reliable experience, no surprises, tell them what they need to know in order to self-diagnose and fix problems. All right, so to recap in this lesson, we've talked about defensive coding through the use of the try, catch, and finally an end try statements, and the plan for how to plan for the inevitable problems that will pop up during the execution of your application. We talked about handling the special cases first and then moving on to any general cases last. And we talked about the mindset of the conscientious developer who seeks to advocate and protect the end user from maybe losing data or even having to make tough choices or feeling dumb and not knowing what you're supposed to do next with your application. So using that catch-all strategy and just trying to wrapping it around everything, like just only using this catch EX as an exception and nothing else. That's not an ideal, it's not a perfect solution, and you should strive to examine every part of your application that relies on some exterior resource that is not directly in your control as a developer. And then apply the try-catch, finally, judiciously in those parts of your application. So you see here that I'm not wrapping it around the write line and the read line because I'm not expecting those parts of my application to fail, all right? Only those parts that rely on something that I cannot control. All right, awesome. We're making great progress. And if you're still hanging in there with me, you're doing great. I'm so proud of you. We're almost to the end. Don't give up now. We're almost there. So see you in the next lesson. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devview.com. In this final tutorial video, we're going to be discussing event-driven programming. Event-driven programming is really at the heart of most of Microsoft's presentation APIs, whether you're building web or Windows applications. And for that matter, it's at the heart of just about every other API in the .NET Framework class library. Events allow you, the developer, to plug in and respond by handling key moments or key events in the life cycle of an application's execution. So up to this point in our simple Windows console applications, there's really been only one event that occurs, the application startup event, which in turn triggers the sub main inside of our module 1, where we wrote the majority of our code in this course. However, in a modern user interface, whether it be a native Windows application or a web-based application, users can interact with various elements on a screen, whether it be buttons or text boxes. They can move their mouse cursor around and hover over elements. They can press keys on the keyboard. They can type text into text fields. They can drag and drop various elements around the user interface, and so on. And so a software developer will write code that responds to those interactions that they want to enable. So a given component, let's say a button, it might define an event. Let's say it's the click event for a given button, but it may have other events too, like hover over or drag over. But let's say we're only going to consider the click button event. The developer says, I want to write code that performs this business logic whenever somebody clicks on that button. And whenever that button's event, that click event is raised, then I want to handle that event, write code that will respond to that event. So the developer creates a method and attaches it or registers it with that event and says, hey, whenever you happen, let me know, because I'd love to run some code whenever that button gets clicked. All right, so as the application is running, the user interacts with the application. Eventually they click that button. The .NET Framework runtime raises the event and notifies any methods that were asked to be notified, and it would then execute that code as well that's attached to the event. And I'm going to show you how events are used in a very, very simple Windows application near the end of this lesson. But first I want to start with the absolute basics, and I'm going to create a timer example. And the great thing about a timer is that it has an elapsed event. So you give it how many milliseconds you want to run before it says, I finished elapsing, I finished elapsing, I finished elapsing. All right, so it'll keep doing that until you tell it to stop. And so what we're going to do is write code that'll say, whenever you finish elapsing, I want to know about it, because I'm going to write some code and we're going to do something interesting like write something to a console window. All right, so let's go ahead and get started here by creating a new project called Understanding Events. And inside of the submain, what we'll do is start by creating a new system.timers.timer. and I'm going to call it, so dim timer as system.timers.timer. And I'm going to pass in how many milliseconds I want it to run between each elapsed event that it will raise. All right. So in this case, I want, let's see, new keyword. I want 1,000 milliseconds or 1 millisecond to elapse between each raised elapse event. Okay. So what we could actually do is simplify this, right, by hitting Control period and just simplify the name, selecting that option. Actually simplify, I could actually add an import statement, but hopefully you get the idea. Okay, let's continue on. Next, what I want to do is attach to the elapsed event or register a handler for the elapsed event. So here's what I'll do. We're going to go and use the add handler keyword. We use the name of the timer and then the event that we want to handle, so elapsed, comma, and then what I want to do is give it the address of a method in the computer's memory. Okay, so methods have a spot in memory, and we want to say, hey, whenever the elapsed event happens, I want you to add a handler and then call out to that event in this address in the system's memory. So here we're going to just create something called module1 dot, and we'll give it a name. Let's just call elapsed 1, or tell you what, handle the timer 1. All right. And then I'm going to hit Control period on my keyboard, and one of the options is to generate a method called module1.handleTheTimer1. And notice that we created a method stub, a private sub, handleTheTimer1, and notice that it automatically creates the correct method signature for the event. So it's going to send two things to us. It's going to send the object that created the event, and then it will give us additional arguments that we can take a look at. And one of those arguments will be something that will actually print off the screen. Now, because it's generated code, it adds this throw new not implemented exception. Let's go ahead and get rid of that because we don't need it right now. Instead, let's do this. Let's go console.writeLine. And then inside of here, we will do handle the timer 1 event, and then I'm going to put in the hour, minute, second, and millisecond when the event was signaled, or when the event was raised. So we're going to use the signal time. All right. So the next thing we'll need to do, now that we've wired up our event to occur whenever the timer elapses after 1,000 milliseconds, now what we'll do is simply go timer.start, and we'll just keep running until somebody hits the console.read line and hits enter on the keyboard, and then we'll go timer.stop, and then we'll just exit out of the program. All right, so let's see how this works. Run the application. All right, and so you can see every second, 47, 48, 49, 50, 51, we are hitting our handle the timer 1 event. Now what I can also do is wire up additional event handlers. In fact, I can have 2, 5, 10 different event handlers that say, hey, let me know too whenever you raise. All right, not just that guy, I want to know too. So you can add multiple event handlers for every single event. And to demonstrate this, let's just do this. Add handler timer.elapsed. And this time we'll go address of module1 dot handle the timer 2. I'll hit Control period on the keyboard to generate the method handle the timer 2, and it adds it right here. And I'll just copy what we did here, and I'll paste it here. except I'm going to rename this so we can clearly see it, handle the timer 2. So let's run it, and now we're going to get, every second we will get 2 entries. 52, 53, 54, 55, 56 for handle the timer 1 and 2. And we could keep adding additional handlers for the elapsed event of the timer if we wanted to. Now, what I can also do, which is kind of interesting, here, let me write this. Console.writeLine, whoops, writeLine, press enter to stop handling both, or stop raising, or stop, handling the event twice. All right, we'll just say that. And then here what I'll do is just go timer.start and console.readline and timer.stop. And then in between here what I'll do is do this. Instead of add handler, we'll remove, remove handler timer.elapsed. And this will do the exact opposite. This will say, hey, I have this method that we're currently calling, whenever we hit the elapsed, I want to stop calling it. Just unregister it, and it's no longer going to be used as a handler for our elapsed event. So here, let's watch how this works. So I can press enter to stop handling the event twice, and right now I'm adding 2 entries every second. So I'll hit enter, and now we're back to only handling the event once. Okay? All right, so I say all of that to say this. I wanted to show you how to respond to events, how events work, and the various parts of an event. An object will declare and raise an event, and then we as developers can attach our code or add handlers to the various events that are raised by objects, and then write any custom code that we want to in response to those events. We can also say, no longer do I want my handler to handle that event. Instead, I just want to remove it so it's no longer listening for that event. All right. So events are central to every type of app that you'll build. I think I said that already. And to demonstrate this, what I want to do is build a really simple Hello World application using the Windows Presentation Foundation API to build Windows applications. So let's do this. I'm going to go File, New, Project, and we're just going to call this WPF Events. I'm going to select a WPF application. That's important, all right? And I'm going to call this WPF Events. All righty. And what I want to do, and I'm not really prepared to talk about WPF. There will be entire courses on Microsoft Virtual Academy that will explain what you need to know about it, but all I really want to do here is just drag and drop a button, and then drag and drop a label, or actually a text block. That would be better. Let's put a text block right below it. Okay. I'm going to select the button, and I might change its content and say, click me. All right. And then in the text block, I might change the text and remove it, just make it empty by default, but I want to rename it to my text block. And I'll rename the button as well to my button, something memorable. All right. All right. Now the next thing that I want to do is come over here to the properties window, and I want to make sure that I have the button selected on the design surface that I dragged and dropped from my toolbox. And here I'm going to select the little electric lightning bolts thingy over here on the right hand side, and this will show me all the available events for an object. In this case, make sure it says my button, type button, and then you'll see all of the events that this button can handle. You see, wow, there's a ton of events. Yeah, many of these you'll probably never ever need or use, but the one that you'll always use is the click event. So what I'm going to do is just inside of this little white area here, I'm going to double click. And when I do, notice that it adds a my button underscore click event. All right, and here I could write my label or my text block, in fact, sorry, dot text equals hello world. And so let's run the application. And we're just going to click the Click Me button, and notice it says Hello World. Now, you might say, well, this wasn't very satisfying because I don't see anything similar to what we did previously. Where did it actually wire up the relationship between the button and the click event my button underscore click? Well, let's do this. I'm just going to go and select the form itself. So the entire window, all right, just the entire visual area. In fact, I'm going to make sure to select just outside of that, because if you select just the inner part, it'll be a grid that's used for layout purposes. I want to select just outside of it and make sure that the word window is visible. Then I want to go down to initialized, and I want to make sure to double click it so it creates this window initialized handler. And then what I'm going to do inside of there is go ahead and do add handler my button dot click comma address of, and then we're going to go main window dot, and we'll give it a name, handle the event one, just like we called it before. I'm going to hit Control period on my keyboard and select generate the method handle the event one. All right, and we'll have to do something a little bit funky here, so just stick with me. Private shared, let's just call this result as string. All right, and then here I'm going to need to put set result equals string dot format, and then here we'll go happened at, and then HH minutes, seconds, and milliseconds, and we'll pass in date dot now. All right, let's see if that works. And then what I'll do is show the result in here. All right, let's see if that works. All right, and you can see it works. Now, the first time you click it, nothing will happen, because the very first time you click it, the result will be an empty string, but then every subsequent time, the handle the event one will have fired second, and it will be populated with values, okay? Now what we could do is just make it happen one time, and then we could do something like this: remove handler, my button dot click, address of, module one, or I'm sorry, main window dot handle the event one. See if that'll work. It doesn't work. We'll have to put that someplace else. Maybe here after the very first time. There we go. That should work. So let's run it. And now the first time we click it, nothing happens. The second time we click it, nothing happens. But then every subsequent time, it does not change the date, or rather the time. Why? Because after we run through this block of code once, we've removed this handler, so it never updates the string result. Okay? So hopefully that's as clear as mud. There are some things there. Hopefully, I know that it probably didn't make a lot of sense with regards to dragging and dropping items and modifying them and using the properties window. But at a high level, just understand that everything in .NET is event driven, and so events are what move the action of the application forward. And here we were just handling an event that's wired up automatically for us through the beauty of the Visual Studio IDE, but we can take control of adding and removing events to, or event handlers to specific events ourselves by using the add handler and remove handler keywords and pointing them to the address of methods that we implement in our source code. All right. So hopefully that's the one of the main takeaways. The main takeaway really is that events are everywhere you look, and that if you can dream up an action that you want your application to respond to, your first thought should be, what event should the application be responding to? What should I be handling as the developer? And then you do your research at MSDN, Microsoft.com to find the specific events for the given objects that you have in your web page or on your Windows form, and then you implement those using techniques that I demonstrated here. Okay. So that pretty much wraps up all of the instruction content